प्रोफेसर आर वाला सुब्रमण्यम सर पद्मश्री इंडियन मैथमेटिकल सोसाइटी का व्याख्यान था, लेकिन किसी परिस्थिति वश उनकी तबीयत थोड़ी ठीक नहीं है तो उनको रिशेड्यूल कर दिया गया है और कल उनका व्याख्यान इसी हॉल में किया जाएगा 9:30 बजे से। इस रिशेड्यूलिंग के बाद आज के जो प्रमुख वक्ता हैं खान न्यास के संयोजक हमारे सामने उपस्थित हैं। राष्ट्रीय व अंतर्राष्ट्रीय स्तर पर इनकी पहचान वैदिक मैथमेटिक्स के रूप में जानी जाती है और वैदिक मैथमेटिक्स के लिए प्रमुख जो इनका कंट्रीब्यूशन पूरे देश में काफ़ी लोकप्रिय है और माननीय राज्यपाल महोदय ने कल इस संदर्भ में वैदिक मैथमेटिक्स के लिए स्कूल के सिलेबस या महाविद्यालय के सिलेबस में भी अंकित करने की बात की चर्चाएं की है। और श्री रामचंद्र जी जो हैं तो उन्होंने प्रेजेंटेशन भी संभवतः गवर्नर हाउस में किया है सिलेबस के संदर्भ में। ग्रेजुएशन के सिलेबस में नालंदा ओपन विश्वविद्यालय और पूरे बिहार के विश्वविद्यालय में लागू हो चुका है। वैदिक मैथमेटिक्स को इंट्रोड्यूस किया जा रहा है और किए जाने वाला है दोनों। तो बहुत बड़ी वैदिक मैथमेटिक्स की कंट्रीब्यूशन आज से प्राचीन काल में जो भी गणनाएं की जाती थी बहुत सरल तरीका से, जो हम लोग बहुत समय लगता था उसको बहुत न्यून समय में, तो इस संदर्भ में मैं श्री राम चौथाई वाले सर को आमंत्रित करते हैं कि हम सभी को वैदिक मैथमेटिक्स में जो भी कंट्रीब्यूशन किया गया है उस संदर्भ में हम सभी को अवगत कराते हैं। तो आमंत्रित करते हैं श्री राम चौथाई वाले सर को इस संदर्भ में हम सभी को अवगत कराएं। थैंक यू सर।
आज के सभा में उपस्थित इस विद्यापीठ के सम्मानीय कुलपति महोदय जी और सभी प्रतिष्ठित वक्तागण और विद्यार्थी बंधुगण, मैं हिंदी और इंग्लिश दोनों मिक्स में बात करूँगा क्योंकि मेरी स्लाइड सारी इंग्लिश में है। बीच बीच में थोड़ा हिंदी थोड़ा इंग्लिश इस प्रकार से बात करेंगे। हम सब जानते हैं कि आज की जो राष्ट्रीय नई शिक्षा नीति अभी आ गई है, उसका इम्प्लीमेंटेशन भी शुरू हो गया है। तो उस शिक्षा नीति में एक विषय पर पहले से ज़्यादा एम्फोसिस है, वो विषय है इंडियन नॉलेज सिस्टम या भारतीय ज्ञान परंपरा। सारे विषय में वो सब्जेक्ट एक मूलभूत रूप में आएगा और सारे विद्यापीठों ने और सारे स्कूल और एनसीईआरटी सारी यंत्रणा इस विषय पर विशेष रूप से काम कर रही है। मेरा थोड़ा सौभाग्य ऐसा रहा कि ये सारे विषय में मैं पहले से ही थोड़ा सा इस विषय का मैथमेटिक्स के लेक्चर होने के साथ भी जब कभी मैं कॉलेज में पढ़ाता था तब भी मैंने भारतीय गणित के इतिहास पर अभ्यास प्रारंभ किया और मेरा जो पीएचडी है वो भी भारतीय गणित के इतिहास के विषय के संबंध में है। तो उसी विषय को आज मैं आपके सामने थोड़ा संक्षेप में रखना चाहता हूँ। हमारे यहाँ दो प्रकार की ज्ञान की परंपरा मानी जाती है। एक को कहते हैं पराविद्या और दूसरे को कहते हैं अपराविद्या। ये जो नॉलेज इन भारतीय सिस्टम इज क्लासिफाइड इनटू टू टाइप्स, नेमली paravidya and aparavidya. This paravidya includes the knowledge about philosophy, Brahma, consciousness, Atma, self, Purush, Kshetrajna, etc. etc. So it relates with philosophical point of view. लेकिन जो अपराविद्या होती है वो अपराविद्या is different from paravidya and which includes the knowledge about earth, water, fire, air, space, mind, intellect, ego, etc. इसलिए this अपराविद्या includes the knowledge about nature, engineering, architecture, sculpture, handicrafts, science of warfare, music, law, political science, economics, astronomy, astrology. ये इतने सारे विषय मैंने यहाँ पर आपके सामने इसलिए पढ़े हैं कि एक बार ये सारे विषयों में कॉमन है एंड दैट कॉमन फैक्टर, और अपनी भाषा में कहना तो लीस्ट कॉमन फैक्टर सारे विषयों का मैथमेटिक्स है। तो हमारे यहाँ बहुत पहले से ऐसी सोच विद्यमान है भारतीय ज्ञान परंपरा में कि गणित एक ऐसा विषय है कि जो सारे ही विषयों को अपने प्रभाव में लाता है। इसलिए बहुत प्राचीन काल से कितना गणित प्राचीन है हमारा, इसका एक ही वाक्य में उत्तर देना है तो हम ये कह सकते हैं कि जितने वेद पुराने हैं उतना हमारा गणित पुराना है। यानी ऐसा नहीं हुआ कि पहले वेद की संहिता तैयार हुई बाद में गणित आया, ऐसा नहीं हुआ है। तो वेद की रचना होने के साथ साथ ही हमारे यहाँ गणित का भी शिक्षा या गणित का भी अभ्यास प्रारंभ हुआ। इसके प्रमाण ऋग्वेद में बहुत मिलते हैं। यदि ऋग्वेद में हमें संख्याओं का प्रमाण मिलता है, एक मेधातिथि नाम का ऋषि है, द नेम इज मेधातिथि, उसका एक सूक्त है ऋग्वेद में, और वो सूक्तों में एकम, दहम, शतम ऐसा करके वो डेसिमल सिस्टम का उल्लेख करता है ऋग्वेद में। वो जाता है परार्ध तक, यानी अप टू 10 to the power 12। तो ये जो एक्सैक्ट एविडेंस है कि ऋग्वेद में यदि संख्याओं का इस प्रकार का डेसिमल सिस्टम का संहिता में उल्लेख है, संहिता का मतलब होता है जब ऋग्वेद का लेखन हुआ या उसको स्मृति में लाया गया, तब यदि ये सिस्टम विद्यमान थी, इसका मतलब है कि वेद की संहिता तैयार करने वाले लोग भी इस प्रकार के सिस्टम को जानते थे। उसी प्रकार हमें से बहुत लोग रुद्र का अध्याय जानते हैं, हम पढ़ते भी होंगे, बहुत बार सुना भी होगा पूजा के समय। उसके आखिरी का जो सूक्त है, यानी चैप्टर अपनी भाषा में कहा जाता है, तो उसमें वो मांग रहे हैं कि मुझे शिव भगवान ने ये देना चाहिए, वो देना चाहिए, ये देना चाहिए। तो आखिरी में वो संख्याओं को मांग रहे हैं, एकाचमे, त्रिशचमे, पंचचमे, सप्तचमे, इस प्रकार की संख्याओं को मांग रहे हैं। तो संख्याओं का जो हमारे मानवीय जीवन में महत्व है वो बहुत पहले से उन्होंने जाना था। इसीलिए वेद के जो 6 अंग हमारे माने जाते हैं, उसका एक अंग है कल्प। जैसा बाकी 6 अंग है, उसमें से एक अंग यानी लिम्स ऑफ वेद पुरुष जिसको कहा जाता है, उसका नाम है कल्प। तो कल्प का एक भाग आता है, उसका नाम है शुल्ब सूत्र। शुल्ब का अर्थ होता है रोप या स्ट्रिंग। ये हमारा सबसे प्राचीन अवेलेबल मैथमेटिक्स का ग्रंथ है। यदि किसने पूछा कि हमारे भारतीय परंपरा में गणित का पहला ग्रंथ कौन सा है, व्हाट इज द फर्स्ट बुक विच इज सोलली ऑन मैथमेटिक्स, नथिंग, नो फिलोसॉफी, नो धर्म, नो पूजा, नथिंग, ओनली मैथमेटिक्स, प्योर मैथमेटिक्स। तो ये बौधायन शुल्ब सूत्र के नाम से जाना जाता है, और ये बौधायन शुल्ब सूत्र का ग्रंथ ज्योमेट्री का है। ज्योमेट्री का ग्रंथ होने के कारण उसका उपयोग उस समय और आज भी जब यज्ञ किया जाता है, उसमें जो वेदियाँ तैयार होती है, वेद भूमि तैयार होती है, कोई खाम वगैरह तैयार होते हैं, उसकी विधिवत उसकी विधि है, वो किस प्रकार से करना, उस सारे विधियों का गणित वो ग्रंथ में है। वो कहते ही है पहली श्लोक में वो कहते हैं कि ये ग्रंथ लिखने का प्रयोजन ही है, यही है कि यज्ञ विधि के लिए सारी रचनाएं, सारे कंस्ट्रक्शंस को करना। और उसमें एक राइडर भी है, यदि वो कंस्ट्रक्शंस ठीक नहीं होती है तो वो यज्ञ सफल नहीं होगा। इसलिए बहुत मेटिक्यूलसली वो कंस्ट्रक्शंस का विचार ज्योमेट्री का किया गया है। उसका नाम है बौधायन शिल्प सूत्र। तो पहला ग्रंथ गणित का हमारे परंपरा में बौधायन शिल्प सूत्र माना जाता है। उसी प्रकार बहुत सारे ग्रंथों में गणित के उल्लेख मिलते हैं। मैं थोड़ा सा अपना समय की मर्यादा में थोड़ा फास्ट उसको ये करूँगा। अब इम्पोर्टेंस ऑफ मैथमेटिक्स, जैसा मैंने कहा, पहले दिन से हमें इसकी पहचान थी। हमारे यहाँ ईसा पूर्व 1400 साल, यानी 1400 ईयर्स बैक, यानी आज से कम 3500 साल पूर्व, 3500 ईयर बैक, एटलीस्ट फ्रॉम टुडे, one book is available in the name of Maharshi Lagadha, and that the name of the book is Vedanga Jyotish. It is a book on astronomy. That's right. वो एस्ट्रोनॉमी का पहला ग्रंथ माना जाता है। लेकिन वो एस्ट्रोनॉमी का जो विचार करते हैं वो ग्रंथ में, तो एस्ट्रोलॉजी नहीं, फल ज्योतिष नहीं, खगोल, हमारे दो पार्ट है, एक एस्ट्रोलॉजी है, एक एस्ट्रोनॉमी है। ये एस्ट्रोनॉमी वाला ग्रंथ है। उसमें वो गणित की प्रशंसा करते समय कहते हैं, वो श्लोक आपके स्क्रीन पर मैं इसलिए सबको पढ़ के दिखा रहा हूँ। यथा शिखा मयूराणाम नागानाम मणयो यथा तद्वद वेदांग शास्त्राणाम गणितम मूर्धनि स्थितम। And as the crest of heads of the peacock, as the gems on the heads of the snakes are recognized for the richness, glory, beauty and bliss, so is the Ganita at the top of all Vedanga sciences. यानी हमारी जो सोच थी, थॉट प्रोसेस उस समय से था, वो सोचते थे कि गणित इज एट द टॉप ऑफ ऑल वेदांग शास्त्र। सिमिलरली एक और इंस्टेंसेस गणित प्रशंसा का हमें मिलता है, वो थोड़ा सा आगे वाला है। 850 AD महावीराचार्य नाम के हमारे भारत में एक बहुत बड़े गणित तज्ञ हो गए। ये महावीराचार्य जैन महावीराचार्य से भिन्न है, नाम यदि सेम है लेकिन वो महावीर ही नाम था उनका। वो उन्होंने अपने पहले 2-3 अध्याय में गणित की प्रशंसा का एक छोटा सा प्रकरण लिखा है कि गणित कहाँ पर इम्पॉर्टेंट है। मैं इसलिए बता रहा हूँ कि हमारी भारतीय सोच क्या थी उस सब्जेक्ट को देखने के लिए। और वो उन्होंने 32 सब्जेक्ट्स की एक लिस्ट बनाई कि कहाँ कहाँ पर गणित का उपयोग आवश्यक है या गणित के एप्लीकेशंस हमारे मानवीय जीवन में आते हैं। उसमें से कुछ सब्जेक्ट्स मैं आपके सामने पढ़ता हूँ। साइंस, म्यूजिक, इकोनॉमिक्स, प्रोसीडिंग यानी छंद शास्त्र जिसको कहा जाता है, ड्रामेटर्जी यानी नाट्य शास्त्र, डाइटेटिक्स अन्न के विषय में, मेडिसिन, साइंस ऑफ इक्लिप्सेस ग्रहण शास्त्र एंड साइंस ऑफ परफ्यूम्स। दिस इज वेरी इंटरेस्टिंग, साइंस ऑफ परफ्यूम्स, गंध शास्त्र। वराहमिहिर का जो किताब है, वराहमिहिर के किताब में इस नाम से एक चैप्टर है, बृहद संहिता। बहुत बड़ा ग्रंथ, बृहद सही अर्थ में बहुत बड़ा ग्रंथ है। बृहद शब्द ही उसके ग्रंथ के नाम में ही बृहद है, बहुत बड़ा ग्रंथ है। उसमें एक चैप्टर है गंध युक्ति, यानी प्रिपरेशन ऑफ परफ्यूम्स। जब वो कहते हैं कि गंध किस प्रकार से बनाए जा सकते हैं, तो उस समय वो मैथमेटिकल मॉडल्स का उपयोग करते हैं विषय रखने के लिए। कहीं मैजिक स्क्वायर का उपयोग किया, कहीं परम्यूटेशन कॉम्बिनेशंस का यूज़ किया। तो इस प्रकार से ये सभी शास्त्रों में महावीराचार्य के अनुसार जीवन से जुड़े हुए सभी शास्त्रों में गणित का बहुत बड़ा प्रयोग होता है। इसलिए वो कहते हैं कि बहुत ज़्यादा बात क्या करना है, बहुभिः विप्रलापैः किं यत् किंचित वस्तु तत्सर्वं गणितेन विना नहीं। यानी हमारी बिल्कुल पहले दिन से भारतीयों के मन में गणित का जो एक विशेष महत्व था, वो ये सारे इन घटनाओं से पता चलता है। आज के मेरे भाषण का विषय लेकिन गणित का सोच नहीं है। मैंने कुछ जितने भी हमारे यहाँ गणित रत्न हुए हमारी परंपरा में, हमारे वैदिक परंपरा में, उनमें से कुछ नोटेबल कॉन्ट्रीब्यूशंस आपके सामने रखने का मैं प्रयास करूंगा। 4-5 ही डिसिप्लिन्स मैंने उसके लिए चुने हैं। उसके एक अरिथमेटिक, अलजेब्रा, ज्योमेट्री, ये तो हम सब जानते हैं कि वी आर द ओरिजिनेटर ऑफ डिसिप्लिन्स। मैंने उसके लिए चुने हैं। उसके एक अरिथमेटिक, अलजेब्रा, ज्योमेट्री, ये तो हम सब जानते हैं कि वी आर द ओरिजिनेटर ऑफ अलजेब्रा भी इंडियन ओरिजिन है। द यूज ऑफ लेटर्स फॉर द नंबर्स, ये जो बेसिक आइडिया है अलजेब्रा की, उसका प्रथम प्रयोग पूरे वर्ल्ड हिस्ट्री में भारत में मिलता है। ये मैंने प्राउड फीलिंग का तो एक भाग है ही, लेकिन मैं कोई उसको एक्सप्लोरेशन नहीं कर रहा हूँ, मैं ऐसा ज़्यादा की बात नहीं कर रहा हूँ। ये वस्तुस्थिति है, सारी दुनिया वो मानती है। उसी प्रकार ज्योमेट्री के बारे में तो मैंने बता दिया, वो ग्रंथ ही ज्योमेट्री का था। चौथा जो डिसिप्लिन था वो आपको सबको शायद आश्चर्य होगा, वो था ट्रिग्नोमेट्री। लेकिन ट्रिग्नोमेट्री आजकल उसको त्रिकोणमिति कहते हैं, ट्रिग्नोमेट्री शब्द का भाषांतर हो गया। हमारे यहाँ ट्रिग्नोमेट्री शब्द नहीं था, हमारे यहाँ शब्द था ज्यामिति। ज्या का अर्थ होता है आज की भाषा में हमारा साइन थीटा फंक्शन। ज्या का मतलब होता है साइन फंक्शन। तो ज्यामिति है द कैलकुलेशंस विद रिस्पेक्ट टू द साइन फंक्शन। और भास्कराचार्य के जो सिद्धांत शिरोमणि नाम का ग्रंथ है, उसमें एक स्वतंत्र चैप्टर ये ज्यामिति का है, यानी ट्रिग्नोमेट्री वाला है। और जो ट्रिग्नोमेट्री आज हम पढ़ते हैं उसमें 6 फंक्शंस यूज करते हैं, साइन थीटा, कॉस थीटा, टैन थीटा और उसके रेसिप्रोकल। कि बिना ट्रिग्नोमेट्री एस्ट्रोनॉमी संभव नहीं था। और एस्ट्रोनॉमी का स्टडी करना है, स्पेस में जाके कुछ विचार करना है, तो 2 प्रकार की ट्रिग्नोमेट्री, सो प्लेन ट्रिग्नोमेट्री एंड स्फीयरिकल ट्रिग्नोमेट्री, दोनों का ही उद्गम या पहला विचार। बाद में अब शास्त्र बहुत आगे बढ़ गए, इसमें कोई शंका नहीं है, लेकिन उसका पहला विचार हमारे यहाँ हो। उस प्रकार से दूसरा सब्जेक्ट जो था वो है इंटरपोलेशंस का, जिसको भारतीय भाषा में अंतर्वेशन शब्द है। एक साइन टेबल आर्यभट्ट ने तैयार किया। मैं अभी नालंदा में आर्यभट्ट जी का नाम लेना ही चाहिए मुझे। आर्यभट्ट का नाम लेना लिए बिना तो ये व्याख्यान पूरा ही नहीं होगा। आर्यभट्ट वाज द फर्स्ट टू से द साइन टेबल, यानी साइन ऑफ दिस इज दिस वैल्यू, साइन ऑफ दैट इज दैट, पूरा टेबल 24 वैल्यूज आर देयर इन द टेबल। Out of the 24 values, if anybody wants to get a value in between 2 angles, and 30 की वैल्यू मालूम है और 40 मालूम है, sin 30 is given in the table, sin 40 is given in the table. Now, if I want to find any value between sin 30 and 40, what is the solution or what is the rule? That is what we used to apply in the regular interpolation techniques. Same interpolation techniques which we used to do under a heading Newton's law and many more things. All those techniques were previously used by Aryabhatta and all other. Aryabhatta was a great mathematician, great astronomer. That is the only reason why our first जो हमने सैटेलाइट छोड़ा था इंडिया ने, उसका नाम दिया था आर्यभट्ट 1। कारण ही उसका था Aryabhatta was a very famous mathematician and astronomer. Again I repeat, astronomer, not astrologer. भविष्य कहने वाले नहीं थे वो, एस्ट्रोनॉमर थे। और वो पहली बार आर्यभट्ट ने दुनिया को चंद्र ग्रहण क्यों होता है, सूर्य ग्रहण क्यों होता है, उसके कारण क्या होते हैं, तात्कालिक गति क्या होते हैं, इंस्टेंटेनियस वेलोसिटी क्या होती है, एस्केप वेलोसिटी। इवन एस्केप वेलोसिटी हम सब जानते हैं कि पृथ्वी के गुरुत्वाकर्षण के बाहर यदि किसी को जाना है तो एक विशिष्ट वेलोसिटी से, विशिष्ट एंगल से जाना पड़ेगा, नहीं तो पृथ्वी के ग्रेविटी के कारण वो नीचे आ जाएगी बॉडी। तो उसको एस्केप वेलोसिटी, हम साइंस वाले तो जानते हैं ये कंसेप्ट। ये एस्केप वेलोसिटी का भी सोच पहली बार आर्यभट्ट ने किया था जमीन पर बैठकर कि कितनी वेलोसिटी लगेगी एक आधे वस्तु को पृथ्वी के गुरुत्वाकर्षण क्षेत्र के बाहर फेंकना है। तो इसके कारण फिर वो सैटेलाइट जब हमने छोड़ा तब उसको नाम आर्यभट्ट 1 दिया। बाद में आर्यभट्ट 2 इसलिए दिया कि 1-2 नहीं था, एक दूसरे आर्यभट्ट हमारे यहाँ हुए। बाद में भास्कर 1 दिया तीसरे सैटेलाइट को नाम। भास्कर 1 वॉज वन ऑफ द मोस्ट फेमस एस्ट्रोनॉमर ऑफ इंडिया। चौथे सैटेलाइट को नाम दिया भास्कर 2, इसका कारण वो भास्कराचार्य जो फेमस है लीलावती के कारण, उनका भी नाम दिया। और भास्कराचार्य का नाम सैटेलाइट को देने का कारण मैं आपको बताता हूँ। उनके ग्रंथ में एक प्रश्न है, आपको आश्चर्य होगा, वो प्रश्न सुनकर भी आश्चर्य, मुझे तो पहली बार इतना आश्चर्य हुआ कि उनके दिमाग में प्रश्न आया ही क्यों पहले। वो प्रश्न पूछते हैं कि एखादा मनुष्य यदि चांद पे खड़ा हो गया, रिमेंबर भास्कराचार्य टाइम इज 1150 AD, 1150 साल में भास्कराचार्य सोच रहा है चांद पर जाने के लिए। 1971 आया हमें प्रत्यक्ष मनुष्य चांद पर उतरने के लिए, लेकिन 1150 में प्रश्न पूछ रहा है कि एक आदमी यदि चांद पर खड़ा होता है तो वहाँ खड़ा होने के बाद वहाँ उसे पृथ्वी कहाँ दिखेगी और कैसी दिखेगी। नॉट ओनली कहाँ दिखेगी, कहाँ मीन्स लोकेशन, 3 डायमेंशनल लोकेशन, और कैसी दिखेगी, व्हाट विल बी द कलर ऑफ द एटमॉस्फेयर और व्हाट आर द एलिमेंट्स अवेलेबल इन दैट एटमॉस्फेयर। और आपको सुनकर ये आश्चर्य होगा कि भास्कराचार्य ने उसका प्रश्न नहीं किया, केवल खड़ा किया, जो उसका उत्तर दिया है कहाँ पे दिखेगी। तो नेचुरल, अब आज का बच्चा भी जानता है कहाँ दिखेगी। वो आप किसी को पूछेंगे कि यदि मैं चांद पे खड़ा हो गया तो मुझे पृथ्वी कहाँ दिखेगी, तो आज का बच्चा भी बोलेगा चांद की स्पेस में दिखेगा। दैट इज अ सिंपल आंसर कि चांद का जो स्पेस होगा, जैसे हम पृथ्वी पे खड़े हैं जमीन पर, हमारे स्पेस में चांद दिखता है, सेम थिंग विल हैपन। आज का छोटा बच्चा भी आंसर दे सकता है, लेकिन ये 1150 में ये सोच रहा है। और आपको ये हमें एक बात और बहुत आश्चर्यजनक लगी, जब नील आर्मस्ट्रॉन्ग चांद पे खड़ा हो गया, उसको भी वही प्रश्न पूछा गया था अर्थ से, हाउ यू फाइंड, वेयर यू फाइंड द अर्थ एंड हाउ इज द अर्थ लुकिंग। उसका जो उत्तर था, आर्मस्ट्रॉन्ग तो साइंटिस्ट था, एकदम प्योर साइंटिस्ट, उसका जो उत्तर था और जो भास्कराचार्य ने अपनी प्रतिभा से या अपने अभ्यास से जो उत्तर दिया था, उसमें 91% करेक्टनेस है। थोड़ी बातें जो आर्मस्ट्रॉन्ग ने कही और भास्कराचार्य ने कही, तो प्रामाणिकता से कबूल करना चाहिए कि थोड़ी बातें थोड़ा थोड़ा गलत है, लेकिन उस समय भी इस प्रकार से हम सोचते थे कि ट्रिग्नोमेट्री के बारे में। और दूसरा और इम्पॉर्टेंट एरिया, द मोस्ट इम्पॉर्टेंट एरिया वेयर India's contributed a lot is the area of infinite series. थोड़ा सा उसके contributions के बारे में हम सोचेंगे। पहला डेसिमल सिस्टम, निगेटिव नंबर वगैरह सब हमको मालूम है, इसलिए मैंने उस एस्केप किया है। बाद में कमेंट ऑफ आइंस्टाइन आता है इसके बारे में, वो हम सब जानते हैं, लेकिन मैं उसको रिपीट करता हूँ। आइंस्टाइन अपने बायोग्राफी में लिखते हैं कि वी ओ ए लॉट टू इंडियंस who taught us how to count, without which no worthwhile scientific discovery could have been made. तो मुझे उसकी ट्रांसलेशन करने की जरूरत नहीं है, एकदम सादा कमेंट है। बहुत बार हमें ऐसा लगता है कि, और हमें पढ़ाया भी जाता है हमारे अभ्यासक्रम में, कि ठीक है भाई, आपने नेचुरल नंबर्स अपनी भाषा में जिसको कहते हैं नेचुरल नंबर्स का विचार किया, यू थॉट ऑफ नेचुरल नंबर, यू थॉट ऑफ रैशनल नंबर्स इवन, बट Indians don't have the knowledge of irrational numbers, what we used to call in our regular syllabus. But that is again a false thing, not true, not fit to the historical events. भास्कराचार्य अपने ग्रंथ में 6 operations on sets, करणी षड्विधम, करणी का अर्थ होता है सर्ड या स्क्वायर रूट, करणी षड्विधम नाम का एक प्रकरण भास्कराचार्य के ग्रंथ में, दुर्भाग्य से हमारे सिलेबस में प्रकरण नहीं है, इसलिए हमें पता नहीं रहता है कि भास्कराचार्य ने पहले रैशनल नंबर के 6 ऑपरेशंस के बारे में सोचा था। वो 6 ऑपरेशंस थे एडिशन, सब्ट्रैक्शन, मल्टीप्लिकेशन, डिवीजन, हम सब जानते हैं। स्क्वायर ऑफ ए सर्ड एक्सप्रेशन इज ए स्लाइटली न्यू थिंग, बट द मोस्ट important thing in those 6 operations is square root of a surd expression. प्रॉब्लम देखने से हमें पता चलेगा कि भास्कराचार्य किस प्रकार का प्रॉब्लम सॉल्व कर रहा है। ये देखो, एक्सप्रेशन है 13 प्लस रूट 48 प्लस रूट 60 प्लस रूट 20 प्लस रूट 44 प्लस रूट 32 एंड प्लस रूट 24। ये एक्सप्रेशन दिया है श्लोक में। श्लोक का यदि हम ट्रांसलेशन करते तो ये एक्सप्रेशन निकलता है। What is the problem is? Problem is to find the square root of this e value. It is a difficult problem. We are all mathematicians. We can understand that this is really not that easy as to square root of a number. दिस इज द स्क्वायर रूट ऑफ द सरल एक्सप्रेशन। और हमारे यहाँ जैसा यहाँ √60 है तो √60 है, √20 है, तो हमारे यहाँ कभी भी 2√5 इस प्रकार से नहीं लिखा गया। हम आज जो हम 2√5, 3√2 ऐसा लिखते हैं, दैट सिस्टम इज कमिंग फ्रॉम द वेस्टर्न। हमारे यहाँ भारतीय ग्रंथों में सभी स्क्वायर रूट डायरेक्टली लिखे गए थे, लेकिन इस प्रकार के एक्सप्रेशन को स्क्वायर रूट निकालना, ये इज ए टफ प्रॉब्लम। आई स्टडी, आई ट्राइड इट and I know it is a tough problem. Tough problem in two sense. The first and important thing, it is not every time that the square root of this type of expression exists. So भास्कराचार्य उस समय भी existence condition का विचार करता है। आज ये fairly new approach है गणित में existence condition भास्कराचार्य की तुलना में। उस समय भी वो he first state when the square root of this type of expression exists, and after satisfying that condition of existence, he then deliberated on the methods of finding the square root of this expression, and that is one of the significant contribution as per my knowledge to the algebra, and unfortunately again not included in the syllabus, nowhere in the syllabus, not in the school level, not in the even college level. So we fairly know about it. Then second, we all know about the sequences, arithmetic progression, geometric, etc. Indians were very expert in finding the rules for sequences and series also. What was the significant contribution in that area is to find, or a formula given by one Sridhar Acharya for the first time, 750 AD. In his book named Pati Ganit. Pati means Anka Ganit. Pati Ganit means a book on arithmetic. What was the formula for the first time given? Formula is for sum of squares of first n terms of arithmetic progression. Sum of squares of natural numbers हमें पता है, 1 square plus 2 square plus 3 square, we know the formula. But the formula given there in the book is not 1 square plus 2 square, but it reads t1 square plus t2 square plus t3 square up to tn square, where t1, t2 are the terms in arithmetic progression. Same formula is later extended for sum of cubes of n terms in AP. So these two results, again not in the syllabus. I am aware of the syllabus, you are all aware of the syllabus. I never find these two results, sum of squares of n terms of arithmetic progression, terms in arithmetic progression, and sum of cubes. Later we know how to find 1 raised to p plus 2 raised to p, 3 raised to p. That idea we know because that depends on what we call as Bernoulli number. We know that idea. But these two results are the very significant contribution. Starting of taking the powers of sums of the terms in arithmetic progression is again an Indian idea. And lastly in this is that what concept is called Vara Sankalitam. Vara Sankalitam is sum of sums of terms. We know sum of sums of n terms of natural number. That formula is our syllabus, n into n plus 1 to n plus 1 upon 6. All know. What this Narayan Pandit has done is he goes one step forward. After finding the first sum, then he starts finding the second sum. You can observe on the screen. The first sum is 1 up to 5. Then 1 plus 3, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, etc. Then third order sum, then fourth order, and then fifth order. This extension of the formula of sum of sums of natural numbers and similarly sum of sums for arithmetic progression. I have taken one example, 2, 7, 12, 17, 22. We can find the sum by routine formula. But then he applied the same technique, 2 plus 7, 9, 9 plus 12, 21, etc. to fifth order, sixth order. And finally, he gives two important results which are called mth order Varasankalitam or mth order sum of sums of natural number. I have written that formula in a regular notation only because we can understand it very easily. N into 1 up to n plus n is the numerator divided by factorial m plus 1. This formula is again a unique contribution from Indian side to the theory of sequences. This is sum of sums of natural number. Similarly, sums of mth order sum of sums when terms are in AP. That formula is again given by Narayan Pandit. I'm not sure how many of you have even heard the name Narayan Pandit and a mathematician. He was a mathematician after Bhaskaracharya. Many times we think that, okay, Bhaskaracharya, starting from Aryabhatta say 499 AD up to Bhaskaracharya say 1150 AD. I can say galaxy of mathematicians available. But after Bhaskaracharya, straight away we jump to Ramanujan. And a 1150 AD to directly 19th century. In between those 800 years, from Bhaskaracharya to Ramanujan, there are again many mathematicians. One of the major mathematicians is this Narayan Pandit, who contributed a lot. The contribution of Narayan Pandit not stops at the Varasankaritham. Even he thought of Fibonacci sequences. We all know Fibonacci sequences, sum of previous two numbers and the sum is carried out. Now a branch Fibonacci mathematics is available after that discovery by Fibonacci. Of course, Fibonacci discovered his idea before Narayan Pandit. That is also in a historical sequence. But what Narayan Pandit did, I don't know whether he knows about the Fibonacci or not. Possibly not. Even if you know about the Fibonacci sequence, what he did, he extend the idea of Fibonacci sequence to n sums. N sums means today we used to call Tribonacci, Tetranacci. These are just 19th century concepts. If you Google it, Tribonacci, Tetranacci type of sequence, you will find that they are just 1900 something. The terms even they are not available. Tribonacci, Tribonacci, Pentanacci, N-Nacci. Now, what this fellow Narayan Pandit did in 1356 AD is, he has given a formula for constructing n-Nacci sequences आज की भाषा में. उस समय तो उन्होंने n-Nacci sequence नहीं कहा है. आज की समझने की भाषा में n-Nacci sequences means if I start with 0 0, then sum of n terms, selected n terms will be the next. Then again selected n terms will be the next number. And not only that, he promoted the idea. He has given the application of this Fibonacci sequence, n-Nacci sequences, in his book. So now currently such type of ideas are called either a Virahanka Fibonacci sequence. Virahanka was one of the Jain mathematician before Fibonacci. That's why that name is attached to that. Or today we used to call it Narayan Pandit's n-Nacci sequences. Now I come to the last point. Just 2 minutes, sir. Infinite series for value of pi. We all know idea of the pi means a ratio of the circumference to its diameter is Indian. They find for the first time in Manav Shulva Sutra, that Shulva Sutra in 800 BC. 25/8 was selected, sufficiently correct value for construction purposes. In decimal point, it comes out to be 3.125, fairly correct. 3.1. Today we use 3.14, fairly 1 decimal digit correct for construction. Later on, Aryabhatta has given a value 3.1416. Not exactly in decimal places, but his ratio was 6200, 832 upon 20,000. How he got that number is again a different story. Then lot of mathematicians come till Ramanujan and lastly Bharati Krishna Tirthaji. They have given the different values of pi ratio starting from correct up to 1 decimal places to 32 decimal places. So it is again a very proud history of Indian contribution to finding the value of pi, actual value of pi, up to 32 decimal places stated by Bharati Krishna Tirthaji. Ramanujan works is known to all in this area. But India doesn't stop in finding the ratio, that is value of pi ratio. Later, throughout the Kerala mathematicians or South Indian mathematicians like Jeshtadeva, Shankardeva, so many, they came and they gave infinite series for pi. One of the series I have given on the screen, and that series read like this: C times 4D, etc., etc. And C denotes for a circumference, D denotes for a diameter. So that Madhava series gets converted to what we used to call today Leibniz series. It is a conversion. Again, Leibniz is a great mathematician. He has contributed a lot. Not necessary to take away anything from Leibniz. He was a great mathematician, no doubt about that. In the history, his name is taken very respectfully. But again, when we see the chronological order, this particular Madhava is given such type of series. Only thing is that all were in Malayalam. Madhava's script was in Malayalam, later it was translated to Sanskrit, and now it is available in English also. And some rapidly converging series were also discussed by Indian mathematicians. Then algebra, one thing only I will be quoting from algebra, and that is the work of solving indeterminate linear and quadratic equations. What is this indeterminate? Indeterminate equations are of the type, if it is a linear equation, it will be of the type ax plus or minus c equal to by. Simply straight line equation. In geometry, I want to predict, I want to say about it, ax plus minus c equal to by. But when India studied this equation as an algebraic equations, it is a difficult problem. Only because two variables x and y, available equation is only one. Usually, if I want to solve anything simultaneously in two variables, if I have two equations, I can solve it. So now, if when number of variables are equal to number of equations available, things are happy and easy. But when the reverse case, when number of variables given in the equation are greater than the number of available equation, that types of equation are called indeterminate equation. Diophantus is given as a father of such type of equation studying in Western history. But again, in Indian history, again this great Aryabhata first Aryabhata from Patilputra, from Nalanda, whatever you say. If I am not wrong, Aryabhata was a Kulapati in Nalanda University sometimes. Because in his book he said, पाटलिपुत्र में जितना मुझे ध्यान मिला उसी को मैं ये ग्रंथ में रख रहा हूँ. इस प्रकार का उसका संस्कृत में बचा है. तो मुझे लगता है कि शायद पाटलिपुत्र. You please check and verify whether he was any time here vice chancellor आज की भाषा में in the Nalanda University or not. I am not sure about it, but please do verify that. This great Aryabhata again comes us and tells us the method of finding the equations of this type. Later on, nx square plus 1 equal to y square. This is the type of the equation Indian attempted, which is a second degree equation in x and y, again indeterminate, because available equation is only one. So this is one of the finest contribution by Indian algebraists to the subject. Now I will close my topic with last unit, combinations. NCR formula, NPR formula we know in our syllabus. This particular formula of NCR was first quoted by Mahaviracharya in his 850 AD in his book Ganita Sara Sangraha. The formula which we apply slightly differs with formula given by Mahaviracharya. Only factorial r factor. We used to say factorial n upon factorial r into n minus r factorial. What Mahaviracharya did, he says factorial n upon factorial n minus r will be factorial r only. That's why he put the formula n into n minus 1, n minus 2 up to n minus r plus 1 divided by factorial r. Slight difference is there, but both results are equivalent. Now coming to the subject of Vedic mathematics, we all know, now it is a buzzword as it is called in English. बहुत उसका गाजा वाजा हो रहा है, जिसको कहते हैं मराठी में, हिंदी में मुझे पता नहीं क्या कहेंगे आप. And now new education policy also recommends that all these subjects should be the part of the syllabus according to the honest history of mathematics. no bluffing, nothing can be said and nothing should be said without a proper evidence. श्लोक है, वर्स है, बुक है, पता है कि this is the evidence, this is the reference, concrete reference, correct reference and sufficiently strong reference. All these three criteria will be applied whenever the education policy comes. So I am very pleased to when I heard that such type of ideas, Bharatiya Jnana Parampara in mathematics, are coming to the universities, and one of the universities is US National Open University. I am thankful to you for introducing such type of subject in the syllabus, and I pray to all of you, even though you are very seniors in mathematics or you are just beginning to study the mathematics, both cases, I request all of you to study history of Indian mathematics. Two references. One, History of Hindu Mathematics, Volume 1, Volume 2, Vibhuti Bhushan Datta, Avdesh Narayan Singh. They can be called as a Bible of this. And whatever Vibhuti Bhushan Datta has said in that 2 volumes, History of Hindu Mathematics, is very honest, very concrete. Now again, nothing is said without the concrete available reference. After that, I will request all you, particularly the young friends, to study a book, A Modern Introduction to Ancient Indian Mathematics. This is again an entirely different approach to the issue. Whatever I am saying, in that workshop held in Chennai back 90s, something 90 to 93, under the head of Dr. Bhanumurthy, T.S. Bhanumurthy, the then head of that university. 7-day workshop. Only one thing was done during the whole period of that workshop. That was a workshop, not a conference. Everybody burned the oil for getting the ideas. And that workshop deals with how we can prove the things said in Bhaskaracharya's book. How we can give the justification for the idea or justification for the concept or the method. So that book contains a lot of things. Again, I must say the book is very tough to follow. At least for me it was a very tough when I started reading that book. Unfortunately, I was not a member of that workshop. But once I know about that workshop, I try to get the material. Fortunately, Eastern Valley, Chennai has published a book about the contents of workshop, available, downloadable on internet. So आजकल तो कोई problem नहीं है ज़्यादा. Even if it is out of stock now. Modern Introduction to Ancient Indian Mathematics. Why it is important? Only because based on the number theory, like Will's theorem and all that things, based on the integer modulo n concept, he has proved, I repeat the word, he has proved what is not available earlier in the text. The reason for not availability is not that they don't know the proof, but because they write in the verse form, they had not given the proof. So that book has the concrete proofs of everything what is said earlier in Indian mathematician. So I pray and request all of you to study these 2 books, History of Hindu Mathematics. You will know what are the contents, and from this particular book, Modern Introduction to Ancient Indian Mathematics, you will realize that these are not all the fake things, they are not all just hearsay things, they are not just the things which are said very loudly and proudly. No, it has a concrete mathematical base. Thank you for listening patiently. Namaskar.
Thank you so much, Dr. Ram. So thank you.
Goes one step forward. After finding the first sum, then he starts finding the second sum. You can observe on the screen. The first sum is 1 up to 5. Then 1 plus 3, 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10, etc. Then third order sum, then fourth order, and then fifth order. this extension of the formula of sum of sums of natural numbers and similarly sum of sums for arithmetic progression. I have taken one example, 2, 7, 12, 17, 22. We can find the sum by routine formula. But then he applied the same technique, 2 plus 7, 9, 9 plus 12, 21, etc. to 5th order, 6th order. And finally, he gives two important results which are called mth order Varasankalitam or mth order sum of sums of natural numbers. I have written that formula in a regular notation only because we can understand it very easily. N into n into 1 up to n plus n is the numerator divided by factorial m plus 1. This formula is again a unique contribution from Indian side to the theory of sequences. This is sum of sums of natural number, similarly sums of mth order sum of sums when terms are in AP. That formula is again given by Narayan Pandit. I am not sure how many of you have even heard the name Narayan Pandit and a mathematician. He was a mathematician after Bhaskaracharya. Many times we think that, okay, Bhaskaracharya, starting from Aryabhatta say 499 AD up to Bhaskaracharya say 1150 AD. I can say galaxy of mathematicians available. But after Bhaskaracharya, straight away we jump to Ramanujan. And a 1150 AD to directly 19th century. In between those 800 years, from Bhaskaracharya to Ramanujan, there are again many mathematicians. One of the major mathematicians is this Narayan Pandit, who contributed a lot. The contribution of Narayan Pandit not stops at the Varasankalitam. Even he thought of Fibonacci sequences. We all know Fibonacci sequences, sum of previous two numbers and the sum is carried out. Now a branch Fibonacci mathematics is available after that discovery by Fibonacci. Of course, Fibonacci discovered his idea before Narayan Pandit. That is also in a historical sequence. But what Narayan Pandit did, I don't know whether he knows about the Fibonacci or not. Possibly not. Even if he know about the Fibonacci sequence, what he did, he extend the idea of Fibonacci sequence to n sums. N sums means today we used to call Tribonacci, Tetranacci. These are just 19th century concepts. If you Google it, Tribonacci, Tetranacci type of sequence, you will find that they are just 1900 something. The terms even they are not available. Tribonacci, Tribonacci, Pentanacci, N-Nacci. Now, what this fellow Narayan Pandit did in 1356 AD is he has given a formula for constructing n-Nacci sequences आज की भाषा में. उस समय तो उन्होंने n-Nacci sequence नहीं कहा है. आज की समझने की भाषा में n-Nacci sequences means if I start with 0 0, then sum of n terms, selected n terms will be the next. Then again selected n terms will be the next number. And not only that, he promoted the idea. He has given the application of this Fibonacci sequence, n-Nacci sequences in his book. So now currently such type of ideas are called either a Virahanka Fibonacci sequence. Virahanka was one of the Jain mathematician before Fibonacci. That's why that name is attached to that. Or today we used to call it Narayan Pandit's n-Nacci sequences. Now I come to the last point. Just 2 minutes, sir. Infinite series for value of pi. We all know idea of the pi means a ratio of the circumference to its diameter is Indian. They find for the first time in Manav Shulva Sutra, that Shulva Sutra in 800 BC. 25 by 8 was selected, sufficiently correct value for construction purposes. In decimal point, it comes out to be 3.125, fairly correct. 3.1. Today we use 3.14, fairly 1 decimal digit correct for construction. Later on, Aryabhatta has given a value 3.1416. Not exactly in decimal places, but his ratio was 6200, 832 upon 20,000. How he got that number is again a different story. Then lot of mathematicians come till Ramanujan and lastly Bharati Krishna Tirthaji. They have given the different values of pi ratio starting from correct up to 1 decimal places to 32 decimal places. So it is again a very proud history of Indian contribution to finding the value of pi, actual value of pi, up to 32 decimal places stated by Bharati Krishna Tirtha ji. Ramanujam works is known to all in this area. But India doesn't stop in finding the ratio, that is value of pi ratio. Later, throughout the Kerala mathematicians or South Indian mathematicians like Jeshtadeva, Shankardeva, so many, they came and they gave infinite series for pi. One of the series I have given on the screen, and that series read like this: C times 4D, etc., etc. And C denotes for a circumference, D denotes for a diameter. So that Madhava series gets converted to what we used to call today Leibniz series. It is a conversion. Again, Leibniz is a great mathematician. He has contributed a lot. Not necessary to take away anything from Leibniz. He was a great mathematician, no doubt about that. In the history, his name is taken very respectfully. But again, when we see the chronological order, this particular Madhava is given such type of series. Only thing is that all were in Malayalam. Madhava's script was in Malayalam, later it was translated to Sanskrit, and now it is available in English also. And some rapidly converging series were also discussed by Indian mathematicians. Then algebra, one thing only I will be quoting from algebra, and that is the work of solving indeterminate linear and quadratic equations. What is this indeterminate? Indeterminate equations are of the type, if it is a linear equation, it will be of the type ax plus or minus c equal to by. Simply straight line equation. In geometry, I want to predict, I want to say about it, ax plus minus c equal to by. But when India studied this equation as an algebraic equations, it is a difficult problem. Only because two variables x and y, available equation is only one. Usually, if I want to solve anything simultaneously in two variables, if I have two equations, I can solve it. So now, if when number of variables are equal to number of equations available, things are happy and easy. But when the reverse case, when number of variables given in the equation are greater than the number of available equation, that types of equation are called indeterminate equation. Diophantus is given as a father of such type of equation studying in Western history. But again, in Indian history, again this great Aryabhata first Aryabhata from Patilputra, from Nalanda, whatever you say. If I am not wrong, Aryabhata was a Kulapati in Nalanda University, sometimes. Because in his book he said, पाटलिपुत्र में जितना मुझे ध्यान मिला उसी को मैं ये ग्रंथ में रख रहा हूँ. इस प्रकार का उसका संस्कृत में वचन है. तो मुझे लगता है कि शायद पाटलिपुत्र. You please check and verify whether he was any time here vice chancellor आज की भाषा में in the Nalanda University or not. I am not sure about it, but please do verify that. This great Aryabhata again comes us and tells us the method of finding the equations of this type. Later on, nx square plus 1 equal to y square. This is the type of the equation Indian attempted, which is a second degree equation in x and y, again indeterminate, because available equation is only one. So this is one of the finest contribution by Indian algebraists to the subject. Now I will close my topic with last unit, combinations. NCR formula, NPR formula we know in our syllabus. This particular formula of NCR was first quoted by Mahaviracharya in his 850 AD in his book Ganita Sara Sangraha. The formula which we apply slightly differs with formula given by Mahaviracharya. Only factorial r factor. We used to say factorial n upon factorial r into n minus r factorial. what Mahaviracharya did, he says factorial n upon factorial n minus r will be factorial r only. That's why he put the formula n into n minus 1, n minus 2 up to n minus r plus 1 divided by factorial r. Slight difference is there, but both results are equivalent. Now coming to the subject of Vedic mathematics, we all know, now it is a buzzword as it is called in English. बहुत उसका गाजा वाजा हो रहा है, जिसको कहते हैं मराठी में, हिंदी में मुझे पता नहीं क्या कहेंगे आप. And now new education policy also recommends that all these subjects should be the part of the syllabus according to the honest history of mathematics. No bluffing, nothing can be said and nothing should be said without a proper evidence. श्लोक है, वर्स है, बुक है, पता है कि this is the evidence, this is the reference, concrete reference, correct reference and sufficiently strong reference. All these three criteria will be applied whenever the education policy comes. So I am very pleased to when I heard that such type of ideas, Bharatiya Jnana Parampara in mathematics, are coming to the universities, and one of the universities is US National Open University. I am thankful to you for introducing such type of subject in the syllabus, and I pray to all of you, even though you are very seniors in mathematics or you are just beginning to study the mathematics, both cases, I request all of you to study history of Indian mathematics. Two references. One, History of Hindu Mathematics, Volume 1, Volume 2, Vibhuti Bhushan Datta, Avdesh Narayan Singh. They can be called as a Bible of this. And whatever Vibhuti Bhushan Datta has said in that 2 volumes, History of Hindu Mathematics, is very honest, very concrete. Now again, nothing is said without the concrete available reference. After that, I will request all you, particularly the young friends, to study a book, A Modern Introduction to Ancient Indian Mathematics. This is again an entirely different approach to the issue. Whatever I am saying, in that workshop held in Chennai back 90s, something 90 to 93, under the head of Dr. Bhanumurthy, T.S. Bhanumurthy, the then head of that university, 7-day workshop. Only one thing was done during the whole period of that workshop. That was a workshop, not a conference. Everybody burned the oil for getting the ideas. And that workshop deals with how we can prove the things said in Bhaskaracharya's book. How we can give the justification for the idea or justification for the concept or the method. So that book contains a lot of things. Again, I must say the book is very tough to follow. At least for me it was a very tough when I started reading that book. Unfortunately, I was not member of that workshop. But once I know about that workshop, I try to get the material. Fortunately, Eastern Valley, Chennai has published a book about the contents of workshop, available, downloadable on internet. So आजकल तो कोई problem नहीं है ज़्यादा. Even if it is out of stock now. Modern Introduction to Ancient Indian Mathematics. Why it is important? Only because based on the number theory, like Will's theorem and all that things, based on the integer modulo n concept, he has proved, I repeat the word, he has proved what is not available earlier in the text. The reason for not availability is not that they don't know the proof, but because they write in the verse form, they had not given the proof. So that book has the concrete proofs of everything what is said earlier in Indian mathematician. So I pray and request all of you to study these 2 books, History of Hindu Mathematics. You will know what are the contents, and from this particular book, Modern Introduction to Ancient Indian Mathematics, you will realize that these are not all the fake things, they are not all just hearsay things, they are not just the things which are said very loudly and proudly. No, it has a concrete mathematical base. Thank you for listening patiently. नमस्कार।
Thank you so much, Dr. Ram Chauthai, Indian mathematical knowledge system and how our ancient people are rich with the mathematical knowledge. So this session is concluding here, and now next invited talk of Professor R.K. Sharma will start in the room number 7. So I request you all please come there in room number 7 for the next invited talk. Thank you so much. Hello. Yeah, now again I would like to call Professor K.C. Sinha, Vice Chancellor of Nalanda Open University, to give a token of memento to Dr. Ram Chauthai for his presentation in this conference.
Easy to make out what this could happen later. So you should not use the mobile if you are communicating something you think is secret, particularly with the mobile. And then comes, so you send a message and get the same apprehension. Whether you use the mail, for example, Gmail, the same apprehension. So basically what phrase, it should not be understood by the others. So this is what is the sole objective of cryptography, and that's how this art and science and basically the mathematics and how she did. So we just give you an idea because we have very brief time. So only a little of that we shall talk about. So it's a long story, of course. So we shall just see. Of the modern times. So it's the same thing as I said. There is one more thing also you might have observed, that when a child enters into a college right from the school, it's very apprehensive and always want to know everything but without revealing himself with anything. So what is a simple way to know whether there is a professor, associate professor, assistant professor, and so on? So it's a very simple thing to know. So stay behind the pillar and then observe how the teacher locks his room and leaves the office. So if he simply locks and goes away, lecture. And if he locks and pulls, he locks and then goes assistant professor. And if he locks and he pulls, he goes to a distance and comes back and then looks at it again and pulls associate professor. He locks, he pulls, he goes to a distance, he comes back and then looks at the lock, open the lock and then look inside and says, yes, everything is fine, and then again locks and closes. By that time, the security calls. Sir, the room is open. How come the room is open? I locked it myself. Sir, the lock is there, but the latch is above. Musla open. Definitely. You can imagine now we have seen it first. It's the same thing when you go on vacation. If the lock is by the child, locks in the leave, and when the lock is by the mother, when the lock is by father, sometimes he pulls so hard the lock is in his hand. Then again the same apprehension. And then another again calls the neighbor and try to find out, did you lock? Yes, I believe I did. Ask the neighbor. Yeah, he did. So let me check with the neighbor. The neighbor again says, Handi lock to the and okay, push the yeah. But when the family returns after 2 months, lock is there and everyone feels safer, safer, safer. And when opens the lock and looks at it, nothing is there. Sab, sab kuch sab. So what has changed in between? The lock was there, the lock is there, everything same, still nothing is inside. So what has changed is somebody came, made the key, opened the lock, took away it. So what is so important is key. Security, of course, is important, but the feeling of security is the most important. And that's what these lock companies or anybody that sell the lock at very high price does not sell security. There is no lock for the thieves. It's basically the feeling of security that they are exploiting. So you buy a bigger lock, more levers in the lock, and so on and so forth. Ultimately, they are exploiting when can they make you feel secure. So that's how things are. In the modern times also, if you put your money in a bank, and then you don't want to go to the bank, what next when you do is that the online banking. If you do the online banking, the same problem comes, whether it is safe or not. And the first time when Jumper became popular, you all know why it became popular, was that there was so much of online frauds originating from Jumper. got anything against J. We should look for the tail. Anyway, so it is again the same thing that when you use whether online for communication, ultimately or the banking, all the same, and the feeling also has to be that everything is safe, everything is secure. So what crypto system do they use? Basically, we talk about that. So it was 1976. Prior to that, cryptography was a forbidden subject for the civil purposes. It was solely for the military purposes. But when the banking system was expanding like anything, so for the revolution, basically in the finance sector, the crypto system was accepted as mode of communication. 1976 was the year to begin with, and the first crypto system in the modern times that came was silver polyhedron exponentiation cipher. So we took you to that. So we come to the silver polyhedron exponentiation cipher. So you take a large prime p. The prime means it's a positive integer greater than 1, whose only positive integer divisors are 1 and p itself. So if I have to start counting the primes, then the counting will begin from 2. So 2, 3, 5, 7, and then 11, 13, and so on and so forth. These are small primes. And then when you throw a little more, then you will have 101, 103, and then say 2017, 2027. And so distribution of primes itself is a subject to study. And finding larger prime, because more so nowadays of the applications, it's again a challenge to find the primes. So prime number generation itself is a task. Anyway, we should talk about that. So how the crypto system works, that we choose a large prime p, and to encrypt a message, identify the message units by an integer model of p. That means one of those 0, 1 to p minus 1, and then choose another positive integer, say e, between 0 and p minus 1, and this is called as exponent, which should be relatively prime to p. That means there is no common factor positive integer greater than 1. So for example, you have 3 and 13, any two primes are always relatively prime, but otherwise also 7 and 12, for example, are also relatively prime. So to encrypt this message, which is identified as one of the integers modulo p, say n, then raise power e and take its modulo p. That means we keep on dividing repeatedly by p till it becomes less than p, but no need. And then you can say, okay, this is C, which is the encryption of n. One simple example could be that, say, hello, how are you? So, if I want to do this, say, for example, hello, how are you, to encrypt. So, I look for the English alphabet, which has 36 letters, to accommodate all those and taking the smallest prime, therefore 29 will do the job. So we start with say 0, 1 to 28, 0 we can assign to 8, and 1 to 3, and that therefore will be 25. We can also accommodate some two more symbols, namely say question mark or the blank space. So if it is H, 1 by 1, if we decide to encrypt, then H would be identified by integer modulo 9. So if you start with say A0, B1, C2, B3, B4, and then F5, B6, H becomes 7. And the smallest exponent that should be relatively prime to P is 29. It cannot be 2, it has to be 3. So 3 raised to the power. Now you have to see here, so 7 is the numeric equivalent of H. E is the, so 7 cubed, 7 cubed, 7 squared is 49, 7 cubed is 343, and if you take modulo 29, so what should I do in taking modulo 29? I will throw away the multiples of 29 as many as possible, so in the bulk of 10. So 290 will go straight away like that. So if you do that, then so this is what I said. We assume this. So this is your if you take 343, this will turn up to be 11 into 29 module, congruent to 24 module 29. And if you look at the pre-assigned table, then this will be y that will correspond to 24, and therefore the encryption of h would be y. Now comes whether I can decrypt it properly or not. That means can I get back from y the letter h. So once again the same thing. So I have to therefore decrypt 24 modulo 29. And for this what we use is your Euclidean algorithm or the division algorithm to find out the inverse of say 3 modulo 29. So the inverse of E, call it say D modulo, say if you have prime P. Now since E and this P minus 1 are relatively prime, and therefore this inverse will exist, and that can be found out by long division or the Euclidean algorithm. Now as far as the inverse of 3 modulo P minus 1 here will be 28, so that you can write the table 3 also, and keep on looking at that when it goes more than 29, take the modulo 29, when it becomes 1 modulo 29. So you can see that 3 into 19 is 57, which is 56 plus 1, and 56 is twice of 28. Therefore, the inverse of 3 modulo 28 is 19. So we can take D. And to decrypt this D, so now we have Y. So this is what I have to do is, so if the encryption of say M is C, which is M power E, then we take C power D. Whether it gives or not, at least for the example we can verify. So that means I have to compute 24 to the power 19 modulo 29. One simple way is that I multiply 24 19 times and then keep on dividing by 29. Or can we do it faster? So this is known as your fast exponentiation, and the simple way is that you keep on squaring it as long as you can and then multiply if required so that it becomes faster. You have less number of steps to perform. You can also make use of the good property of the numbers that if you square x and minus x, you get the same thing. And therefore you can cut the size of this number to half. So you don't have to go up to 24. So when you take 24 modulo 29, this is minus 5 modulo 29. So 24 is square modulo 29 will be the same as minus 5 square modulo 29, which is rather small. And minus 5 square, 5 square will be the same. That is 25. That means minus 4. We again use this property. So we square minus 4, which is 16. And then we again square this. So we get 256. And every time, whenever it grows more than 29, the same technique we shall apply to throw away the multiples of 29. So doing this means that writing the power as a binary number, and the highest power till then you can square, and by that time all the powers of 2 that will be required in this binary expansion will turn up there. Then you can simply multiply. And therefore for this 19 you can write this as 16 plus 2 plus 1. So you are raising the squares till 4th power, and then you can multiply by the square and by the number, and then if you do like this, then you will get here. So this is minus 80. Now minus 87 minus 7. So when you multiply 29 by minus 3, that will be your minus 87 plus 7. So modulo 29, 24 is to the power 19 will be 7. And we look at the table that we have used to assign the numeric equivalence. So that comes to h. So we have decrypted that easily. Some simple exercise you can ask the children power of 101 and you divide by 103, what will be the remainder? Now, that was straightforward that there is no need to multiply this number 101 times. You can use a small theorem due to Fermat, irreversible. So this is known in the literature as Fermat's little theorem. So what does this theorem say is if P is a prime, A is a positive integer, and A and P are relatively prime, in that case A is to the power P minus 1 is common to 1 modulo P, and therefore if you apply this for P as under 3, which is prime, A is under 1, P minus 1 becomes under 2, therefore A is to the power P minus 1 becomes 101 raised to the power 102. You apply the Fermat's little theorem for P equal to 103, you get the remainder as 1. Right side. So this works. Now this is precisely, this is another example. So we use in the decryption the same theorem from our cylindrical theorem. So when you have got C as m raised to the power e, so when you do d power both sides, this is c power d, which is n power e power d, that means n power ed. Now ed is common to 1 modulo p minus 1 because that's what we have chosen it, and therefore this can be written as n power 1 plus k times p minus 1, where p is an integer. Now n raised to the power p minus 1 because p is prime and n is an integer between 0 and p minus 1, and therefore this is relatively prime. The Fermat's little theorem says n raised to the power p minus 1 is common to 1 modulo p, and that means you that this is simply n power 1, that is n. So you will get that the original mass is n. So it works, so it is true. So it was proposed as a publicly crypto system. So what is a publicly crypto system? Where encryption can be done publicly. Anybody can encrypt, but the decryption is private. Otherwise, what is the purpose? But unfortunately, what happens to make this publicly crypto system, you have to make public two things, namely P, the prime, and exponent E. But once this is done, it's a simple application of the Euclidean conductor to get the decrypting E, namely D. And therefore, in spite of all best efforts, this crypto system could not be accepted as a publicly crypto system. Well, friends, as it always happens that somebody does the hard work, somebody does the patchwork, and takes all the credit. Precisely the same thing happened 1 year later. So 1 year later in the laboratories, United States, there was a trial, 3 people, Ryder, Shamir and Adleman. They came up with a crypto system which is today the most commonly used crypto system, named RSA crypto system after their initials. So this crypto system simply suggests that instead of taking just one prime, you take better 2 primes. So take 2 distinct primes, say P and Q, and then encrypt any integer modulo n. N is the product of this. And then choose an exponent as earlier so that this is relatively prime to, so each should be chosen between 0 and n, which is relatively prime to phi. Phi is the Aristotelian function. So if the n is the product of 2 distinct primes, say you, Aristotelian function will give you the product of 2 numbers, p minus 1 and q minus 1. And once again, to get the inverse of this number, e modulo phi is a simple application of the same algorithm, namely the Euclidean algorithm. So you get D. And it can be proved that the decryption works properly. But this time, Fermat's little theorem is not applicable because it is not a prime. In that case, we have one more beautiful theorem, Euler's theorem. So what does the Euler's theorem say is that if n is a positive integer, A is an integer, A and n are relatively prime, A raised to the power 5 is common to 1 n. We are not proving, we don't have time also, but it works. It can be split into 2 distinct cases, when m and n are relatively prime, and m and n are not relatively prime. This publicly crypto system, as it was proposed, worked really as a publicly crypto system for the simple reason that to make encryption public, you have to make public n, which is called RSA modulus, and the exponent e. So the question is, can the system be broken? Usually it can be broken if p and q, the factors of n, are known. Because if factors are known, then the illustrated function simply is a product of p minus 1, q minus 1, this is known, and you apply simply the Euclidean number, then you get t. But if factors are not known, can it be? So the basic assumption behind this strength of the crypto system is that it is difficult to find out the factors given n, or given n and e, it is difficult to find out phi. So assumption is that it is basically equivalent to the factorization, and therefore if it is chosen carefully, two distinct primes kept secretly, multiplied, it is difficult to find the factors. Naturally, the crypto system will be lost. There are other attacks also, but the most attacks on this RSA crypto system are algebraic and basically the factorization attacks. There are several, therefore, factorization algorithms were developed. So we don't talk about those, but just to have a feeling that whenever you throw a product into the market, what you want is the success of the product, and therefore you do some experiment for it. If you put it into the market, will it survive in the market? So the same thing was done by the derivations. As a publicly crypto system, so all users will list in a directory two things. One, their RSA modulus, and e, their exponent. If you want to send a message to somebody whose RSA modulus is n and the exponent is e, so you convert the message unit into a modulo n integer, base power e, take modulus n, this is that. How he or she will recover from that is because he has known that publicly crypto system, so he or she knows the factors of n. And once factors are known, phi n is known, b is known, and then this can be decrypted. So the sole assumption is it is difficult to find factors given a positive integer, and given it is known that factor here will mean that the block of factors that is other than 1 and n if we are looking for the positive factors. So one thing is that in 77, to just have an idea how difficult it is going to be, they threw what is known in literature as a little challenge. So this little challenge was put up in 1977. So this was RSA crypto system. So how are you? Once again, it's an example, and now we come to the little challenge. Yes. So this was 1977. So 1977, so this was the challenge thrown that you decrypt this method. Now you can see that this is only one number. I have put in the box of 4 so that I don't make a mistake. But you can assume this is one number straight. Alright. It is also told that this has been obtained using the RSA crypto system. That means that they told n and e. So this n is this RSA modulus. This is again one number. It's not a big number if you look at it. It has how many digits? So each row has 32 digits, 4 rows, 128. This little bigger, one more. So this is 129 digits. So 129 digits is not a big number. You think even at that time also it was not that big number. They also told that this exponent 9007. By the way, this is also a prime. So the challenge was that you decrypt this, which actually amounts that you find non-trivial factors for this. So how much time you think that this factorization may take place? So can I just have some idea if you want to tell how much time it may take to find a factor for this number? Just any wide guess you can You can use your mobile, you can use your laptop, you can use any device that you have in your college. And just one line from that. So, would you like to tell us how much time it might be, sir? 10 minutes.
How can mathematically explain 24 whole to the power 19 equal to minus 80?
Just tell me this much time. Just tell me that. How many minutes is that? So sir is faster than you. He said it will take only 10 minutes, and I'm pretty sure that it will be faster if you are doing this computation. More so because nowadays it's the era of computers, so you can use mobile, laptop, desktop, and so on. So this was the year 1977. So the bilaboratories it always happens. So there is a principle of lottery. What is the principle of lottery? Is that खिलाने वाले को जीतना चाहिए, खेलने वाले को कभी नहीं. So इसलिए to make more money, you will put the cost of the ticket very little, but the price very high. So ₹1 का टिकट और 1 लाख करोड़ का आपका प्राइस होगा. लेकिन प्राइस करना नहीं चाहिए, because price is there and nowhere. So same thing, and then try to do this experiment. And if I were the customer of the ticket, how much time I would have taken. So this experiment always you do, because you are always afraid of losing time. Anyway, nobody does anything for free. So when this was done, so they announced the price. This was $100 price. They also said that this will be given to only one person who comes first, and not that will come 10 years later or something like that. So they also give some time limit. A lot of time, this 5 is not correct, it is 70 something, 1985. The thing is that for $100 is it safe? So they did their own assessment of this. So their estimate was 10 minutes, as you said. So their estimate was this much only. So these many, not minutes or seconds, these are the years altogether. You can count the zeros. So you can see 3, 3, 3, 5 times. So 15, and then there is one more, 16 zeros. So a million has 6 zeros, billion has 9 zeros, trillion has 12 zeros, quadrillion has 15 zeros, 40 quadrillion years will take. That was with the assumption that all computers around the globe will be used only for this purpose, and all people will work only on this problem. Problem is so simple that you will understand. Find a non-trivial factor. It's not a big deal. Factorization starts in class 3. As soon as you start adding up and multiplying, the next job is ask the child, find the vectors of 12, and so on. The same thing here. But you can imagine, all the banks are using the vector system. If you see, the laboratories, they sell only these two numbers, N and E. You can imagine how much they are charging, and the license is valid only for 2 years. They keep on changing. Now, to keep on changing this, the purpose is simple. To know, is there any glorious boy or girl around the club who can find the vectors quickly? So the purpose is that to know the status of man's machine. Man is a cartoon, machine is the hardware of the system. How fast this can be computed. And for that, once again, the prices are announced. So this is called an RSA challenge number, RSA challenge price. The current price is $250,000. That is around $7, which you earn if you do own money on. Here is the problem. So this was just 40 into 10 to the power 16 years, and then you check. It's a small number. You raise the powers, it gives you the feeling it's not big. It's very small. But this was their estimate that 40 quadrillion years. So they thought that $100 was safe. What is these many years? Nobody is going to have this money. So this challenge was accepted. दुनिया में कोई चैलेंज ऐसा होता नहीं, कोई ना कोई तो निकलेगा. So yes, this was accepted. By whom it was accepted? Atkins, Graf, and Lewis. So this was now 4 people. Did they succeed? Of course, this was the question. They did indeed. It was 1994. And 1994 saw so much actually activity in mathematics, science, literature, geography, and everything. So it changed the whole thing around the globe. So I think we have to wind up. So just before that, I show you something you will really enjoy. I don't know, we can't hear the sound. If you could hear the sound, it would have been much nicer. So this you put that if you get some sound, you will really enjoy. So we always believe that one day someone will succeed. So this is just and we will show you. Therefore, decrypt 24 modulo 29. And for this, what we use is your Euclidean algorithm or the division algorithm to find out the inverse of 3 modulo 29. So the inverse of E, or it's a D modulo, say if you have prime P. Now since E and this P minus 1 are negatively prime, and therefore this inverse will exist, and that can be found out by long division or the Euclidean algorithm. Now as far as the inverse of 3 modulo P minus 1 here will be 28, so that you can write the table of 3 also, and keep on looking at that when it goes more than 29, take the modulo 29, when it becomes 1 modulo 29. So you can see that 3 into 19 is 57, which is 56 plus 1, and 56 is twice of 28. Therefore, the inverse of 3 modulo 28 is 19. So we can take D. And to decrypt this D, so now we have Y. So this is what I have to do is, so if the encryption of say M is C, which is M power E, then we take C power D. Whether it gives or not, at least for the example we can verify. So that means I have to compute 24 to the power 19 modulo 29. One simple way is that I multiply 24 19 times and then keep on dividing by 29. Or can we do it faster? So this is known as your fast exponentiation. And the simple way is that you keep on squaring it as long as you can, and then multiply if required, so that it becomes faster. You have less number of steps to perform. You can also make use of the good property of the numbers that if you square x and minus x, you get the same thing. And therefore you can cut the size of this number to half. So you don't have to go up to 24. So when you take 24 modulo 29, this is minus 5 modulo 29. So 24 is square modulo 29 will be the same as minus 5 square modulo 29, which is rather small. And minus 5 square, 5 square will be the same. That is 25. That means minus 4. We again use this property. So we square minus 4, which is 16. And then we again square this. So we get 256. And every time, whenever it grows more than 29, the same technique we shall apply to throw away the multiples of 29. So doing this means that writing the power as a binary number, and the highest power till then you can square, and by that time all the powers of 2 that will be required in this binary expansion will turn up there. Then you can simply multiply. and therefore for this 19 you can write this as 16 plus 2 plus 1. So you are raising the squares to the fourth power, and then you can multiply by the square and by the number, and then if you do like this, then you will get here. So this is minus 80. Now minus 87 minus 7. So when you multiply 29 by minus 3, that will be your minus 87 plus 7. So modulo 29, 24 is to the power 19 will be 7. And we look at the table that we have used to assign the numeric equivalence. So that comes to H. So we have decrypted that easily. Some simple exercise you can ask the children, for example, if you raise the derivative to the power of 101 and you divide by 103, what will be the remainder? Now, you should at first know straightforward that there is no need to multiply this number 102 times. You can use a small theorem due to Fermat, so this is known in the literature as Fermat's little theorem. So what does this theorem say is if P is a prime, A is a positive integer, and A and P are relatively prime, in that case A is to the power P minus 1 is common to 1 modulo P, and therefore if you apply this for P as 103, which is prime, A is 101, P minus 1 becomes 102, therefore A is to the power P minus 1 becomes 101 is to the power 102. You apply the Fermat's little theorem for P equal to 103, you get the remainder as 1. Right side. So this works. Now this is precisely, this is another example. So we use in the decryption the same theorem from Fermat's theorem. So when you have got C as m raised to the power e, so when you do d power both sides, this is c power d, which is n power e power d, that means n power ed. Now ed is common to 1 modulo p minus 1 because that's what you have chosen it, and therefore this can be written as n power 1 plus k times p minus 1, where k is an integer. Now n raised to the power p minus 1 because p is prime and n is an integer between 0 and p minus 1, and therefore this is relatively prime. The Fermat's little theorem says n raised to the power p minus 1 is common to 1 modulo p, and that means you that this is n power 1, that means n. So you will get that the original mass is n. So it works. So it is true. So it was proposed as a publicly kept system. So what is a publicly kept system? Where encryption can be done publicly. Anybody can encrypt, but the decryption is private. Otherwise, what is the purpose? But unfortunately, what happens to make this publicly kept system, you have to make public two things, namely P, the prime, and exponent E. But once this is done, it's a simple application of the Euclidean conjecture to get the decrypting E, namely D. And therefore, in spite of all best efforts, this crypto system could not be accepted as a publicly kept system. Well, friends, as it always happens that somebody does the hard work, somebody does the patchwork, and takes all the credit. Precisely the same thing happened 1 year later. So 1 year later in the laboratories, United States, there was a trial, 3 people, Tyler, Shamir and Adleman. They came up with a crypto system which is today the most commonly used crypto system, named RSA crypto system after their initials. So this crypto system simply suggests that instead of taking just one prime, you take better 2 primes. So take 2 distinct primes, say P and Q, and then encrypt any integer modulo n. N is the product of this. And then choose an exponent as earlier so that this is relatively prime to, so each should be chosen between 0 and n, which is relatively prime to phi. Phi is the Aristotelian function. So if the n is the product of 2 distinct primes will give you, Aristotelian function will give you the product of 2 numbers, p minus 1 and q minus 1. And once again, to get the inverse of this number for E modulo finite is a simple application of the same algorithm, namely the Euclidean algorithm. So you get D. And it can be proved that the decryption works properly. But this time Fermat's theorem is not applicable because it is not a prime. In that case, we have one more beautiful theorem, Euler's theorem. So what does the Euler's theorem say is that if n is a positive integer, A is an integer, A and n are related to prime, A raised to the power 5 is common to 1 over n. We are not proving because have time also, but it works. It can be split into two distinct cases when m and n are relatively prime and m and n are not relatively prime. This publicly kept system as it was proposed worked really as a publicly kept system for the simple reason that to make encryption public, you have to make public n, which is called RSA modulus, and the exponent e. So the question is, can the system be broken? Easily it can be broken if p and q, the factors of n, are known. Because if factors are known, then the Euler's function simply is the product of p minus 1, q minus 1, this is known, and you apply simply the Euclidean algorithm, you get d. But if factors are not known, can it be? So the basic assumption behind this standard of the system is that it is difficult to find out the factors given n, or given n and e, it is difficult to find out phi. So assumption is that it is basically equivalent to the factorization, and therefore it is chosen carefully, two distinct times, kept secretly, multiplied. It is difficult to find the factors. Naturally, the crypto system will be lost. There are other attacks also, but the most attacks on this RSA crypto system are algebraic and basically the factorization attacks. There are several, therefore, factorization algorithms were developed. So we don't talk about those, but just to have a feeling that whenever you throw a product into the market, what you want is the success of the product, and therefore you do some experiment for it. If you put it into the market, will it survive in the market? So the same thing was done by the derivations. As a public key crypto system, so all users will list in the directory two things. One, their RSA modulus, and E, their exponent. If you want to send a message to somebody whose RSA modulus is n and the exponent is e, so you convert the message unit into a modulo n integer, base power e, take modulus n, this is the equation. How he or she will recover from that is because he has known that public key crypto system, so he or she knows the factors of n. And once factors are known, phi n is known, d is known, and then this can be declared. So the sole assumption is it is difficult to find factors given a positive integer, and even if it is known that factor here will mean that the proper factors, that is other than 1 and n, if we are looking for the positive factors. So one thing is that in 77, to just have an idea how difficult it is going to be, they threw what is known in literature as a little challenge. So this little challenge was put up in 1977. So this was our security system. So how are you? Once again, it's an example, and now we go to the little challenge. Yes. So this was 1977. So 1977, so this was the challenge thrown that you decrypt this method. Now you can see that this is only one number. I have put in the box of 4 so that I don't make a mistake. But you can assume this is one number straight. Alright. It is also told that this has been obtained using the RSA crypto system. That means that they told n and e. So this n is this RSA modulus. This one number. It's not a big number if you look at it. It has how many digits? So each row has 32 digits, 4 rows, 128, this little bigger, one more, so this is 129 digits. So 129 digits is not a big number, you think. Even at that time also it was not that big number. They also told this exponent 9007. By the way, this is also a prime. So the challenge was that you decrypt this, which actually amounts that you find non-trivial factors for this. So how much time do you think that this factorization may take? So can I just have some idea if you want to tell me how much time it may take to find the factor for this number? Just any wide guess you can do. You can use your mobile, you can use your laptop, you can use any device that you have in your college. And just put light. So would you like to tell us how much time it might take, sir? 10 minutes.
How can mathematically explain 24 whole to the power 19 equal to minus 20?
Just tell me this much time. Just tell me that. How many minutes you said? So sir is faster than you. He said it will take only 10 minutes. And I'm pretty sure that it will be faster if you are doing this computation. More so because nowadays it's the era of computers. So you can use mobile, laptop, desktop, and so on and so forth. So this was the year 1977. So the parallelography is it always happens. So there is a principle of lottery. What is the principle of lottery? Is that खिलाने वाले को जीतना चाहिए, खेलने वाले को कभी नहीं. So इसलिए to make more money, he will put the cost of the ticket very little, but the price very high. So ₹1 का टिकट और 1 लाख करोड़ का आपका प्राइस होगा. लेकिन प्राइस करना नहीं चाहिए, because price is there and nowhere. So same thing, and then try to do this experiment. And if I were the customer of the ticket, how much time I would have taken. So this experiment always you do, because you are always afraid of losing time. Anyway, nobody does anything for free. So when this was done, so they announced the price. This was $100 price. They also said that this will be given to only one person who comes first, and not that will come 10 years later or something like that. So they also give some time in it. A lot of time. This file is not correct. It is 77 to 1985. The thing is that for $100 is it safe? So they did their own assessment of this. So their estimate was 10 minutes, as you said. So their estimate was this much only. So these many, not minutes or seconds, these are the years altogether. You can count the zeros. So you can see 3, 5 times. So 15, and then there is one more, 16 zeros. So a million has 6 zeros, billion has 9 zeros, trillion has 12 zeros, quadrillion has 15 zeros, 40 quadrillion years will take. That was with the assumption that all computers around the globe will be used only for this purpose, and all people will work only on this problem. Problem is so simple that you understand. Find a non-trivial factor. It's not a big deal. Factorization starts in class 3. As soon as you start adding up and multiplying, the next job is ask the child, find the vectors of 12, and so on. The same thing here. But you can imagine, all the banks are using the vector system. If you see, the value laboratories, they sell only these two numbers, N and E. You can imagine how much they are charging, and the license is valid only for 2 years. They keep on changing. Now, to keep on changing this, the purpose is simple. To know, is there any glorious boy or girl around the club who So the purpose is that to know the status of man's machine, man is a charter, machine is the hardware, the system, how fast this can be computed. And for that, once again, the prices are announced. So this is called an RSA challenge number, RSA challenge price. The current price is $250,000. That is around $7, which you earn if you do own money on community. Here is the problem. So this was just 40 into 10 to the power 16 years, and when you check, it's a small number. You raise the power, so it gives you the feeling it's not big, it's very small. But this was their estimate that 40 quadrillion years. So they thought that $100 is safe. What is these many years? Nobody is going to have this money. So this challenge, was this challenge accepted? दुनिया में कोई चैलेंज ऐसा होता नहीं, कोई ना कोई तो करेगा. So yes, this was accepted. By whom it was accepted? Atkins, Graf, and Lewis. So this was now 4 people. Did they succeed? Of course, this is the question. They did indeed. It was 1994. And 1994 saw so much activity in mathematics, science, literature, geography, and everywhere. So it changed the whole thing around the globe. So I think we have to wind up. So just before that, I show you something you will really enjoy. I don't know, we can't hear the sound. If you would hear the sound, it would have been much nicer. So this put that so if you get some sound, you will really enjoy. So we always believe that one day someone will succeed. So this is just and we will show you.
So then, no questions. Let us thank Professor R.K. Sharma for his wonderful talk. So may I request now Professor Sinha and then Professor Oprah to join.
Thank you so much. After 10 minutes of the I would like to request Professor Alimuddin Sahab Ali Muslim and conduct it. Please.
Thank you very much. Good morning to everybody. It's a great pleasure to invite Professor S.K. Pandey from IIT PhD Varanasi to give a talk. So, Dr. S.K. Pandey is Professor in the Department of Mathematical Sciences, IIT PhD Varanasi.
The word is one brings Chakravarti. One thing I can promise, nothing will be boring here.
See, this is Honorable Vice Chancellor, Professor K.C. Sinha of this university, Nalanda University, Geometry at Patna Science College. Then you are a true alumnus of Patna Science College. See, I have seen several professors of several universities, but I could not find anybody who could be ever compared with the professors who taught me at Patna Science College. Be it Professor Punendra Bhattacharya of chemistry. It's not that what I remember his lectures. Be it Professor Punendra Bhattacharya or Professor Harishchandra Verma. Harishchandra Verma took his first class at Patna Science College in 1979 of physics, and that was my first class of physics at Patna Science College. This fact was revealed when we were exposed at NIT Patna a couple of 3-4 years back. He was a teacher, I was a student. Then Professor A.K. Rai Physics, Professor B.P. Tripathi, Professor Asishwar Yadav, Professor A.K.P. Yadav. Friends, this must be a surprising fact that I am just uttering their names. See, I learned from Professor A. Yadav. I remember it was month of July. I remember even the classroom. I remember his lecture that he said, by the surface tension is that property of matter, that property of a liquid by means of which it tries to minimize its surface area. It's not that. I wrote it and then tried to remember. I remember the way he uttered, the moment he uttered from that one. Professor A.K.P. Yadav said, electrostatic potential, the work that is required to bring unit positive charge from infinity to that point is electrostatic potential. See, it's not that we were not taking down whatever was being delivered, but we remember directly from our teachers, probably the way our ancestors directly learned from their gurus. When probably writing, this humankind had not developed the writing skills. I'm having some friends here, although they were juniors. He was a classmate of my younger brother. He was admitted to Patna in 1982. Then Professor Ompakasi, he is an alumnus of Patna Science College. Of course, I was a student of Professor Kamalkant. The professors. So, if you are not finding yourself able to learn directly from lecture, it means or it guarantees that the talk was or the lecture was not a good lecture. Let's come to this lecture. Modeling. Modeling, what do you mean? What is modeling? Even if people ask the candidates that you tell what modeling is, don't tell what you have modeled. And this is my firm belief. This is my firm belief that the first creation of the Brahma, people can give several names. The first creation of Brahma was not Brahma, Brahma. The Almighty was mathematics. This is my firm belief. After that, we made mathematical formulations and then followed the creation of this entire universe. We all know that this universe is governed by inverse square law. Do you think that universe was created first and then this formulation was done? No. The formula was already there. Based on that formula, this universe was created. And likewise, for everything, for every activities, we have a formula. The principles are unending. I wrote in my PhD thesis, the first paragraph, man lacked the enchanted hands of dancing forces that created the universe brilliantly. But the way he attempted and explored the mysteries with his limited talent and skill is no less splendid. The moment he opened his eyes, you observed on the one hand was lying stupendous beauty, and on the other was standing unyielding principles. They looked out of curiosity into the laws, connecting things in nature, and tried to trace fibers from them. The ventures passed from one generation to another, and finally created artificial world of the world. So this must have been the most amazing fact. For whole of the mankind, this huge universe with enormous diversities has several events recurring for it. And even smaller entities having perfect automation. We observe the sun rises in the east. It's not that today I rose in the east, tomorrow somewhere else. Whether it will rise or not, no, we are all sure. Because this process or this phenomenon is based on some formation. So rises in the east, sets in the west, time changes, then there are several seasons. These seasons are repeated. We have a very big unit that we call year, and year is bigger unit. That is based on the revolution of the earth around the sun. It takes 1 year. What is 1 year? It is a unit of time. I would ask you, particularly youngsters, can you tell why here the angle subtended around a point is 360? Not 400, not 100, not 100. एक बिंदु के चारों जितना कोण बनता है बस 360 डिग्री क्यों है? 400 क्यों नहीं? उसको 400 क्यों नहीं बोला? कुछ बोला क्या? 100 बोलते 360. See, we learn from nature. कितने दिन लगते हैं? 365 दिन कुछ मिनट से ये 5 मिनट और 5 दिन 6 घंटे आप कितने मिनट से कहाँ बता रही थी? बचाया नहीं गया, इसके कुछ कारण है. तो चढ़ते ने एक टीचर ने पूछा, बताओ एक सामान मैंने 20 रुपये और 75 पैसे में खरीदे और उसको बेच दिया 25 रुपये 49 पैसे में. मुझे फायदा हुआ कि घाटा? एक छात्र ने 5,000 पैसे बैठे हैं. सर आपको रुपये में फायदा हुआ और पैसे में घाटा? बड़ी मजेदार बात. रुपये में फायदा हुआ 5 रुपये का और घाटा हुआ कितना? 26 पैसे का. तो 5 रुपये में 26 पैसे घटाकर रिजल्ट बताना बहुत आसान है, पर इस बार इसके कि हम लिख के उसको साइंस का हिसाब किताब करें. और यही बात सब जगह की गई है. 360 लिया गया. एज में भी हम 360 का ही ईयर मानते हैं. आगे तीसरे साल उसको पूरा करते हैं और ऐसा नहीं कानन में करते हैं. हर पूर्णिमा में एक नक्षत्र का देखना बहुत जरूरी है. इस साल 2 सावन थे, तो दूसरे सावन में श्रवण नक्षत्र दिखाई पड़ा पूर्णिमा को. What is the beauty of 360? That it is circles by 1 by 2. भाग लगेगा, दूसरे भाग लगेगा. स्टार्ट में 3 में, 3 से 4 से 5 से 6 से 7 से 8 से 9 से 10 से 80 बटा 360. क्या कह सकते हैं? क्यों आप भाग देते हैं बार बार? तो अगर उत्तरायण दक्षिणायन करना होता है तो 2 से भाग देना पड़ता है. सीजन में 6 से भाग देना पड़ता है. महीनों के बाद आते हैं तो 12 से भाग देना पड़ता है ना. पक्षों के बाद आते हैं 24 से भाग देना. सबसे भाग देना. चलिए इस पर कभी बात हो क्या जाते हैं. So modeling is that. So there are several compromises. There are several symbolizations. We in mathematics we use symbols. और modeling में क्या करते हैं? Only a closed system can be modeled, not an open one. By an open system we mean a system which has infinite number of parameters. So if you are not aware of the number of parameters, how can we model the system? So the parameters must be finite number. Unequal some 5,000 and parameters it's not possible for you. So you have to give away or neglect those parameters that give least that this is significant or there is impact. So with the only a few parameters, we start formulation. For example, P equals NRT. What is that? That is kinetic charge. Yes. But that is not derivation. It was meant for ideal cases. For ideal cases, there are several improvements. The famous improvement is van der Waals equation. P minus A upon B square into D minus B equals NRT. ER. So this way we keep on improving our formulas, and those formulas are one. Yeah. Next is explanation of the genesis is उद्गम का था। उद्गम तो क्या होता है? उद्गम का मतलब जानना है। आप उद्गम यहाँ बोले मतलब कम, थोड़ा सा कम, तो उससे थोड़ा सा कम मतलब एकदम चले नहीं जाना है, धीरे धीरे करके उसको शब्द बनाए जाते हैं हमारे यहाँ। उन्मन, आप अपने मन से काम नहीं कर रहे का उन्मन है। अब व्यंजन संधि पर उसका नहीं करना चाहिए। See, unlike huge size mighty tornadoes and hurricanes, they are popular names tornadoes and hurricanes. Hurricanes क्या होते हैं? अलग अलग क्षेत्र में अलग अलग नाम देते हैं। कहीं हरिकेन कहते हैं, कहीं टाइफून कहते हैं, और हम लोग साइक्लोन कहते हैं। डस्ट केवल्स कहते हैं, हम गांव में शहरों में भी कहते हैं गर्मी के दिनों में एक चक्रवात होता है जो कहते हैं उसमें मत जाओ, तो नहीं जाना चाहिए। जब वो क्षणिक होते हैं कुछ समय के लिए, लेकिन वो खतरनाक हो सकते हैं। तो unlike huge size mighty tornadoes, hurricanes, dust devils are transient whirlwinds rotating at a small scale, mixed with the dust particles, dry leaves, and anything else available in the surroundings, lying on the ground, and light enough to float in the air. Observed particularly in the summer, a dust devil is witnessed lasting even for several minutes, but less frequently. बहुत समय तक लोग है, लेकिन लोग ऐसा कम दिखता है। और ये एक फार्मूला बनाया था, इसके पहले 1982 में ही 1882 में एक फार्मूला बनाया गया जिसमें इसको जीरो लिया गया। यह भी जीरो केवल रोटेशन था। बाद में सारी इंप्रूवमेंट्स के कुछ मॉडल्स की मैं बात कर रहा हूँ, हमारे उतना समय नहीं है, लंबा मॉडल में चर्चा करनी चाहिए। इसमें तीनों वेलोसिटीज की बात की गई है। और आप ऐसे फॉर्मेशन कैसे होता है कि एक रेडियल वेलोसिटी का कोई पॉइंट लेते हैं, उधर से हवा यहाँ गर्मी जब बढ़ती है तो यहाँ की गर्म हवा ऊपर जाती है, उसको बढ़ाने के लिए चारों दिशाओं से, और चारों दिशाएं में समतल दिशा जो हवा आती है, और सेंटर की तरफ इसलिए हम क्या लिखते हैं? माइनस लिखते हैं। क्योंकि सिंपल हार्मोनिक मोशन में लिखते हैं ना माइनस करके, तो यहाँ फिर ये जो मॉडल्स आए हैं ये एम्पिरिकल मॉडल्स हैं। मतलब वो लोगों ने सोचा है, समझा है, कुछ फॉर्मूला बनाया है, उसका सिमुलेट किया है, तो देखा ठीक ठाक होता है, लेकिन एग्जैक्टली ये जो थ्योरेटिकली डिराइव किया गया ऐसा नहीं है। बट देखिए उसमें माइनस AR लिखा है, तो बहुत इंपॉर्टेंट है। और उसके बाद ये पता है उसमें और भी देख रहे हैं क्या, नहीं दिख रहा है। पर्टिकुलर इन द समर, a dust devil is witnessed lasting even for several minutes, but less frequently. बहुत समय तक लोग है, लेकिन लोग ऐसा कम दिखता है। और ये एक फार्मूला बनाया था, इसके पहले 1982 में ही 1882 में एक फार्मूला बनाया गया जिसमें इसको जीरो लिया गया। यह भी जीरो केवल रोटेशन था। बाद में सारी इंप्रूवमेंट्स के कुछ मॉडल्स की मैं बात कर रहा हूँ, हमारे उतना समय नहीं है, लंबा मॉडल में चर्चा करनी चाहिए। उसमें तीनों वेलोसिटीज की बात की गई है। और आप ऐसे फॉर्मेशन कैसे होता है कि एक रेडियल वेलोसिटी का कोई पॉइंट लेते हैं, उधर से हवा यहाँ गर्मी जब बढ़ती है तो यहाँ की गर्म हवा ऊपर जाती है, उसको बढ़ाने के लिए चारों दिशाओं से, और चारों दिशाएं में समतल दिशा जो हवा आती है, और सेंटर की तरफ इसलिए हम क्या लिखते हैं? माइनस लिखते हैं। क्योंकि सिंपल हार्मोनिक मोशन में लिखते हैं ना माइनस करके, तो यहाँ फिर ये जो मॉडल्स आए हैं ये एम्पिरिकल मॉडल्स हैं। मतलब वो लोगों ने सोचा है, समझा है, कुछ फॉर्मूला बनाया है, उसका सिमुलेट किया है, तो देखा ठीक ठाक होता है, लेकिन एग्जैक्टली ये जो थ्योरेटिकली डिराइव किया गया ऐसा नहीं है। बट देखिए उसमें माइनस AR लिखा है, तो बहुत इंपॉर्टेंट है। और उसके बाद ये पता है उसमें और भी देख रहे हैं कि आप लेकिन वहाँ जेड नहीं दिख रहा है तो बढ़ती करना कुछ फॉर्मूले हैं प्रेशर इस तरह आया है। चलिए आगे चलते हैं अपने मॉडल की बात करें। एक है डिस्टेंस, उन्होंने यह मॉडल दिया जो एक है तो पहले पहला मॉडल है जब मैं एक फिक्स प्रोबेबिलिटी जो एक टाइम प्लस हो जाता है। चलिए आगे चलिए। एंडरसन एक फार्मूला दिया, चलिए तीन लोगों ने अलग अलग फार्मूले दिए, इसके अतिरिक्त भी बहुत सारे लोगों ने फार्मूले दिए। आगे बढ़िए अब सर चलिए ये पहला क्या है 10 डिग्री जो कुछ सेकंड के लिए हम लोग देखते हैं मगर वैसे ही यह क्या है ये टॉर्नेडो कहाँ दिख रहा है तो आसमान में दिख रहा है। यह टॉर्नेडो जो है जमीन पर आता है और जब पानी पर आएगा तो वाटर स्पॉट बोलते हैं और ये साइक्लोन है ये समुद्र में बनता है। मजेदार बात है कि छोटा सा हिस्सा दिख रहा है उसको आई बहुत ज़्यादा चौड़ा नहीं होता है, एक करीब 40 माइल के करीब होता है। और उसकी बात का दूसरा ये है और थोड़ा सा ज़्यादा है वैसे करीब 70-80 माइल का हो जाता है। उससे में पहले यहाँ कुछ नहीं होता है पाकिस्तान और ये यहाँ पहले गर्म हवा ऊपर जाती है बाद में लगभग वहीं पर अस्सी किनारे में फिर वर्षा होती है और जो बाहर का क्षेत्र है ये करीब 500 माइल का होता है। तो राजस्थान तक जो है इसका असर पड़ सकता है ऐसे तो वहाँ केवल आंधी तूफान होगा। बिहार में वर्षा हो जाती है, बंगाल और उड़ीसा में बहुत ज़्यादा ही होती है, वहाँ खतरनाक तूफान होता है, वहाँ पर लोगों को शिफ्ट करना पड़ता है। बिहार में लोग मजे लेते हैं, उत्तर प्रदेश की कुछ हिस्सों में जाके पहुँच जाता है, आगरा वगैरह नहीं जाता है, खाली ताजमहल देख के लौट जाएंगे तब साइक्लोन में मजा नहीं ले सकती, आप माना पड़ेगा। नालंदा वाले भी एक स्कूल पढ़ा, स्कूल के छत पर तो उसने ऐसा बढ़ाया कि वह करीब 10-12 किलोमीटर दूर बाद में मिला। दूसरे दिन आगे गुजरा तो कुछ लोग पंपिंग सेट के साथ बैठे थे, उसको पकड़ लिया, पंपिंग सेट के साथ उनको उठाया। क्या हुआ होगा सोचिए। ये ट्रक आया, ट्रक को उसने उछाला, 50 फुट ट्रक भी उछला, उसके बाद से एक ईटा बैठा के से गुजरा, जिसके ईटे से मिसाइल चल रहे थे। धान के खेत से गुजरा, धान के पौधे कबाड़ दिए। मतलब यहाँ वेलोसिटी शुरू होती है, ऐसा नहीं है ना। तो ये कहते हैं कि दिन को कुछ नहीं होता है, वहाँ धान के खेत को ऐसा कुछ हो गया, ऐसे ही होता है। तो कुछ मॉडल्स जो मैंने बनाए यहाँ पर जीरो वेलोसिटी मान, हमने इसको डिस्क्राइब करके हमने इसको और सुधारा है। मगर अभी मैं उदाहरण की बात नहीं करूँगा, मैं केवल डस्टेबल की बात करूँगा। अब हम ये जानते हैं अगर सर्कुलर मोशन है, इसके लिए क्या जरूरी है? हाँ, there must be some centripetal force। इसके पहले हो नहीं सकता है। मतलब आश्चर्य की बात है, कितने साल से रिसर्च होता रहा था, कहते तो थे लोग, लेकिन किसी में वह जो है लो प्रेशर चले। अब बताइए कि सेंट्रीपिटल फोर्स कैसे बनेगा? वहाँ रस्सी तो लगाएंगे नहीं हम, वहाँ लो प्रेशर जोन बनता है और बाहर का प्रेशर ज्यादा होता है। तो क्या हो, हवा उधर से बहनी शुरू होती है। आप हम डायनेमिक्स में पढ़ते हैं, कोप्लेनर डायनेमिक्स के लिए सिस्टम ऑफ कोप्लेनर फोर्सेस reduces to a single force and a couple। कपल्स को रिपीट करता है। फ्लूइड डायनेमिक्स में भी इस तरह के जो फोर्सेज जब होते हैं, हम जब जनरलाइजेशन करते हैं तो स्प्लिट करते हैं दो पार्ट्स आते हैं। एक से रोटेशन, एक से ट्रांसलेशनल वेलोसिटी बनती है और दूसरे से रोटेशनल वेलोसिटी। और जो उसमें वोटिसिटी वेक्टर बनता है, तो वोटिसिटी वेक्टर इज जस्ट ट्वाइस ऑफ द एंगुलर वेलोसिटी। So since its velocity it has got a direction, the vorticity vector is also a vector quantity। तो हमने देखा कि जब हमारा मॉडल बना, उस मॉडल का मैं नहीं बता रहा हूँ, उसमें एक लॉगरिथमिक टर्म आया। मजेदार बात है, लॉगरिथमिक टर्म भी पैराबोलिक ही है ज्योमेट्रिकली, लेकिन जब हम वहाँ पर r ड्रॉ करते हैं तो वहाँ वो जो है वो सिंगुलरिटी है। सिंगुलरिटी हमारे बड़ी सिंगुलरिटी की बात करते हैं, तो सिंगुलरिटी का क्या मतलब है वहाँ समझ में आता है। मतलब वैसा हो नहीं सकता कि अगर इस तरह का कोई रोटेशनल मोशन है और वहाँ पर उसका रेडियस जीरो हो जाए, जी नहीं। तो हमें ऐसा एक एरिया चाहिए लो प्रेशर जोन का, जो टॉर्नेडो में जो क्या कहते हैं साइक्लोन में बड़ा सा है, मात्र 40 माइल के करीब होता है। वहाँ पर कुछ नहीं होता है शांत। तो जैसे उड़ीसा में जब साइक्लोन आगे बढ़ता है तो पहले तो इधर तूफान आता है, तूफान आने के बाद से फिर आगे बढ़ते तो वर्षा होती है, तो आगे और जाते हैं तो शांत खत्म हो गया। फिर वो साइक्लोन और आगे बढ़ता है, फिर वर्षा होती है, जब और आगे बढ़ता है फिर तूफान आता है। तो मैंने पूछा अपने मित्र से जो उड़ीसा का है कि भाई ये बताइए तूफान की दिशा कैसे होती है? बोले ये तो देखा नहीं की तरह बात पता है कि नहीं, उनको नहीं पता है, इंग्लिश के प्रोफेसर है। बोले कि उसने पहली बार एक तरफ से हमारे दिशा दी और जब दूसरी बार दूसरी बना, हाँ उसको ऐसे ऐसे घूमना था। 3 दिन में जो है जब शिफ्ट हुआ तो पहले इधर से हमारे तूफान आ रहा था, ऐसे हो गया, डायरेक्शन बदल गया। चलिए आगे चलते हैं। ये करता है ठीक है, बात को समझाना तो समझ में आ जाएगी। हाँ, क्योंकि कह दिएगा आँख मूंद कर आप खा जाइए तो शायद कितना भी स्वादिष्ट खाना बना आप खा नहीं सकते। सिर्फ जब तक पढ़ते हैं, समझने की कोशिश करते हैं। मेरे मन में भी कभी उठता है कोई चक्रवात, लहरों को मस्ता हिंदोलता कर कंपाता तट से टकराने को लगती, इतना चाहता है बरसना कि हो जाए जलकान, डूब जाए भूमि और पठार, मिट जाए सरवर, कर जाए उपन, कर जाए तोड़ते मरोड़ते साए साए करते दयावा। तब तो अवश्य ही कहीं किसी अवसाद का डेरा होगा, फसल या किसी विवाद का डेरा होगा, लंबी अवधि तक विस्तृत पर्व में मन के अब जो इधर का हिस्सा उसकी व्याख्या है, व्याख्या तब समझ में आएगी जब आप ऐसे किसी वर्गीकरण के मॉडल को समझेंगे, आगे बढ़ रहे हैं। इसका हमारे बहुत कुछ समझना कैसे चलिए आगे बढ़िए। ये देखिए जो कैसा समझ और यहाँ पर पहले अपराध होता है लगभग यहीं पर थोड़ा के टाइप का डाउनग्राफ होता है, हवा आती है और ये चारों तरफ हवाएं आती हैं, तो ये गर्म हवा ऊपर जाती है। चलिए आगे और बढ़िए, बढ़ते रहिए। ये दोनों इक्वेशंस हैं, नेविल-स्टोक्स इक्वेशन, इनको नालंदा में स्लाइस किया है, करें मत करें कोई बात, चलिए आगे बढ़िए। अब इसमें हमने u को लिया, ये चलिए आगे बढ़ते, ये माइनस c अपॉन r, आज जब इन्फिनिटी हो तो चलो, और जब जीरो हो तो इन्फिनिटी, हाँ तो मतलब इन्फिनिटी और माइनस इन्फिनिटी जरा बिल्कुल दिया जाए, थोड़ा मुझे आप टाइम दीजिए। अच्छा बताइए, ये जो हम अगर अर्थ के नॉर्थ पोल पर आप खड़े हैं, अर्थात फैला दें, जो बाहें फैला दें, तो आपके जो बाहें कितनी दिशा में होंगी? आज ये आप बंद कर लीजिए, किसकी दिशा में बाहें आती है? ईस्ट और वेस्ट, आप वहाँ ये नॉर्थ पोल पर खड़े हैं, कौन सी किस दिशा में है? ये किस दिशा में है? आपके क्या है? उल्टे क्या है दिशा? ये नॉर्थ पोल पर है, हाँ तो ये अरे वो नॉर्थ पोल पर है, कौन सी दिशा होगी? आप नॉर्थ आप कहीं नहीं है भाई, ये नॉर्थ पर है, इतना मालूम है। हाँ तो मेरे लिए नॉर्थ है, मतलब नॉर्थ पोल पर मेरे लिए नॉर्थ है, आपके लिए अरे वो नॉर्थ पोल पर खड़े हैं, नॉर्थ पोल जिधर होता है उसको नॉर्थ बोलते हैं, कौन सा नॉर्थ है? और मेरे लिए नॉर्थ है, वो ईस्ट ईस्ट कैसे हुआ? हम दोनों आपके साउथ ही हैं। आइए बैठिए, दिशाएं तक रिलेटिव होती हैं, दोनों हाँ, आपको उधर जैसे माइनस इन्फिनिटी और इन्फिनिटी आपको अलग अलग चीज़ है, आप बैठे हो गया, समझना आ जाएगा धीरे बात। आप दोनों के लिए मैं इधर था, उधर के लिए, दोनों के लिए नॉर्थ थे, बस हम दोनों आपके साउथ ही थे। माइनस इन्फिनिटी प्लस इन्फिनिटी इस बात को नहीं हाँ अनंता और माइनस अनंता मिलता है, तो माइनस लिया कौन आप? तो अगर आप इन्फिनिटी को तो ये सर जीरो इन्फिनिटी ऐसा होगा नहीं, मतलब वहाँ तक एक सिंगुलरिटी है, वहाँ अपने आ सकती है वहाँ तक, बस इसके बाद से ही ये हमारा टर्मिनेटिव फॉर्म होता है। आइए नीचे और बढ़ते जाइए, देखिए डब्ल्यू निकाला है हाँ, चलिए लास्ट में बात करते हैं, आगे क्वेश्चन तक पर अनेक वीडियो पर विषय यहाँ पर ये एंगुलर वेलोसिटी है, एंगुलर वेलोसिटी मुझे देख रहे हैं आप क्या है? 2 - c म्यू से अपन म्यू, अगर वहाँ जीरो कर दें तो क्या होगा? ये आर है, ये आर जो है इनर रेडियस है, मैं आपको बोल ले कम ही होगा। अगर 2 - c से अपन म्यू है, अगर वहाँ पर हम 2 कर दें तो क्या हो जाएगा? 0। ये 0 है, वो भी 0 होगा, नहीं है भी 0 होगा, सॉरी 1 होगा ना, 0 कैसे? मैं आर इन्फिनिटी हो जाए, ठीक है ना, लगता है ना? तो वेलोसिटी जो है कभी इन्फिनिटी होगी नहीं, आपको बता रहा हूँ। चलिए आगे बस जो ग्रेड मिला है आगे आप फाइनल ग्रेड पर आएगा, यहाँ पर ये क्या है, इंगल प्लस, ठीक है। आप देख रहे हैं ये वो जो है C/2 देख रहे हैं 1.99 कौन सा है, और 2.01। जब उसको सॉल्व किया जाएगा, लिमिट निकालेंगे आप, तो फाइनाइट लिमिट निकलता है। और क्वांटिटी कब होगी, जब वैल्यू ऑफ द फंक्शन एट दैट पॉइंट इज एक्जेक्टली इक्वल टू, तो हम जब 2 रखेंगे वहाँ पर, तो शुरू इक्वेशन में भी अगर C/2 को अगर आप 2 रख देते हैं तो तभी वही वैल्यू आता है, वही लिमिट। इसका मतलब द फंक्शन इज कंटीन्यूअस, दिख रहा था तो कंटीन्यूअस फंक्शन है। और यहाँ पर ठीक है इसकी वेलोसिटी बढ़ जाती है जैसे C/2 होता है। वही मैं आपको दिखाना चाह रहा था कि 10 कभी घूमते रहते हैं और एक तेजी से घूमने लगता है। लोग कहते हैं भाई क्या कारण है, लोगों ने अन्य कारण बताए। आगे प्रेशर का थोड़ा बताते हैं, असली यही है। ये क्या है, W है, ये आगे बढ़िए। देखिए यह प्रेशर वो जो है प्रेशर एरर है, एसिड के ऊपर आता है, प्रेशर एकदम बढ़ जाता है, ऐसे राइज करता है। ये कोई जादूगर नहीं है, मैथमेटिक्स में हमने करके देखा है। एंड देयर इज कंटिन्यूटी। हमने पेपर कैसे दे दिया था, इसको मैं पहले लिखा मस्ट बी पब्लिश, फिर नीचे बताया क्या कहा कि लिमिट निकाला, उस पर देखिए चेक करके पहले मैंने लगा कि ये सिंगुलैरिटी है, सर क्या रिमूवेबल डिसकंटिन्यूटी है। फिर जब चेक करेंगे वहाँ पर कोई डिसकंटिन्यूटी नहीं है, जैसे ही ऐसा होता है ये शूट अप करता है। और वातावरण जब ऐसा होता है और जहाँ C/u वो एक रेशियो है, वह जैसे 2 होता है वैसे ये वर्ग में तो हमेशा सब जगह क्यों नहीं मिलाता, बनना नहीं होता। जब वैसा बनता है तो जाकर ये फार्मूला हमारा दिया हुआ नहीं है, ये फार्मूला ईश्वर का बनाया हुआ। और ईश्वर के फार्मूला जब हम ढूंढ लेते हैं, कभी एग्जैक्ट फार्मूला मिलता है हमें, कभी हम उसके बहुत करीब होते हैं या आगे बढ़ने की कोशिश करते हैं, ये फार्मूला मिला। ऐसे ही बताइए उसके जेनेसिस है ही बताया। तो जो लो प्रेशर का बनना रहना जरूरी है चक्रवात के लिए, आपके मन के भीतर जब कभी ऐसा लो प्रेशर बनता है, न्यूट्रिशन आता है, तो आप बहुत धीरे गुस्से में आते हैं, चाहते हैं या फिर किसी विवाद का घेरा हो, विवाद किया हो, लंबी अवधि तक विस्तृत परिधि में जब आप ऐसा किया होगा तो फिर
Professor and former head of
फिंगर प्लस ठीक है। आप देख रहे हैं ये वो जो है C/√2 देख रहे हैं 1.99 1.98 कौन सा है और 2.01 जब उसको सॉल्व किया जाएगा लिमिट निकालेंगे आप तो फाइनाइट लिमिट निकलता है और क्वांटिटी कब होगी जब वैल्यू ऑफ द फंक्शन एट दैट पॉइंट इज एक्जैक्टली इक्वल टू, तो हम जब टू रखेंगे वहाँ पर तो शुरू इक्वेशन में भी अगर C/√2 को अगर आप 2 रख देते हैं तो तभी वही वैल्यू आता है, वही लिमिट। इसका मतलब द फंक्शन इज कंटीन्यूअस दिख रहा था तो कंटीन्यूअस फंक्शन है और यहाँ पर ठीक लिखा है इसकी वेलोसिटी बढ़ जाती है जैसे C/√2 होता है। वही मैं आपको दिखाना चाह रहा था कि डस्ट में घूमते रहते हैं और एक तेजी से घूमने लगता है। लोग कहते हैं भाई क्या कारण है, लोगों ने अन्य कारण बताए। आगे एक प्रेशर ट्राई थोड़ा बताते हैं असली यही है। ये क्या है W है ये आगे बढ़िए देखिए यह प्रेशर वो जो है कंप्रेशनल एरर है ऐसे क्यों पर आता है, प्रेशर एकदम ऐसे राइज करता है। ये कोई जादूगर नहीं है, मैथमेटिक्स में हमने करके देखा है। एंड ये रीजन देयर इज कंटिन्यूटी। हमने पेपर कैसे दे दिया था इसको एक पहले लिखा मस्ट बी पब्लिश, फिर नीचे बताया क्या कहा कि नहीं लिमिट निकाला उस पर देखिए चेक करके पहले तो मैंने लगा कि ये सिंगुलैरिटी है क्या रिमूवेबल डिसकंटिन्यूटी है, फिर जब चेक करेंगे वहाँ पर कोई डिसकंटिन्यूटी नहीं है। तो जैसे ही ऐसा होता है ये शूट अप करता है और वातावरण जब ऐसा होता है और जहाँ C/u वो एक रेशियो है वह जैसे 2 होता है वैसे ये वर्क में तो हमेशा सब जगह क्यों नहीं मिलता वरना नहीं होता। जब वैसा वातावरण बनता है तो जाकर ये फार्मूला हमारा दिया हुआ नहीं है, ये फार्मूला ईश्वर का बनाया हुआ और ईश्वर के फार्मूला जो हम ढूंढ लेते हैं, कभी एग्जैक्ट फार्मूला मिलता है हमें, कभी हम उसके बहुत करीब होते हैं या आगे बढ़ने की कोशिश करते हैं, ये फार्मूला मिला। ऐसे ही होता है उसके जेनेसिस है ठीक बताएगा। तो जो लो प्रेशर का बनना रहना जरूरी है चक्रवात के लिए। आपके मन के भीतर जब कभी ऐसा लो प्रेशर बनता है, जब आता है तो आप बहुत धीरे धीरे गुस्से में आते हैं, चाहते हैं या फिर किसी विवाद का घेरा हो, विवाद किया हो लंबी अवधि तक विस्तृत परिधि में जब आप ऐसा किया होगा तो फिर
Another So, with these words, I invite Professor Pankaj to deliver his.
So thank you so much for inviting me. First, I would like to thank the organizer of this conference. Of course, I am also part of the organization. Now it is 12:37, so I will try to conclude within the time, within 30 minutes. And of course, whatever just before me, Professor Pandey presented, I think that should be in place of me, because before lunch, some applications would be more helpful to listen carefully and importantly. Anyway, my area is rings and modules, and of course I am also working in applications of rings and modules. But today, title of my talk is Additivity of some multiplicative derivations. So without wasting much time on other things, directly I would like to come to the topic, and whatever the first I'll show you the basic facts about which almost all the things, because all are at least established in mathematics. So I'll start from very beginning of this topic, that is starting from ring, and then I will come to the actual. So this is the outline of my talk, basic concepts, skew semi-derivations, generalized skew semi-derivations. Of course, one section is missing there, that I will containing main results on the course. And then we have literature. Please go ahead. Many examples we have set of integers, set of rational integrals. We have finite rings, which have direct applications to the information and to the program. So after definition of ring, that's the definition of derivation. Of course, what derivation we have been using in calculus. This one is more generalized. The other derivations are more generalized. That's one of the example. So any additive math satisfying this condition, we are calling them derivations. Any additive, these ones. So again we have generalized derivation, and in case of generalized derivation, now you can see we have one derivation d, which has been used to define the generalized derivation. Capital D is the generalized derivation, the small d is the derivation. By using it, we are giving the definition of generalized derivation. Okay? After generalized derivation, we have definition of skew derivation. Of course, what's the meaning, literary meaning of skew? That concept is involved here. And here skewness is due to a new map phi. So now you can see delta x y equal to delta x y plus phi x delta y. So due to this phi, this skewness is coming. Next one. This is an example over the matrix in matrix of Visual. So that's the definition of semi-derivations. Now you can see, of course, not exactly derivation, but with the help of a map, additive map, which is the skew derivation. Again, we are introducing another map G, which has commuting with the H. So HGX equal to GHX. With this condition, we are coming to define the semi-derivation. Now this one is again what you have seen: derivation, generalized derivation, skew derivation, singularity parallel concepts. Which one? This is one of the examples of a semi-derivation. After that we have semi-derivation. So these are the generalizations. I don't want to go into that part. Go ahead. That's again the generalization. Associated examples have been given so that you can understand the concept. Next. Yes. Now look at this example. Even though we have considered the map alpha G, and of course a little bit computations giving us about the semi-derivations with the associated map G and automorphic alpha. But if we have particularized the element, then conditions have been not satisfied. So therefore, even though it is a skewed semi-derivation, but it is not a semi-derivation. Whenever we are discussing about a certain definition, certain terminology, then we are thinking about supporting examples, as well as we are looking for counter examples. Otherwise, under which condition, whatever assumptions are there, that has been not satisfied. So all those and those we are trying to see for the completeness of the study of our particular. Next page. Again, such type of examples we have considered here. Yes. Now I would like to come to the literature. So as you are looking at the article additivity of some derivations, semi-derivations. So whenever we are talking additivity, you are already seeing linear transformation. First condition is additivity. F over x plus y equal to fx plus fy. But it is not always true. And whenever we have been talking about over generally, then of course many cases it has been not satisfied. If it is homomorphic, then it is okay, that can be satisfied. Otherwise it is not true. So over the general structure we have been trying to study about the additivity of the numbers. So in this regard, Martin in 1969 studied and was published one of paper on multiplicative bisecting map on with non-trivial idempotent issues operation that was additive. After that, many work came into picture. Another one is of Silviki and Khan. He also proved about multiplicative semi-derivation on R, which are satisfying certain conditions, and then it would be an additive map. Of course, many more studies are there, but I would like to show you what we have studied based on the results. Whatever he extended in terms of semi-derivations, we have extended. Please go. Please go. So of course, after the study these papers, I have already put the question: under what condition do these multiplicative skew semi-derivations? We have studied showing about semi-derivations, generalized derivations, generalized semi-derivations, about the additivity. Now we have observed about the skew semi-derivations. Okay, so we have some of basic results, examples, assumptions we put there, and based on these assumptions, examples, what we have observed, under which condition it has been known for the additivity. we have established few results, and of course, to establish the results, certain assumptions we have assumed. So in this regard, we have considered three special maps to study all systems. If you go ahead, then three maps should be there. Three maps have been considered by us. Go back. I think from there I have already given. You don't will go. So we have considered the standard map, and with respect to that, we have tried to establish which group. So these are the lemma as we are aware. To establish any given results, initially we have been trying to establish a small results that would have helpful to establish the main results. So part by we have been trying to see, and of course one by one we have been going ahead. So after establishing these lemmas related to the additivity, now you can see there, if Aij, Rij, whatever Rij considered by us, then additivity holds. Similarly, lemma 5 tells about 4 elements, 3 elements, 4 elements, and in this way we have been going ahead, and then we have established this system that additive, d-additive. That one is then giving us dash additive on R. Please go ahead. I think yes, R we are in containing a non-trivial idempotent. As we are aware about the identity elements in ring, we have two types of identity. Additive identity, zero multiplicative identity, we are calling unity. And then we have been taking idempotent element, square of element to element itself. But whatever identity about identity I told you, often if you see in the ring I, certain things we have, and based on this result, we have this corollary from the previous theorem. Next, yes. So let R be with a non-trivial idempotent E. G is any map on R which vanishes at 0, because in the previous results we have seen for different I equal to 1, I equal to 2, what are the 0? What entries are 0? So based on that. So that's the complete picture of my this result. Of course, these all are related to the results additivity. Again, this is the main result. Same type of results you can see, but just conditions have been changed. Yes. Anyone who are interested to work in this area, I can provide this information. So thank you so much for listening to me. And I think within 20 minutes I have completed. Sir, yes.
This sounds very abstract.
Pardon?
It sounds really abstract. Would you like to
Application.
suggest something which one could visualize the concept that you explained to us?
Of course, your question is pertinent, and I think initially I already told you, even though we have been working over some of the particles that we call cryptography, but this work is really overripe. Okay, but even though what derivations, concept of derivations we have in algebra, for last 10 years we have been trying to use them in information and technology, in the construction of codes, which have got of communication by which our communication system, that has been added to our communication system. Everybody have been using email, mobile, computer, internet, and to the receiver safely. Okay, So for last 8 years, mathematicians have been trying to utilize the concept of derivation over ring to construct some data, and of course that has been provided. But handling ring with derivation is still not so easy. Many kind of computations have been involved. What we have been looking here, derivations, generalized derivations, semi-derivations. Later on, of course, application will come, but still we don't have applications currently. But of course, those who have been working over the analytical systems and in other areas, and if they are feeling that with the derivations, they are unable to cover the whatever the regions provided to them to control the solution, then certainly we are looking for the generalized structures. So these are the generalized structures. They form over which if you want, you can. That's all. Thank you, sir. Any other questions?
आपका एरिया वही है, मुस्लिम से सवाल थोड़ा हटके है। एक खेल मैंने पढ़ा था, और शब्द का अर्थ का मान से रिश्ता बड़ा गहरा, हमने तो कहा बादल और उसको सुना था। ये जो है, जो डेसिमल ने दिया, हमारे को पता है कि प्राइम नंबर से कर लेते हैं और इनको करना, ये हमने कहा बादल उसने सुना पानी, ये कैसे है? तो प्राइम नंबर का रोल है या केवल प्राइम रिलेशन का रोल है?
सर देखिए, आप अभी जो दो वर्ड आप यूज किए, प्राइम नंबर और प्राइम रिलेशन, प्राइम रिलेशन ज़्यादा जनरलाइज है, प्राइम नंबर उसका एक पार्ट है। तो मुझे लगता है कि जो पहले जो हम लोग करते आ रहे हैं, so now we are trying to look about this generalized, क्योंकि जो हमने पहले किया है, जैसे हमने पहले जो भी एप्लीकेशन आप देखेंगे, वेक्टर स्पेस, आप डायनेमिक्स में या जो भी प्रॉब्लम आप सॉल्व करते हैं, अल्टीमेटली सॉल्यूशन एग्जिस्ट इन अ फील्ड, am I right? Whether it should be field of real numbers, field of complex numbers, लेकिन अब सिर्फ फील्ड से ही काम नहीं चलना है, फील्ड से जनरलाइज नहीं, आप सिर्फ फील्ड लेते हैं तो बहुत सारी चीजें आप छोड़ देते हैं। यानी आपको जनरल सॉल्यूशन के लिए, ओवरऑल ऑब्जर्वेशन के लिए, जो आप पानी, बादल, बिजली जो चमकाइए, लेकिन अल्टीमेटली जनरलाइज पे आना पड़ेगा। तो जनरलाइज आपने बताया जो भी प्रकृति में चीजें दिखती है ना, सब आपके अंदर है, जो आपके अंदर है वो सारी चीजें प्रकृति में है। तो बस वही चीज है। अब आप कितना समझ सकते हैं, हम कितना समझ सकते हैं,
So any question or comment on this over his talk? So any query? If you don't have any question or comment, I just add one.
What are the advantages of this one, disadvantage of being system?
क्वेश्चन हाँ बोलिएगा।
What are advantages and disadvantages of being system?
Ring systems, I never seen any disadvantage. Whatever is available, they are all are advantages. Thank you.
So I just add one thing. Please. 2 minutes I asked the same question, which who asked what is the application of advantage, and also somebody asked what is the application of derivation and means and all that. Yeah. Same question I asked once upon a time when I was doing the master program of my mathematics. His flat and simple answer was, we do mathematics for the sake of mathematics. Number two, when you ask the same question, I mean, you see, how do we revise mathematics? when your mathematics, I mean, two straight lines never meet for your mathematics. But when you go to applied mathematics, yes, two parallel lines meet somewhere at infinity. Yes.
Not only that, it keeps moving.
But when it comes to modular or industrial mathematics, who is formulating real life problem, they say that two parallel lines meet at corner. So how you visualize the thing? Actually, you see, it's a lot of debate. Hardy sometimes told that this applied mathematics is applied mathematics, something like that. So pure and applied, sometimes it looks pure, but at later it becomes applied and all that. So in fact, we are mixing all the mathematics, all mathematics is pure. So just you do mathematics has several variables.
This is itself the generalized comment. It means so it doesn't mean. They don't mean. But the fact that you did say, whether by doing, when you go deep into it, because as you are working on this pure abstract mathematics, you are going into deeper and deeper. And then suddenly you got a flash. And that flash, whether you got or you will be getting in future due course, that flash is important where you will apply or where it will become so visible.
That's what the matrices were developed. Those mathematicians were not aware of the fact that once upon a time those matrices will be used for computation. But had the matrices not been there, you would not have done computation by writing computation. So it's not that we are doing this course, we are doing pure and very quality.
So with this, I think we are unending discussion on this topic here. Our Chandra is there, so now it's time to give moment to our Thank you very much, sir. Now, sir, please stay. Now, I invite. He is one of the organizers, but.
आप नहीं थे लेकिन बोल दिया होगा I'm also part of the organizing team.
So thank you very much. So this session is over, and now we go for lunch. Yes.
After lunch I think first balance is
भी बढ़ता है तो गणित का ही एप्लीकेशन, तो गणित का एप्लीकेशन सबसे महत्वपूर्ण हर विधा में है। इस कारण राष्ट्रीय व अंतर्राष्ट्रीय स्तर पर गणित की काफ़ी लोकप्रियता है। हर विषय की अपनी जगह है, लेकिन उन विषयों में गणित की सबसे महत्वपूर्ण भूमिका है। और जर्मनी में जब विश्व युद्ध हुआ था तो हिटलर ने ऑपरेशन रिसर्च वाले को बुलाया और कहा कि आप एक ऐसा फार्मूला डेवलप करो ताकि हम इसमें जीत पाएंगे। और मैथमेटिक्स का सहारा लेते उन्होंने काफ़ी उनसे सहयोग लेकर करके और जर्मनी में उस पर द्वितीय विश्व युद्ध में वो लड़ाई करने में काम किए थे। तो गणित की उपयोगिता हर जगह है। प्रोफेसर एनसी घोष जो सेवानिवृत्ति के बाद गणित के क्षेत्र में रिसर्च के लिए कई काम कर रहे हैं, राष्ट्रीय स्तर पर, अंतर्राष्ट्रीय स्तर पर। तो प्रोफेसर एनसी घोष बिहार मैथमेटिकल सोसाइटी से कई वर्षों से जुड़े हैं और कलकत्ता मैथमेटिकल सोसाइटी के जनरल सेक्रेटरी भी रहे हैं ये। तो आज हमारे सामने उपस्थित हैं, तो बहुत बहुत धन्यवाद सर को। मैं इस कार्यक्रम के लिए आभार हम लोगों की तरफ से है, नालंदा ओपन विश्वविद्यालय और बिहार मैथमेटिकल सोसाइटी से, कि आप यहाँ आए और 2 दिनों से जो परिचर्चाएँ चल रही है काफ़ी इंटरेक्टिव, बाला सुब्रमण्यम साहब हों, पीयूष चंद्रा साहब हो, इतनी बड़ी गणितज्ञ की समागम एक अद्भुत इस नालंदा के ज्ञान स्थली पर हुआ है। तो हम सभी सौभाग्य है कि हम इस कार्यक्रम को यहाँ नालंदा में जो ज्ञान की स्थली है, जो एक समय 10,000 छात्र यहाँ पढ़ते थे, 1,000 से अधिक शिक्षक रहते थे, उस गौरव परंपरा को बढ़ाने के लिए माननीय मुख्यमंत्री जी ने हमेशा प्रयास और तत्पर रहे हैं, और उनका विशेष कृपा इस नालंदा के लिए विशेष रूप से रहता है। तो थैंक यू सर, आज ये कार्यक्रम में थैंक यू सर।
Perhaps this is the first international conference in Nalanda Open University, and most notably, main theme of this conference is exploration of excellence in mathematical sciences. For me, for a student of mathematics, I think we should be proud for that, because this seminar, this conference is on mathematics. And beginning of this conference, dignitaries who are here emphasizes on mathematical talents should be explored among the young generation particularly. I think it is essential to say people mathematics is nothing but it is life's experience. Soviet mathematicians used to say mathematics is nothing but language. You see, when people used to live in caves, they used to select particular caves, not all caves. Length, breadth, depth, they consider whether that cave is really habitable or not. Mind it, during that period language not evolved. So, mathematics, concept of mathematics, people used to apply before evolving language even. And we the people lives either in town or in village, whatever it may be, we are continuously using mathematics. But till then, some people used to say, our governor also said, I am afraid of mathematics. Though always we are using mathematics, we are continuously using mathematics in everywhere, every time. Till then, we are saying we are afraid of mathematics. That is the problem. So, to enthuse young people particularly, I have selected topics like cyclone or tsunami, where mathematics is useful to analyze. Initially I thought I will speak in modern tense in mathematics education, because last before 1 year I came and I did deliver a lecture on that. So this year I have decided not to speak on that. I have decided to speak on turbulent flow. You know, turbulence is an unsolved problem till today. Last century, Heisenberg, Cosmograph, Prandtl, Taylor, etc. has done a lot of work. Even Einstein, his last student Preston, he get this problem to solve turbulent flow problem. You see, Leonardo da Vinci, he was not scientist according to present people, but he had drawn a picture of turbulent phenomena. Though then scientific study of turbulence not started, even not imagined. What happened? Something happened. Leonardo da Vinci had drawn a picture of turbulent flow. And what he wrote, it is in language, is given here. Also English version is here. This is picture, what Leonardo da Vinci drew. This is another picture by Vincent van Gogh. You know, well-known artist. Then when turbulent phenomena was started to analyzed by scientists, recursion first started, and he said, big wheel have little wheel that fit on their velocity, little wheel have lesser wheels, and so on viscosity. I am not going details because viscosity, etc., is known to all mathematicians, particularly applied mathematicians. Heisenberg once said, if there is God and I can meet him, I will ask him about turbulence. No other question he will ask. According to Heisenberg, he told, if there is God and if I can meet him, I will ask him about turbulence. Because Heisenberg was really in trouble to analyze turbulence. Though he has written a lot of equations, lot of what he has done, but till then he told this. Why it is essential? I told you, it is the most difficult problem, and for a complex situation, today's people cannot avoid turbulent flow study. Yesterday, when a person from Algebraic University was talking about signal processing, image processing, one of the students asked, how this noise can be controlled? This is really problem. Problem, why? Because noise goes, if you see the television, you will see something, it is noisy. Why? Because signal is coming through the atmosphere, and it is dusty and other, particularly in the atmosphere, is disturbing the noise signal. So, if atmosphere is turbulent, then it is become more complicated. So, without knowing about the turbulence of the atmosphere, it is not possible to control. So, for simple example, I think all of you are now convinced why this study is essential. I told you just a few minutes about the atmosphere aspect. Signal is one control, cyclone, tsunami is also atmospheric phenomena. So, for this, it is essential to study turbulent phenomena. For weather forecasting, at least 5 years or 10 years back, it is used to have an experience when television or radio, we have to know the cyclone is coming or raining is coming, but that day is completely dry. Why? That is because very less portion yet today is clear to us about the turbulence of atmosphere. Moreover, the data we are used to have at that time from different centers, thousands and thousands of centers in India, in different places, in particular time, every day in particular time, they collecting data, they have to send those data in different centers, and analyzing those, we have to declare weather forecasting. But nowadays it has been improved. Solar is, many places solar is there. So we have data from solar and other things from satellite images, we can have the information, and matching local data, ground truth data and solar data and satellite data, and nowadays we can almost accurately can say about weather forecast. Because in meantime, turbulent phenomena aspect is also been known to us many parts. I told you to know about the cyclone. To know about the cyclone, a turbulence study is essential. Very good. I told you about the tsunami because it is extremely turbulent. People who are aware of this last tsunami, how people were really suffering. So it is extremely turbulent. So anything to do to rescue the people, knowledge of turbulence is essential. That is ocean turbulence. Many people have experience about the gas turbine. Within the gas turbine, flow is completely turbulent. Hydel plant, perhaps you have experience in hydel plant. The water is coming from the reservoir. It's very turbulent. So without considering turbulent phenomena of those water, how that mechanism will be built? So it is most essential to know the turbulent phenomena of the fluid in barrage. It is essential to know, and accordingly engineering measures should be taken. Common experience, there are lots of chimneys in town areas, particularly the gas fluid is coming on through the chimneys. That is completely turbulent. Picture is there. For artificial rain, sometimes in drought period, in many governments nowadays used to make artificial rain so that harvesting can be done. And for that, we have to study the turbulent phenomena of the atmosphere. Now, we are sending satellite. Now we have already sent satellite to moon and planning to satellite other places also. And America trying to search another stars, another universe. So there are also continuously turbulent phenomena is going on. Particularly in the sun, continuous gas is moving. So in there it is continuous turbulent phenomena is going on. But the people, we have to know about that if we want to go really around the outside our universe. That is called stellar turbulence. The stenosis problem. When I was a student, I asked head of the department of Calcutta University Applied Mathematics Department, sir, is turbulence possible in body? He got bored. Why are you asking about this? Really, it was shocking at that time for me. In the year 2001, I was cerebral patient. For 17 days, I was in coma state in ventilator machine. No doctor thought that I will survive. But due to your blessing, I am quite well and here delivering lecture. In the year 2003, I was invited to Ranchi. There, a professor from Pilani, BIT, Pilani, came, young boy. He delivered a lecture there. Turbulent phenomena, how the turbulent phenomena is the cause of heart attack. I was surprised to hear his lecture and tempted to ask a question. Have you any paper or any knowledge about the turbulent phenomena which may be cause of cerebral hemorrhage? The young boy told, no, sir, no, I don't know anything. But from his word, I was really tempted and searching papers, searching words in different net or literature. And ultimately I could develop a model. Turbulent phenomena is the cause of cerebral hemorrhage also. And our body, in particular time, particular moment or particular case, turbulent occurs. May not be survived for a long period, but occurs. So this is called stenosis problem. Now, these are the outline of turbulence. For that, we have to know salient features of the turbulence. To go through the turbulence study, we have to know the salient feature. You know, it is here a smoke. How it is whirling. How it is whirling. It means vortex is there. So, we have to know the vortex equation. And some complex partial differential equation. And this is physics. You see that fluid mechanics people know the Reynolds number. There is a critical Reynolds number. When fluid flows, a certain point it becomes semi-turbulent, then turbulence. That is called critical Reynolds number. For different fluid, according to the basis on the viscosity, a critical Reynolds number is different. Not same for all. For water, it is which the Reynolds number is. For another liquid, that is oil or like that, any other liquid, is not same. Because it depends on the viscosity of liquid. This is interaction. What we observe, our physical phenomena, about the theoretical idea what is behind it, and then more. Because without theoretical ideas, we cannot do anything for modeling. What we are seeing is physical phenomena, but we should have theoretical aspects of this phenomena. Then we can model it. Otherwise, it is not possible at all. Here, just what I told you, from Vinci to Amor, it is here. How mathematical concepts is analyzed for turbulence. For that, we have to know first where the turbulence of what is generated. I told you, depending on Reynolds number, laminar slowly becomes to turbulent. So, the point where the turbulence is generated, for modeling, we have to know first. Then, how long the turbulence will maintain and when it will rest. Because when turbulence started, ultimately it decays and it becomes rest. Vijay told you, we have to see cyclone, and after some time, when raining started, turbulence phenomena becomes, that means cyclone becomes slow down. That means turbulence of the air slowly decaying, and then one time it becomes completely decayed. You know, basics of this field is derivations equation. You must have to start with the derivations equation. It is here. There is a common two types. One is Taylor's method, and another is Kolmogorov method. You know, Kolmogorov is a Russian mathematician. He has done turbulence study in statistical way. But Taylor is on algebraic. I am lucky to meet both of them. One in Calcutta, India, and in Moscow. Another study, because those who are till date, I told you, those who are till date, it is really very little part is known. A new concept, mathematical concept, when coming up, people are trying to attack this problem with that new tools, mathematical tools. Wavelet problem, you know, wavelet analysis is a new tools. So people are trying to solve this problem with the help of wavelet. Another tool has come, that is called factor analysis. Some people have done some work, and also wavelet, using wavelet I have also done some work. But fractal I have not done. But people are trying to do some study with the help of fractal. And many people are trying to solve this problem with fuzzy analysis. I think now it is clear why we will study turbulence, what is the turbulence, and why we will study it, and how mathematicians can contribute. Young people, I am sure young people if desire, it is a vast area to do work, and future is glorious if they can proceed. Thanks. If any question, please. Okay. Oh, sir. Very nice question from the young person. When cyclone is very severe, some scientists suggesting that send a plane on the cyclone vortex and inject something. I told you, when after raining, cyclone decaying. So from that experience, scientists are saying, send a plane there and spray something so that momentum of the airflow in the cyclone, it's called eye. So when moving, this particular point is called eye of the cyclone. If you can spray something there, and whether air becomes heavy, then cyclone will decay. That is the idea. But the problem is, the plane when try to enter in the eye, it will be damaged. It may be damaged. So some techniques are going to be involved yet, and scientists are trying that. With this idea, with the help of this idea, injecting some salt or like that, because you know salt is quickly absorbing water. So they are trying this model, and experience has done. Rudy of Germany, he has done this work, and he took risk to go into the eye, and he was in danger at that time. So the boy is asking, really, interesting question, and people are trying. It is yet to develop. Okay? Any more question? Thank you. Things from satellite images, we can have the information, and matching local data, ground truth data, and solar data, and satellite data, and nowadays we can almost accurately can say about weather forecast. Because in meantime, turbulent phenomena aspect is also been known to us many parts. I told you to know about the cyclone. To know about the cyclone, a turbulence study is essential. Thank you. I told you about the tsunami because it is extremely turbulent. People who are aware of this last tsunami, how people were really suffering. So it is extremely turbulent. So anything to do to rescue the people, knowledge of turbulence is essential. That is ocean turbulence. Many people have experience about the gas turbine. Within the gas turbine, flow is completely turbulent. Hydel plant, perhaps you have experience in hydel plant. The water is coming from the reservoir, is very turbulent. So without considering turbulent phenomena of those water, how that mechanism will be built? So it is most essential to know the turbulent phenomena of the fluid in barrage. It is essential to know, and accordingly engineering measures should be taken. Common experience, there are lots of chimneys in town areas, particularly the gas fluid is coming on through the chimneys. That is completely turbulent. Picture is there. For artificial rain, sometimes in drought period, in many governments nowadays used to make artificial rain so that harvesting can be done. And for that, we have to study the turbulent phenomena of the atmosphere. Now, we are sending satellite. Now we have already sent satellite to the moon and planning to satellite other places also. And America trying to search another stars, another universe. So there are also continuously turbulent phenomena is going on. Particularly in the sun, continuous gas stuff is moving. So in there it is continuous turbulent phenomena is going on. But the people, we have to know about that if we want to go really around the outside our universe. That is called stellar turbulence. The stenosis problem. When I was a student, I asked head of the department of Calcutta University applied mathematics department, sir, is turbulence possible in body? He got bored. Why are you asking about this? Really, it was shocking at that time for me. In the year 2001, I was cerebral patient. For 17 days, I was in coma state in ventilator machine. No doctor thought that I will survive. But due to your blessing, I am quite well and here delivering lecture. In the year 2003, I was invited in Ranchi. There, a professor from Pilani, BIT, Greece, Pilani, came, young boy. He delivered a lecture there. Turbulent phenomena, how the turbulent phenomena is the cause of heart attack. I was surprised to hear his lecture and tempted to ask a question. Have you any paper or any knowledge about the turbulent phenomena which may be cause of cerebral hemorrhage? The young boy told, no, sir, no, I don't know anything. But from his word, I was really tempted and searching papers, searching words in different net or literature. And ultimately, I could develop a model. Turbulent phenomena is the cause of cerebral hemorrhage also. And our body, in particular time, particular moment or particular case, turbulent occurs. May not be survived for a long period, but occurs. So this is called stenosis problem. Now, these are the outline of turbulence. For that, we have to know salient features of the turbulence. To go through the turbulence study, we have to know the salient features. You know, it is here a smoke. How it is winning. How it is wind. It means vortex is there. So, we have to know the vortex equation. And some complex partial differential equation. And this is physics. You see that fluid mechanics people know the Reynolds number. There is a critical Reynolds number. When fluid flows, at a certain point it becomes semi-turbulent, then turbulence. That is called critical Reynolds number. For different fluid, according to the basis on the viscosity, a critical Reynolds number is different, not same for all. For water, it is which the Reynolds number is. For another liquid, that is oil or like that, any other liquid, it is not same because it depends on the viscosity of liquid. This is interaction. What we observe, our physical phenomena, about the theoretical idea what is behind it, and then model. Because without theoretical ideas, we cannot do anything for modeling. What we are seeing is physical phenomena, but we should have theoretical aspects of this phenomena. Then we can model it. Otherwise, it is not possible at all. Here, just what I told you, from being sick to Amor, it is here. How mathematical concepts is analyzed for turbulence. For that, we have to know first where the turbulence of what is generated. I told you, depending on Reynolds number, laminar slowly becomes to turbulent. So, the point where the turbulence is generated, for modeling, we have to know first. Then, how long the turbulence will maintain and when it will rest. Because when turbulence started, ultimately it decays and it becomes rest. Vijay told you, we have to see cyclone, and after some time when raining started, turbulence phenomena becomes, or that means cyclone becomes slowed down. That means turbulence of the air slowly decaying, and then one time it becomes completely decayed. You know basics of this field is Navier-Stokes equation. You must have to start with the Navier-Stokes equation. It is here. There is a common two types. One is Taylor's method, and another is Kolmogorov method. You know, Kolmogorov is a Russian mathematician. He has done turbulence study in statistical way. But Taylor is on algebraic. I am lucky to meet both of them. One in Calcutta, I in India, and in Moscow. Another study, because those who are till date, I told you, those who are till date, it is really very little part is known. A new concept, mathematical concept, when coming up, people are trying to attack this problem with that new tools, mathematical tools. Wavelet problem, you know, wavelet analysis is a new tools. So people are trying to solve this problem with the help of wavelet. Another tool has come, that is called fractal analysis. Some people have done some work, and also wavelet, using wavelet I have also done some work. But fractal I have not done. But people are trying to do some study with the help of fractal. And many people are trying to solve this problem with fuzzy analysis. I think now it is clear why we will study turbulence, what is the turbulence, and why we will study it, and how mathematicians can contribute. Young people, I am sure young people if desire, it is a vast area to do work, and future is glorious if they can proceed. Thanks. If any question, please. Correct. Oh, sir. Very nice question from the young person. When cyclone is very severe, some scientists suggesting that send a plane on the cyclone vortex and inject something. I told you, when after raining, cyclone become decaying. So from that experience, scientists are saying, send a plane there and spray something so that momentum of the airflow in the cyclone, it's called eye. So when moving, this particular point is called eye of the cyclone. If you can spray something there, and whether air becomes heavy, then cyclone will decay. That is the idea. But the problem is, the plane when try to enter in the eye, it will be damaged. It may be damaged. So some techniques are going to be involved yet, and scientists are trying that. With this idea, with the help of this idea, injecting some salt or like that, because you know salt is quickly absorbing water. So they are trying this model, and experience has done. Rudy of Germany, some Rudy of Germany, he has done this work and he took risk to go into the eye, and he was in danger at that time. So the boy is asking, it's a really interesting question, and people are trying. It is yet to develop. Okay? Any more question? Thank you.
लेकर के आइए।
Particularly a subject like turbulence. So, here this seminar is excluding excellence in mathematical science. I always tried to explore mathematical concepts among the people, not only on students, but even common people, because I believe many mathematical concepts are among the people, common people. Our duty is to explore that concept. 14%. They never ask you what to do. They come from their common experience they are doing. When I am writing books for the Particular Board of Secondary Education, I did not know the use of LCA and SCF. At that time, having experience from many people, I could having knowledge to explain why we are using it. So that man has no child, nothing, no man to authorize him. Then what will happen? I asked my student, what will happen? They told me, sir, government will take, or some organization of the local bodies will take. They are not sure who will take it. That means something different is undefined. It is a physical example. So thus we can say from turbulence to everything, to our student, to our common people, surrounding us, the method is not at all hard. It is not, at least not a question of fear or tears. Only to see from your own eye surrounding you mathematics. Thank you.
सामने से हट जाइए लोग, सामने से हटिए।
वो हमारे इस कार्यक्रम में उपस्थित हैं, मैं उनका आभार और स्वागत करता हूं कि इस गणितीय अधिवेशन में हम सभी को गणित के बारे में जो देश दुनिया में रिसर्च पर कार्य किए जा रहे हैं वो हम सभी को अवगत कराएंगे। आपका रिस्ट्रिक्टेड थ्री बॉडीज प्रॉब्लम पर ये अपनी परिचर्चा रखेंगे और काफ़ी इनकी शोध अंतर्राष्ट्रीय स्तर पर प्रकाशित किए गए हैं। कई जर्नल का प्रकाशन, कई शोध वर्क, तो हम सभी शुक्रगुजार हैं कि हम सभी के आज अपने वक्तव्यों से हम सभी को अवगत कराएंगे और काफ़ी आप लोगों को लाभ मिलेगा। तो कार्यक्रम अब शुरू करते हैं और अपना वक्तव्य रखेंगे। थैंक यू वेरी मच।
Khagol, name derived from a famous observatory which was situated in the Nalanda. So it is a very important place where we are today, where in this Nalanda our great astronomer Arithmetic studied and gave very important contributions. He was first man who gave heliocentric theory 1,000 years ago, about 1,000 years ago from Kepler. So, and he told there is a slope Sarva Disanam Surya Surya Surya, means when one sun sinks below the horizon, 1,000 suns take its place. So this is our glory of our ancient India. After that, although our credit has gone to Hello. So it was better there. It was better there. Secondly, surrounded by a wind. So at first, we are going to discuss about what is the restricted three-body problem. So you know that Newton formulated in the 17th century two-body problem on the observation of the motion of moon around the earth, around the earth, the motion of the earth around the sun, the motion of the sun around the galaxy, or simply say that what black hole, and the motion of the galaxy around the center of the universe. So that's why he was first who formulated two-body problem. And two-body problem was solvable. He solved very easily two-body problem. After that, he added one body in the two-body problem. But he did not know what complexity will come by adding one more body in two-body problem. When he formulated three-body problem, when he started to solve three-body problem, then he could not solve this problem. He tried so many times, at least he tried 2 times at the interval of 16 years. And lastly he tired, and he complained that three-body problem gave him headache and kept him awake. This was like this. So since then, several mathematicians, several astronomers started to solve three-body problem, but nobody was able to solve this problem. After a long time, around 18th century, then people started to make some assumption so that they can solve three-body problem. But it was difficulty to make new assumption because the assumption should be valid mathematically and physically also. Then, although the credit has gone to Lagrange, but before Lagrange, there was a astronomer or mathematician whose name was Euler. But this credit is not gone, has not gone to him. So Lagrange, and what he did out of three-body problem, the mass of the third body, he taken so small that this mass is not able to attract two massive bodies, remaining two massive bodies, but its motion is governed by them. Then he called restricted three-body problem, and he solved this problem. He got 5 solutions. That's why, and that solution corresponds to equilibrium points, liberation points, or Lagrange points. That's why you know in this recently you have seen India has sent Aditya L1 point, Lagrange L1 point. But Lagrange is in the honor of Lagrange. This point was given, but actually this is liberation point, you can say, or you can say equilibrium point, all are same thing, or even a stationary point. So what is a stationary point or Lagrange point? Lagrange points are those points at which the velocity and displacement components are zero. It means that if you put anybody at Lagrange points or equilibrium points, it should stay for a long time. So this is the equilibrium points. Now we have discussed about restricted. Now our title is restricted three-body problem. So in the beginning, in the restricted three-body problem, the body which has more mass, that is called massive body or primary, first primary. The second body which has lesser mass is called secondary or a smaller primary. And the body which has negligible mass, that is called third body. Like for example, third body may be our satellite, or like if you consider the motion of the moon in the gravitational field of our sun and earth. So that's why in that case, the natural example of the restricted three-body problem is the motion of the moon in the gravitational field of the sun and earth. Otherwise, when we launch a satellite, the motion of satellites in the gravitational field of the earth and the moon, that is also restricted three-body problem. When massive bodies move in the circular orbit, then we call circular restricted three-body problem. When massive bodies are moving along the elliptic orbit, then we call elliptic restricted three-body problem. In the circular restricted three-body problem, the distance between two massive bodies is always constant. It does not depend upon time. And therefore, the Hamiltonian of the dynamical system is time independent. So we are able to get one integral, that is called Jacobi integral. But in the elliptic problem, the distance between two massive body is variable. And this is a function of time. So that does not, it's a Hamiltonian, is also time dependent. So it is difficult to establish or to derive Jacobian integral in that case. This is the difference between these two. So after that we have used, so classical restricted theory, in the classical restricted theory body problem, it was assumed that the body, the orbits of the body, finite bodies are circular. Their masses are constant and they attract only force in the nature. There are several forces acting on a body. So that's why since then people try to include different type of perturbations so that calculation or value should be close to only force. Like this one, we have albedo, or we come, sorry. So we have discussed this one. So we have added, you see in the title there is a last perturbing force. Now we have Cooper belt. Here is no cable. There is a Cooper belt. So it affects the motion of our satellites. So that's why we have considered a belt surrounded by the Earth and Moon. Secondly, we have albedo. What is albedo? Oh, already I told you the shape of the finite bodies or massive bodies are taken to be spherical. But in real situation, all planets are not in a spherical shape. Like the Earth, the Jupiter and Saturn are sufficiently oblate. Similarly, our Moon and Pluto and its moon Charon, all are traxial rigid. So what is traxial rigid body? What are oblate bodies? In geometry, all bodies are a type of spheroid, ellipsoid. So if they are in ellipsoid is a three-dimensional body, if suppose A, B, C are its axes, semi-axes, and if two axes are equal but greater than third one, then we have oblate body. If all three axes means A equal to B equal to C, then we have circular body. If A, B, C, all these three are unequal, like A greater than B greater than, then you have traxial rigid body. So this is shape of traxial rigid body. Here is you have oblate view. This is what is happening like. Here is no cable. Here is okay, but that's why I feel bad that yes, he has never asked him like this. The fraction of this reflected radiation means albedo equal to reflected radiation back to the surface, back to the space divided by incident radiation. So if reflected, if suppose all incident radiation is absorbed. In that case, the value of albedo is 0. Suppose none part of the incident ray or radiation is not absorbed, then we have, or means total is refracted, then we have the value of albedo is 1. So the value of albedo lies between 0 to 1. So if a body has albedo value 0 or nearby this, then we call black body. If a body has albedo value 1 or around 1, then we call white body. The black body temperature is higher, but the white body temperature is lower. So this is the effect of albedo. So in the figure, the Earth's albedo fluctuates with the changes in clouds, with the changes in season, and its effect on the satellites depends upon the altitude of the satellites, optical construction or optical properties of the satellites. So therefore, albedo effect is important in considering the motion of a satellite. So that's why we have considered albedo effect. So this is your albedo. So already we have discussed about assumptions of the restricted three-body problem. So the fundamental concept about restricted three-body problem, which you know, Newton's law of motion, or Kepler's law, or Newton's law of universal gravitation. So all are there. So already we have discussed about the gap of the research, because in the classical problem only gravitational force is considered when we consider the motion of a satellite. But apart from gravitational force, apart from gravity, there are several forces acting on the satellite. So out of several attracting forces, only we have taken into account here only 4: albedo, shape of the body, like axiality or obliqueness, and build. So already this one, yeah. Aim is already like this one, to consider the motion of, or to determine the motion of the principal mass in the gravitational field of two massy bodies, which are axial or oblique and surrounded by a belt, and they are affected with albedo effect. So we have discussed at first equation of motion of a satellite in the elliptic body problem. Then we have obtained collinear points, and after that we have considered its stability, and finally we have discussed about periodic orbits around these points. Semi-analytic approach we have used, and Mathematica we have used to solve our complex equation. So this is significance. Already I have discussed about restricted few body problem. If you have n equal n body problem, you can say that if n equal to 3, then you have 3 body problem. If n equal to 4, then you have 4 body problem. What is area of this one? Which are shown in this table. So this is our restricted three-body problem like this one. Here, you see here you have L3, L1, L2. These are Lagrange points. These are Lagrange points in the Sun-Earth system. So here, on the left side you have bigger mass, that is our sun. Right side you have a smaller mass, that is our earth. And between sun and earth you have L1, and opposite side of earth you have L2, and L3 point is far away from the sun, opposite side, in the opposite side. So this is the transfer of orbits. So in simple way, what is the stability? If we give a small displacement, what you say that if we push a body with a small velocity, with a small displacement, and if the body oscillates considerably for a considerable time around that point, that is point is called a stable point. Otherwise it is called unstable point. This is in simple definition of stability. Now we come to our main problem. Here you see this one. This is our restricted three-body problem. M1 is the more massive primary, M2 is a second or a smaller primary, or you say the first primary M1, M2 is a secondary, and M3 is the most of our satellite or any body, or anything you can consider, like or in celestial body you can consider. Means the smallest body in mass with respect to mass. R1 and R2 are distances of our satellite from the M1 and M2, and R is the radial distance. Here F1 and F2 are gravitational force acting on the satellite due to M1 and M2, and Fe is the satellite in the opposite direction of gravitational force. Here the line joining the first primary and second primary y-axis, and similarly we are formulated like this one, the y-axis and the type. So you are familiar with this one. So this is our equation of motion. So here double prime denotes differentiation collinear points. Collinear or equilibrium point. At equilibrium point, the velocity component and acceleration component both are 0. So that's why if we substitute single prime, double prime term on the left hand side 0, then we have right hand side omega x equal to 0, omega y equal to 0. In the value of this one, omega x, omega eta, omega beta, we have three equations, equation 5, 6, 7. If we observe equation 6 and 7, then that is the factor of in the 6th equation, that is the factor. It means that eta equal to 0 or its coefficient is 0. Similarly, in the case of 7th equation, beta equal to 0 or its coefficient is 0. So, collinear point, if we can solve first equation, that is eta equal to 0, beta equal to 0, then we have collinear point or collinear Lagrangian point. So, in this way, we have 5 collinear points. So, if we put eta equal to 0, beta equal to 0 in the first equation, then we have equation 8, and if we solve this equation 8, then we have collinear equilibrium point L1, L2, L3. In notation, only we have to keep in mind which region we are considering. The region between the two massive bodies, or the region outside, left side of the more massive prime, or right side of the smaller prime. So this, if we think like this one, then there is no any confusion. Otherwise, if you read, I told you, I am telling like this here, you will read any textbook or any other research paper, then you see naming notation is different. So, but this is the main thing. And another thing is, it is not necessary always we keep more massive primary on left side and a smaller primary means right side. We can keep more massive right side and a smaller mass on the left side. Only difference will come in solid. Only difference will be in the agile coordinate or x coordinate with negative sign. And all calculation, all nature of stability will remain same. There is no any difference. So that's why it depends upon which side you want to keep more multiplying and less multiplying. So here we have substituted xi equal to 0, zeta equal to 0 in the first equation. Then we have seen 8 equations. Now we want to solve So there are 3 cases. So first case we have considered here M1 is left side, M2 is the right side, M1 is our bigger primary or first primary, M2 is our smaller primary or second smaller mass or second primary. So we consider L1 point on the left side, L1 point in the launching of our Aditya. So that point L1 is called in between M1 and M2. We have taken between M1 and M2, like between Earth and Sun. But so that's why I make clear that no need to confuse in the notation. So L1 I have considered the left side of M1 at a road distance, and you see M1 has coordinates xi1 with value is mu is the mass ratio, mu equal to M2 divided by M1 plus M2. This value lies between 0 and 1. Since mu equal to M2 divided by M1 plus M2, if M1 and M2, if M2 is equal to 0, then we have to equal equal. And if M1 and M2 both are equal, then we have mu equal to half. So maximum value, the maximum value of mu will be half. So if you have and 0 is when you have M2 equal to 0. So you see the 0 and half. The value of 0 and half is called the degenerate case. So here the coordinates of L1 now will be our aim is to find the value of coordinates of L1, means position of L1, first level L1 point L1. So when we substitute the value mu equal to here R1 will be rho and xi1 will be mu. So if we substitute all these values, then we have equation 9. When we solve with the help of mathematics, then we do. So numerically I have solved, so we have stopped here. Now similarly we have considered second diagram point L2. So here L2 is between M1 and M2. In the case of Aditya, you have L1 instead of L1 this one. So here we have considered L2. The position of L2 is at a distance rho on the left side of M1. So that's why coordinate becomes here mu minus rho. And R1 will be rho and R2 will be 1 minus rho. So if we substitute all these values, then in equation 8, then you have equation 10. The solution of this one will give us L2 value. Similarly, when we consider third Lagrange point, the third Lagrange point is situated on the right side, left side of M2 at a distance rho. So its value coordinates will be minus 1 minus mu minus root, because we are going left hand side. And O is the center of mass which we have considered origin of our coordinate system. So in this case again you have RT is equal to O, and when we substitute all these values in the equation number 8, then we have equation number 11. So when we solve equation number 9, 10, 11, after solving equation 9, 10, 11, then so it will give us, because all you see all the value will give us the value of 9. Then we substitute in 3 cases. Exact value of, like in the case of L1 you have mu1 plus the value of 2. In the case of L2 you have mu minus root, in this case corresponding value of 2. And in the case of L3 you have 1 minus mu minus root, like this, the value of rho in this third case. So we have solved with the help of mathematical. So you see this one, we have considered our Earth and Moon system. So Earth Moon, in the Earth Moon system, the mass ratio is coming equal to this one. Completeness of the Earth A is given by this one. Already we have seen numerical value. Its semi-axis is like this, is the value of this one, and the value of T is equal to this one. When we consider substituting all these values in the equation, corresponding equation that one, then we got L1, L2, L3. So you see this one, the position of L1. So you see this one, the value of L1 means position of L1 is increasing, which increase of any of these parameters. So this is exact. It means that the position of L1 is moving towards, sorry, this is the value of L1 is position is decreasing. So that's why the position of L1 is shifting towards the origin. Same in the case of L2, you will see this one, you have the negative value, but this is also in the negative direction, this is decreasing. It means that L2 is approaching towards or shifting towards the origin from the left hand side. And L3, the value of L3 is, you see this one, is also decreasing on the left side. It means that the position of L3 is shifting from the origin, shifting towards the, away from the origin. But after some value, again it starts to move towards the origin. Last two value is shown like this. So this is the graphical presentation of this shifting and effect of these parameters in all these 3 cases. Now we come to stability. So already we have discussed what is stability in simple way. So with the help of either value of a linear system, we have discussed stability. So if we, already I told you, if we give some small displacement in the party or a body, so that's why our displacement, the value of displacement becomes xi equal to xi naught plus sigma theta equal to required theta value in the pointer points 0, but after giving some displacement, that's why you have 2, and theta equal to 0, that's why you have 1 value. So it means that sigma, theta and gamma are a small displacement given to the coordinates of the any Lagrangian point. So when we substitute this value in the equation, and then we get 3 equations that is called rational equations of motion. The last equation The second partial derivative, here we have upper asterisk denote the means that the second partial derivative are evaluated around or at the equilibrium point under consideration, and already the second sub-asterisk denotes the second partial derivative. So third equation, the coefficient of gamma is negative. So therefore we can easily solve last equation and we get a bounded solution. Bounded solution means we have a stable solution. So that's why the motion of satellite was called test particle. Along the z direction or zeta direction, we have a stable motion. Now we come to the first two equations. Then to solve first two equations, we have taken tried solution sigma equal to p exponential lambda gamma and 2 equal to q exponential gamma lambda gamma. So this is the stability. The nature of stability depends upon the nature of gamma. So we have calculated all these values. At first we have considered first Lagrangian points. So corresponding to L1 we have this value equation 40. So the value is greater than 0. Similarly equation 15 we have got less than 0 value, means negative side, and mixed partial derivative, the value of mixed partial derivative becomes 0. So that's why similarly we consider L2 and L3 point. In all cases we have second partial derivative with respect to algebra greater than 0, means omega not eta eta less than 0 and omega beta eta equal to 0. So due to this one, so we have solved this one. We substitute the value of this one by considering all these unit values, and this is L1. So the value of, because our characteristic equation is biquadratic equation, so that's why that must be 4 values of lambda. So the two values you have lambda 1, lambda 2, another two values you have lambda 3, lambda 4. So two values are real but opposite in sign, and other two values are complex conjugate. So that's why if you observe this, then you will see that in each case there is at least one positive real number. So due to this one, our stable, the point is unstable. So that's why we call this one. Similarly, L1, L2, L3 means collinear points are unstable. But we have not discussed here points L5, L4, L5, that is rectangular points. They are stable points. They lie on the vertices of a triangle whose base is the line joining the massive body, two bodies. But that points are stable, but they are far, very far. So it's like a practical point of view. It is not possible to make any station or colony on the L4 point or any L5 point for any system, Earth, Moon or Earth, Sun. For any system it is very difficult to establish a space colony or any one other station. So that's why L1, L2, L3 points are unstable, but it has more importance than practically it is very taken dry solution sigma equal to p exponential lambda gamma and 2 equal to q exponential gamma lambda gamma. So this is the stability. The nature of stability depends upon the nature of gamma. So we have calculated all these values. At first we have considered first Lagrangian points. So corresponding to L1 we have this value equation 40. So the value is greater than 0. Similarly equation 15 we have got less than 0 value means negative side, and mixed partial derivative, the value of mixed partial derivative becomes 0. So that's why similarly we consider L2 and L3 point. In all cases we have second partial derivative with respect to algebra greater than 0 means omega not eta less than 0 and omega beta eta equal to 0. So due to this one, so we have solved this one. We substitute the value of this one by considering all these unit values, and this is L1. So the value of, because our characteristic equation is biquadratic equation. So that's why that must be 4 values of lambda. So the 2 values you have lambda 1, lambda 2, another 2 values you have lambda 3, lambda 4. So 2 values are real but opposite in sign, and other 2 values are complex conjugate. So that's why if you observe this, then you will see that in each case there is at least one positive real value. So due to this one, our stability, the point is unstable. So that's why we call this one. Similarly, L1, L2, L3 means collinear points are unstable. But we have not discussed here points L5, L4, L5, that is rectangular points. They are stable points. They lie on the vertices of a triangle whose base is the line joining the massive body, two bodies. But that points are stable, but they are far, very far. So it's like a practical point of view. It is not possible to make any station or a colony on the L4 point or any L5 point for any system, Earth, Moon or Earth, Sun. For any system it is very difficult to establish a space colony or any one other station. So that's why L1, L2, L3 points are unstable, but it has more importance than practically it is very
I think he didn't get your question. Have you any other question? Then you will ask. Yes,
sir, one question. How can I measure the albedo effect?
How you can measure the
albedo effect?
I gave you.
मेजर कैसे करेंगे सर?
मेजरमेंट कैसे?
मेजरमेंट का केवल आपको फार्मूला दिए।
सर ऐसे यदि मेजर करना हो
एक बार चलिए आपको बताते हैं पहले ही सिग्निफिकेंस। जरा इसको देख लीजिए। मैंने आपको बता दिए थे शुरू में, मूव नहीं कर रहा है। देखिए सेलेस्टियल मैकेनिक्स का हम लोग थ्योरेटिकल करते हैं, समझ गए? थ्योरेटिकल वर्क केवल करते हैं, और आपको जो दूसरा पार्ट है इसका एक एस्ट्रोनॉमी है, तीसरा पार्ट जो है इसका इंजीनियर्स लोग जो हैं वो करते हैं, और जितना रिजल्ट आता है, जितना रिसर्च हो रहा है संसार में, उसका निचोड़ लेकर के, रिजल्ट लेकर के जो रिजल्ट उपयोगी होता है कि उसके आधार पर जो डिजाइनर होता है सैटेलाइट का उस तरह से करता है। मेजरमेंट तो आपको मैंने टेलीस्कोप है, बहुत तरह का इंस्ट्रूमेंट है, उसके आधार पर केवल हम आपको थ्योरेटिकल आइडिया दें।
100% अगर हम इसका यूज 100% इस बात से जो ऑब्जेक्ट उसका यूज करें जिससे कोई इफेक्ट हो सकता है, हम भूल भी हो सकते
इफेक्ट तो बताएं,
100% की बात करें, 100% जो ऑब्जेक्ट उसका यूज करें।
मैंने शुरू में ही आपको हम बता दिए कि all bodies, all celestial bodies are not white. समझ गए?
like a mirror, 100% इफेक्ट यूज करें तो इफेक्ट नहीं।
इफेक्ट तो आपको बता ही दिए, आपको जो टेबल बताया वो इफेक्ट ही बता रहा है।
मिरर का यूज करेंगे जैसे इम्पैक्ट होगा, सही है कि गलत है, 100%।
अच्छा, मैं जैसा समझ रहा हूँ आप सर के लेक्चर हो गए हैं, अब आप बैठकर डिस्कस करेंगे। जिस भी पैनल में सर बैठते हैं वहाँ बैठकर डिस्कस कीजिए, बिकॉज वी आर ऑलरेडी डीलिंग हियर, सो आई थिंक यू कैन आस्क क्वेश्चन। थैंक यू सो मच फॉर योर नाइस प्रेजेंटेशन। नाउ आई वुड लाइक टू रिक्वेस्ट वाइस चांसलर प्रोफेसर के.सी. सिन्हा to give a token of memento of this conference. Please. Now parallel session will go ahead. Have any announcement, Randhir? No. कोई और रणधीर? So no announcement, then we can go for parallel session. If outside tea है, अभी बाहर आ गया है. Okay, so 10 minutes tea break, and after that parallel session will go ahead. Thank you.
Integer order derivative are considered. Fractional order partial differential equation. Fractional order differential equation consists of integer other than integer order, means its order will be delta alpha u by delta t alpha, where alpha may be in between 1 or 2 or in between 0 and 1. So a new concept of fractional partial differential equation. So there is a, in real phenomena you see there is a case of super diffusion or sub diffusion. So there is, whenever you consider only integer order derivative, only diffusion is considered. But depending upon what is the order of fractional order, whatever you expect to be diffused, it will be diffused more rapidly. And sub diffusion is whatever you consider it will result in less direction. So there are many types of fractional order derivative introduced in book like Capital, Non-Learning, but in the process of solution, only capital fractional order derivative is considered. So we consider the fractional order derivative with capital cells. Next one. Memory derivative introduced by Wang and Lee. Actually, the concept of fractional and memory derivative, every function has a memory. Means every body part or every body part has different memory. Means whatever goes to increment on our body, it responds with different amount. So there is a kernel function kt alpha is introduced, and t minus epsilon is sleep time. Means depending upon what is epsilon, sleep time is different, and this is the kt.
In 1988, Beck was the one who introduced the concept of zero divisor and discussed its chromatic number. Then in 1999, Anderson and Houston redefined the definition of Beck's concept of zero divisor and discussed the various properties of graph theory. Later in 2008, Anderson and Baldwin introduced the total graph concept or the commutative graph, and the concept of balance. The concept of balance sign graph was introduced by the Harare and studied the various properties in 1950. zero element in a completed ring R is said to be a zero divisor. There is no zero element B in R such that the their product is equal to 0. If 4 are the zero divisor elements of ring Z6. Graph is an ordered pair of vertex and edges set, and here is an example of the graph. This is a Peterson graph of 10 vertices and 15 edges. Total graph of the completed ring R denoted by T of gamma is an undirected graph which all elements are the vertices. Here all elements of 0, 1, 2, 3, 4, 5 are the vertices, and 2 vertices are adjacent if their sum belongs to zero divisor element. Sign graph. Sign graph is a graph in which edges has a positive or negative sign. So here example in figure 3 we have a U V W X graph in which UX UV
SB and SH. SB means vertically polarized circle and SH means horizontally polarized circles. Next, surface waves. Surface wave, first surface waves is polar wave. This name comes after British seismologist A.E.H. understood word of love. For the propagation of love wave, which is basically horizontally polarized wave, the presence of at least one superficial layer is required. In love wave, there is no particle motion in the vertical plane. And next, second surface wave is Rayleigh wave. In Rayleigh wave, there is no particle motion in the horizontal plane, and the velocity of Rayleigh wave is greater than that of love waves. Next slide. Next. Another kind of surface wave may also be available in non-homogeneous path, which is known as torsional media when it propagates. The main objective of my presentation is the possibility of existence of torsional surface waves in an initially spaced anisotropic low velocity layer. Formulation of my problem is, this is the geometry of the problem. Here M1 is layer and M2 is half space. Layer in the propagation of torsional surface waves. Initial space is meant by the astrophases developed in a medium before it is being used for study. This initial space when developed in a medium due to the natural phenomena or by any artificial process. Due to the variation in temperature, external pressure, slow process of heat, and manufacturing process, etc., huge quantities of stresses are stored in the medium. graphs which are also the conclusion part of this table. Next slide. Next slide. Particular next. Yes. This part is very we show that initial space plays an important role in the propagation of cosmic surface wave. Here, in figure 1, 2 and 3, figure 1, 2, 3 represent the curves without initial, when there is no initial space in the layer, and curve number 4, 5 and 6 represents when there is initial space present in the layer. In which two figures we are saying that initial space plays an important role as
What should I read?
So there is various applications
Say one application.
in computer science and in networking also.
Laymen students don't know computer science, don't know
Just like if we connect the if we construct a road,
Yes.
there is a map.
That is the question.
Yeah. There is a map. And
Thank you. That is that is. I was because laymen should know mathematics what it is around him. Am I clear?
Yes.
We are teaching graph theory starting from some point, mathematical point. No. You should show him mathematics is around him. Say you are building a room, 2 rooms in your house, in your plot. You have to decide what that house or building will be. And that concept purely graph theory conception. However, you cannot do. We are using that concept spontaneously. That is called spontaneous mathematics. But that is mathematics also. But people don't know that is mathematics. Okay, thank you. इसका बाद दिखा क्या नाम?
Present my paper on the topic of study and isomorphism of finite solvable group and its impact. And I'm not a research scholar right now because I'm just doing my coursework. After that, I will be called as a research scholar. I'm just doing a research scholar right now. So my abstract is in this paper. We have studied about finite group and conditions of finite solvable group. The composition factors of every finite solvable group are isomorphic to cyclic groups of time order. We have also studied various applications of solvable groups like applications in Galois theory, where solvable groups are used to prove that polynomial equations of degree greater than 4 are not solvable using a finite number of additions, multiplications, and root extractions. Second, we discuss the polycyclic group, which is a solvable group satisfying the maximal condition of subgroups. We proceed with polycyclic representation and specific applicability. So I will define some of the keywords which I use in my abstract. First one is finite group. A group of finite number of elements is called a finite group. Order of a finite group is finite. Next, subgroup. A subgroup is a subset of a group that is self-group. One with a composition series where all the composition factors are available, or as one with a subnormal series where all the quotients are available. There are some conditions of finite solvable group. A finite group is termed a finite solvable group if it satisfies the following equivalent conditions. First, it has composition factors, and all its factors are there. Isomorphism of finite solvable group. Every two finite solvable groups of the same order have the same composition factors. The composition factor
we have to set now what?
Okay, thanks. Any question?
And in third day of the conference, again, first talk is of Professor R. Balasubramanian. It's my pleasure to introduce him in front of you, even though on the first day, many times introduced by different dignitaries. During the inauguration, Professor K.C. Sinha and others have been introduced. Then in his first keynote, introduced by Professor Piyush Chandra. And it's my pleasure to say something about Professor R. Balasubramanian, Padma Shri R. Balasubramanian. May you can knowing about the candidates for Bhatnagar Awardee. Before 45 years, scientists have been getting that award, and he is one of the awardee of Bhatnagar Awardee, Professor R. Balasubramanian. Even though he is of more than 73 years, but before time, I think at 9:05, he was ready and waiting for the vehicle to come at the time, and later and program will go accordingly, what's the schedule is. He has many contributions in number theory as well as in algebraic number theory, and I am fortunate that 2 or 3 theses of my students evaluated by him. So with this brief note, and of course whatever he has discussed in his first lecture, just continuing it, I am going to show something about the number theory and what's the related area in which people can work in future too. So with these words, I would like to invite Professor R. Balasubramanian for his talk.
Since I was not feeling well, I could not give the lecture yesterday. Today I am giving the lecture. Okay. Again, let me continue on number theory. See, number theory has many aspects. One studies about prime numbers, that's one aspect. Some transcendental number theory. Then additives, meaning essentially writing an integer as a sum of integers of a special type. And for example, most of you would have known about the Goldbach's conjecture. Goldbach's conjecture is the statement that every even number can be written as sum of 2 prime numbers. And this Goldbach's conjecture is still not solved yet. And there is another aspect of additive combinatorics, another aspect of number theory, which I have come in the recent past, maybe in the last 20 years, which is called additive combinatorics. That is, doing combinatorics in number theory. This has many aspects, and there is something called the Ramsey theory, and I will just introduce something like the Ramsey theory, but probably I won't talk much about that, and then some free sets. That's all. What is Ramsey theory? Operate this. So if you move, there it moves, right. Oh, page up page. Okay. Okay, fine. Yeah, first of all, what is Ramsey theory? Ramsey theory says the following: you have all the integers, and when you look at all the integers, they have some property. But now you don't take all the integers, you take the integers and color them with some 3 colors, blue, green and yellow. And then whatever properties that all the integers have can you find within the blue color alone or within the green color alone? Okay. Therefore, if you can find out a property within one single color, that property is called a monochromatic. Therefore, mostly what you would be interested is, there are many equations which can be solved in integers, and now you are asking whether they will have a monochromatic solutions, which means that if you take all the integers and color them, whether the equation will still have a solution in one single color. That's exactly what is that. We illustrate this by means of what is called Schur's theorem. Therefore, the Schur's theorem says the following: let R be a natural number, then there exists a natural number capital N which depends upon R, such that the following holds. What does it say? It says that if you look at this equation x plus y equal to z, and then x plus y equal to z has of course a solution in integers. You can write a lot of solutions, 2 plus 3 equal to 5, 7 plus 9 equal to 16 and so on. But on the other hand, now what I am asking is that if we take all the integers and color them, therefore the 1 will be colored blue, 2 will be colored green, 3 will be colored yellow and 7 will be colored blue. The 3 color I am giving. And now I want a solution for this equation x plus y equal to z, where x, y, z all belong to the same color. Therefore, if x, y, z, everything should be green or everything should be blue. And if that happens, then it is called a monochromatic solutions. And the first result in this direction was proved by Schur, and Schur proved that if you look at this equation x plus y equal to z, then this equation does have a monochromatic solution, which means that whichever way you color the integers, and you should take only finitely many colors, but then you can take as many colors as you want. You can take some 250 colors and then color them any way you want. Even then, this particular equation x plus y equal to z will have a monochromatic solution. That is where the whole thing started. And in fact, the reason why Schur did it, I won't go into the proof details, but the reason why Schur did it is there is something called a local global principle in number theory. For example, you have an equation and then you want to know whether that equation has an integer solution. If you want to know that the equation has an integer solution, then it should definitely have a solution modulo p. Because if 7, 23, 47 is a solution in integers, the 7, 23, 47 will also be a solution modulo p. Okay? Therefore, if there is any solution, there will be a solution modulo p. Now something called the local global principle says that if you have a solution modulo p for every p, does it really mean that it will have a solution in integers? Okay, and that is one important question which is discussed in a number theory things, but I won't go into that. And somehow that is exactly what Schur wanted to prove. Schur wanted to prove that given any n, there will be some modulo p for which this equation x power n plus y power n equal to z power n, modulo p will not have a solution, and therefore you will conclude Fermat's last theorem. Okay? I wonder how many of you have not heard Fermat's last theorem? Is Fermat's last theorem a familiar name for all of you? Okay, can I assume that? Okay. Therefore, he wanted to prove Fermat's last theorem, and therefore he wanted to prove that the Fermat's last theorem does not have a local solution, and therefore he wanted to know that if you take an nth power and add another nth power, whether it can be in nth power modulo p. And unfortunately, he proved that the Fermat's last theorem cannot be proved by that way, because whatever attempt he made, that failed. But in order to do that is what he should prove his theorem. Okay, and this is a proof. I don't think I have time for that. Okay, but now the next question is, Yeah, Radha's theorem, etc., probably I will skip. And now the question is here dash. Yeah, this is the important thing. Now the question is, now we are going to ask a question not about x plus y equal to z, but about the question x plus y equal to 2z. Therefore, now you are asking whether there is a monochromatic solution for this equation x plus y equal to 2z. Of course, x plus y equal to 2z has a lot of solutions in integers. For example, 3 plus y equal to 2 times 4, 7 plus 13 equal to 2 times 10, and so on and so forth. But now you are asking, but if on the other hand, if I take all the integers and finitely color them, if I color finitely many integers, if I color the integers finitely many, but I did not even take all the integers. I take integers up to a large level, from 1 to n. I take integers up to 1 to n, and then finitely color, and then is it necessarily true that this equation x plus y equal to 2z will have a solution? Okay, I will say something about this now, and then I will come back to this x plus y equal to z a little later. Now you see, if this x plus y equal to 2z has a solution, that means the numbers x, z and y are in an arithmetic progression. Therefore, you are now asking the simpler question, namely that if you have if you take the integers and then color them finitely many, then is it necessary that is at least one color will have a 3-term arithmetic progression? That's the question you are asking. Okay, therefore I take the integers and color them, and I want to know whether they will have a 3-term arithmetic progression. And in this particular thing, L' conjecture, no, it was already proved by Van der Waals. Van der Waals proved that if you take it and then a 3-term arithmetic progression will be there. But there is a theorem, difference between Schur's theorem and Van der Waals theorem. The Schur's theorem, you know that there is a solution, but it is not necessarily true that that box which contains the maximum number of elements will have a solution. The solution may be in a box which contains a smaller number of elements. But in Van der Waals theorem, L' conjecture that the box which contains the maximum number of elements will have a solution. In other words, if you take the integers 1 to n and you take a subset A, and provided this A has a positive density, which means that this A is bigger than alpha times n for some fixed alpha. Therefore, you cannot take a small set, but take a big set. The big set should have at least n over 2 elements, or n over 10 elements, or n over 57 elements. Okay? Therefore, it should have a positive density. And therefore, if the A has to be bigger than alpha times n, if A has a bigger than alpha times n, then it has an arithmetic progression of 3 terms. And in fact, L' went further. L' went further that not only it will have an arithmetic progression of 3 terms, it will have an arithmetic progression of any number of terms you want. Therefore, you take a set A such that mod A is bigger than alpha n, and of course I am assuming that the capital N is sufficiently large, and if the capital N is sufficiently large, and if you take a subset A which is bigger than alpha times n, then this set A will have an arithmetic progression of some 378 terms. You can even fix how many terms you want. Okay. You can fix that I want an arithmetic progression of 1023 terms. Then is that if, and this alpha again you can fix very small. Alpha can be something like a 1 over 1000. Therefore, if you take a set A contained in n, which is cardinality of A bigger than 1 over 1000 times n, then this A will contain an arithmetic progression of 1023 terms. Just needs a positive progression, which is definitely not true for Humphrey. And if I have a Humphrey set, then it is not necessarily, okay, anyway I'll come to that a little later. Okay, now this is the interesting, this conjecture turned out to be one of the very important conjectures, and this more or less started the study of this additive combinatorics. This conjecture was proved by for k is equal to 3 by K.F. Roth in 1953. Okay, and he used what is called a circle method, which I did explain yesterday, namely a method which was developed by Hardy and Ramanujan to study partition functions. And using that, he proved that if the cardinality of A is bigger than alpha times n, it will have a 3-term arithmetic property. Then k equal to 4 was proved by Sammardi. Sammardi, as most of you would have known, was a great combinatorics person, and he proved in 1969. And Roth again proved the same thing in 1972 by his circle method. And the general case was proved again by Sammardi, and the method is combinatorics. I mean, Sammardi's proof was called a masterpiece of combinatorial reasoning by L'. It is a very, very difficult proof. But because this theorem is very important, then many people try to give other proofs, not necessarily using combinatorics. And the proof came from Furstenberg in 1977, and he used what is called the ergodic theory. And then Gowers proved in 2001 using Fourier analysis, and the result related to K approximate group, about which we will talk later. And of course, Gowers did a lot. I mean, Gowers is one of the big names here, and he introduced the Gauss norm, which has been important for many processes. And now let me define what is an approximate group. What is an approximate group? Suppose G is a abelian group and A is okay. And suppose I take a subgroup H and a subset A of a coset. Then when you add two cosets of a subgroup, then you will get a third coset. Okay, which means that the cardinality of A plus the cardinality of A will be the cardinality of A plus A will be the same as cardinality of A, because A is a coset and I take one coset, let us say 3 modulo 7, and I take another coset 5 modulo 7, and then when I add 3 modulo 7 and 5 modulo 7, for example, I will get the full 1 modulo 7, and therefore A is there in A 3 modulo 7, then A plus A will be there, essentially because that is an idea of a subgroup. A plus A will be equal to A. And a K approximate subgroup means, first of all, let's say G be a commutative abelian group, and consequently we write the group operation additively. Therefore, our group operation is additive. Therefore, our group operation is plus. And if G is a commutative abelian group and A is a finite set, then we say that A is a K approximate subgroup if cardinality of A plus A is less than or equal to K times cardinality of A, which means that when you take the A and another A and add A plus A, okay, let me explain what is A plus A means. A plus A means you take an A1 from A, A2 from A, and add A1 plus A2, keep doing it for every pair, but then sum of the A1, A2 can apply many times, multiple times, okay, but you look at it as only as a set, which means that if it appears many times, then you take it only once. Okay? Therefore, A plus A, yes, which we have defined. Therefore, A plus A can be defined as those elements of the group where G can be written as A1 plus A2, where A1 is an element of A and A2 is an element of A. Remember, the point is the same G can be written as, may be written as A1 plus A2 more than one time. Probably you can write G as A1 plus A2 7 times. The thing is, of course, you don't count the G 7 times, you count the G only once. You view it only as a set. Therefore, only view as a set, then the A plus A, the cardinality will go down, because many elements may have multiple representations, and then the representation will go down. And after that, if A plus A is only up to a constant times capital A, then it is called an approximate. Now there are questions about approximate groups which I won't bother about. Yeah. Now ask the question. I don't even need to yell free. Yes. Okay. Now one can ask the question. Yes, some free set. This is the question: X plus Y equal to Z. Therefore, when I say a set is sum free, that means this equation x plus y equal to z does not have a solution. That is equivalent to say that x plus y equal to z does not have a solution is equivalent to saying that if you take a plus a and another a and intersect, the intersection is empty. That is what sum free means. A plus a intersection a is empty. And you can of course define L3. L3 is a1 plus a plus a plus a L times intersection a should be empty. That is called L3. And not much is known about L3, therefore we are only talking about the sum free sets. Therefore, now we are only asking sum free set, which means that L equal to 2. Therefore, I am only asking, I have a finite abelian group G, and once I have a finite abelian group G, which is written additively, therefore addition is a group operation. Therefore, and then I take a set A and then add A to A, then you have an A plus A, and I want A plus A to have a empty intersection with A, which means that no element of A can be written as A1 plus A2. If no element of A can be written as A1 plus A2, that is called a sum. That is exactly the equation which you originally saw, x plus y equal to z. And now one can say something. Suppose you take 1 to n, and in 1 to n you take odd integers. Odd integers are nearly n over 2. If the odd integers are nearly n over 2, still they do 78 terms. You can even fix how many terms you want. Okay. You can fix that I want an arithmetic progression of 1023 terms. Then is that if, and this alpha again you can fix very small. Alpha can be something like a 1 over 1000. Therefore, if you take a set A contained in N, which is cardinality of A bigger than 1 over 1000 times N, then this A will contain an arithmetic progression of 1023 terms. Just needs a positive property, which is definitely not true for sum free. And if I have a sum free set, then it is not necessarily, okay, anyway I will come to that a little later. Okay. Now, this is the interesting. This conjecture turned out to be one of the very important conjectures, and this more or less started the study of this additive combinatorics. This conjecture was proved by for k is equal to 3 by K.F. Roth in 1953. Okay, and he used what is called a circle method, which I did explain yesterday, namely a method which was developed by Hardy and Ramanujan to study partition functions. And using that, he proved that if the cardinality of A is bigger than alpha times n, it will have a 3-term arithmetic proportion. Then k equal to 4 was proved by Chamaridi. Chamaridi, as most of you would have known, was a great combinatorics person, and he proved in 1969, and Roth again proved the same thing in 1972 by his circle method. And the general case was proved again by Chamaridi, and the method is combinatorics. I mean, Chamaridi's proof was called a masterpiece of combinatorial reasoning by L'. It is a very, very difficult proof. But because this theorem is very important, then many people try to give other proofs, not necessarily using combinatorics. And the proof came from Furstenberg in 1977, and he used what is called the ergodic theory, and then Gowers proved in 2001 using Fourier analysis, and the result related to K approximate group, about which we will talk later. And of course Gowers did a lot. I mean, Gowers is one of the big names here, and he introduced the Gauss norm, which has been important for many purposes. And now let me define what is an approximate group. What is an approximate group? Suppose G is a abelian group and A is a, okay, and suppose I take a subgroup H and a subset A of a coset, then when you add two cosets of a subgroup, then you will get a third coset. Okay, which means that the cardinality of A plus the cardinality of A will be the cardinality of A plus A will be the same as cardinality of A, because A is a coset and I take one coset, let us say 3 modulo 7, and I take another coset 5 modulo 7, and then when I add 3 modulo 7 and 5 modulo 7, for example, I will get the full 1 modulo 7. And therefore A is there in A 3 modulo 7, then A plus A will be there, essentially because that's an idea of a subgroup. A plus A will be equal to A. And a K approximate subgroup means, first of all, let's say this G be a commutative abelian group, and consequently we write the group operation additively. Therefore, our group operation is additive. Therefore, our group operation is plus. And if G is a commutative abelian group and A is a finite set, then we say that A is a K approximate subgroup if coordinate of A plus A is less than or equal to K times coordinate of A. Which means that when you take the A and another A and add A plus A, okay, let me explain what is A plus A means. A plus A means you take an A1 from A, A2 from A, and add A1 plus A2. Keep doing it for every pair. But then sum of the A1, A2 can apply many times, multiple times. Okay? But you look at it as only as a set, which means that if it appears many times, then you take it only once. Okay? Therefore, A plus A, yes, which we have defined. Therefore, A plus A can be defined as those elements of the group where G can be written as A1 plus A2, where A1 is an element of A and A2 is an element of A. Remember, the point is the same G can be written as, may be written as A1 plus A2 more than one time. Probably you can write G as A1 plus A2 7 times. Which is, of course, you don't count the G 7 times, you count the G only once. You view it only as a set. Therefore, only view as a set, then the A plus A, the cardinality will go down. Because some many elements may have multiple representations, and then the representation will go down. And after that, if A plus A is only up to a constant times capital A, then it is called an approximate group. Now there are questions about approximate groups which I won't bother about. Yeah. Now ask the question. I don't even need to L3. Yes. Okay. Now one can ask the question, a sum free set. This is the question x plus y equal to z. Therefore, when I say a set is sum free, that means this equation x plus y equal to z does not have a solution. That is equivalent to say that x plus y equal to z does not have a solution is equivalent to saying that if you take a plus a and another a and intersect, the intersection is empty. That is what sum free means. A plus a intersection a is empty. And you can of course define the L3. L3 is a1 plus a plus a plus a L times intersection a should be empty. That is called L3. And not much is known about L3, therefore we are only talking about the sum free sets. Therefore, now we are only asking sum free set, which means that L equal to 2. Therefore, I am only asking, I have a finite abelian group G, and once I have a finite abelian group G which is written additively, therefore addition is a group operation, therefore, and then I take a set A and then add A to A, then you have an A plus A, and I want A plus A to have a empty intersection with A, which means that no element of A can be written as A1 plus A2. If no element of A can be written as A1 plus A2, that is called a sum. That is exactly the equation which you originally saw, x plus y equal to z. And now one can say something. Suppose you take 1 to n, and in 1 to n you take odd integers. Odd integers are nearly n over 2. If the odd integers are nearly n over 2, still they do. Which of course was not the case for an arithmetic progression. Arithmetic progression says if the cardinality of A is bigger than alpha times n for any alpha which is positive, then already it will have a solution. But that is not true for sum free set. Even up to the density half, you may have sets which do not have a solution. Now the same question, the sum free sets we are asking for finite abelian group. Sum free set A, and I want to know what can I say about the sum free set A. Therefore, what is the cardinality of the sum free set? These are the questions which we are related. Okay, now the answer to these questions seem to depend upon the order of the group G. And if the order of the group G, therefore we say that G is a group of type 3, the question becomes somewhat more difficult. The type 2, the G is divisible by order of G is divisible by 3. Those two types are easy. And in fact, the first two questions, what is the cardinality, what is the classification, that was provided by Nalanda and Yap, is not type 3 a complete answer. Till 2005, the answer to the first question of type 3 groups was known only in a very special cases. Okay, G is of type 3 as we defined if all the divisors of its order are congruent to 1 modulo 3. If all the divisors are congruent to 1 modulo 3, it's determined to the. And then you have two subgroup H and K. And now let us assume that the two subgroup H and K are isomorphic. Then you would like to know whether there is an automorphism of G which is restricted to H gives you K. In other words, if there are two isomorphic subgroups, whether this isomorphism can be extended to an automorphism of a full group. And that is a question called a Burnside question, which has not been solved completely, even in the case of the finite abelian group, and that's where we have a problem in really solving the question completely. And with that, I think I will stop it.
So thank you so much, sir. Any quick questions you can ask within a minute, please, so that we can go for the next. Yes, please.
Sir, in number system, I write cardinal number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why 10 is a row of single digit? 10 is a stand in single digit.
10 is not single digit, yeah.
Yes. 1 to, I know 1 to 9 as single digit.
Yeah.
But it's row vertically. Why 10 stand there?
Oh, why is not single digit? That's an interesting question. Okay, let's answer that.
There are many questions right here.
Know about the world by different, okay, I can even use this. The number system was developed throughout the world by different civilizations. And the different civilizations came to the representation of numbers in various symbols. Okay? And let me talk about something which is not related to, which is essentially the Roman symbols. Okay? In the Roman symbol, there is no question of why 2 digits, etc. What they did was, if they wanted to write 573, they created a symbol for 500. Okay. They created a symbol for 50. They created a symbol for 10, which all of you know is yes. They created a symbol for 1, which all of you know is 1. Therefore, 573 would be written as 500. I think, what is that? D plus 50 is L plus 20, which is x plus x, plus 3, which is I plus I plus I. This is how they wrote the numbers. Okay? This, as you can see, has many problems. Okay? Number one, then if you want to write a bigger number, okay, like 1,78,493, then you should now create a symbol for 5,000, create a symbol for 10,000, create a symbol for 50,000, create a symbol for 1 lakh, and so on. You can write it. And now you can imagine, if you write numbers like that, and if you want to add 2 numbers, okay, there's absolutely no way you can do it. No? If I now tell you CBXYI plus DXIII, what is the sum? It's not something which you can ever do. Okay? Therefore, this system of creating a symbol for each one has its own disadvantages. Okay? But on the other hand, the Indians developed something called the decimal system. Okay? This decimal system involves a zero. Okay? And of course, now we know that probably the Indians were not the only people who did it, and the Chinese also did it, and so on and so forth, but essentially it is attributed to India. Okay? And there, once you write the decimal system, which means that you can have only the whole idea is you have only finite number of digits. Okay? Therefore, you don't have one digit for 1 and 1 for 5, 1 for 10, 1 for 50, 1 for etc. But you have only 9 digits, which is exactly, if you are using computer, you only 2 digits, 0 and 1. And then try to write every number in terms of only those 2-3 digits by using again the positional advantage, where you are putting 573 is not the same as 375. Okay? Whereas V111 is the same as 111V, because that's all what you are doing. Okay? Therefore, with a limited number of digits, if you have to write all the integers, there is no way you can essentially do it with only 1 digits. If you write 1 digits and you want to write up to 1 lakh, then you need 1 lakh symbols. We don't want to do that. Therefore, somewhere you have to go to the 2-digit number. Where you go to 2-digit number is called the base. If you write 1, 2, 3 of 9 and then 10 as a 2-digit number, it's called a base 10. If you write 0, 1 and then immediately 1, 0, that is a binary. 0, 1, 2 and then for 1, 0, 0 is base 3. That's how it will go.
Thank you. Any other questions, please?
Yeah, I think he wants one.
Yeah.
Order of the group can be 0 or not.
Sorry?
Order of the group.
Can be 0 or not.
Once you have a group G, at least you have one element. When you define a group G, you don't have a group G with no element at all. I mean, that group doesn't make sense.
That should be non-empty, no?
Yes, the group has to be non-empty. But you can have one element.
Non-empty. Yes. Thanks. Any other questions? I think one question I have already taken. Last question you will ask outside the room. Thank you so much, sir. Thank you so much, Professor Sri R. Balasubramaniam, for his nice talk. And he has given flavor of many branches of number and encourages to all of us to work in future. So thank you so much once again, sir. Now please take your seat, please. Now in this sequel, I would like to invite another senior professor, Professor K.C. Prasad. Again, it's my honor to introduce him here. Of course, I am a student of his student. But anyway, that's the opportunity and my pleasure to introduce him. He did his MSc from Patna University and PhD from Ranchi University. He worked there almost more than 36 years or something, 38 years in teaching. And then now he has been coming to discuss over the number theory. Exactly, I am not recalling the topic over which you are going to talk. Of course, abstract should be there, but you feel free to, as you feel comfortable with this audience, so that they can encourage for the future research. Please come here and discuss your topic, please. Professor K.C. Prasad. PPT है कैसे?
20 of this conference. I will take 2 minutes to express my feelings about this conference. Professor K.C. Sinha is there, and I hope he will love it. I am happy to be a part of this August gathering of the International Conference of Mathematical Sciences in Nalanda, the land of great historical events and an ancient sadhana study of knowledge with the largest library of the world, where scholars from different parts of the arrogant world, essentially Arab and China, not Europe, used to visit. In independent India too, Bihar is proud of nurturing several great mathematicians and teachers of highest order, internationally acknowledged for research as well. Few names are, I think, our students and young research scholars should know it. That will enthuse them that Bihar was not much behind as today. Few names are Professor A.V. Prasad, Professor R.K. Chaudhary, Professor V. Rangachari, Professor Nagendra Nath, Professor R. Shukla, Professor S.K. Mishra, Professor S.N. Jha, Professor Bhola Ishwar, Professor K.K. Jha, Professor Prabhat Chandra, Professor D.N. Singh, Professor K.C. Sinha, etc. Due to political upheavals, University of Bihar lost the attraction of bright guys in the domain of mathematics teaching who completed PG and PhD from IITs, NICERS, ISI, IISc, etc. But I believe that now scenario will change. In the decade of 1960, when I was a student of Patna University was rated 6th in the country, and foreign students too used to come here for reading and research. Friends, we have great hopes from Professor K.C. Sinha, who is Vice Chancellor of Patna University too, besides this Nalanda Open University. It's his acumen and vision that the name of this conference, Exploring Excellence in Mathematical Sciences, was accepted and appreciated by the dynamic Secretary Professor D.N. Singh of Bihar Mathematical Society. Finally, I am happy to underline that the young teachers, research scholars and students are really charged and enthused by the enthusiastic deliberations of Padma Shri Professor Bala Subramanian of Chennai, Professor Piyush Chandra of IIT Kanpur, Professor Raj Shekhar of IIT Kharagpur, Professor Om Prakash of IIT Patna, Professor Jagdish Singh of Nigeria, Professor N.C. Ghosh of Calcutta, Professor Kalimuddin of Aligarh Muslim University, Professor S.K. Pandey of BHU, etc. And in the days to come, the research workers present here will try to deliver, that's my belief, something non-trivial. With this prelude, I now shift to my talk of the day. Well, let me thank you for this short routine talk. Well, I will ask Shekhar Suman to assist me prepare my talk, in brief, I wanted to tell you about some of my findings. I appreciate Professor Balasubramanian that I believe he must be a very good teacher. So he was always trying to tell you, or he was always trying to keep you thinking on what he has done. I have not prepared my lecture in that way. I will be communicating you about what I have done in different areas of left-hand approximation. Left-hand approximation of an irrational number. You see, in every neighborhood of an irrational number, consider real line. In every neighborhood of an irrational number, you have infinitely many irrational numbers. But that is, if theta is an irrational number, and h by k is a rational number with h and k co-prime, then what theta minus h by k is less than epsilon has infinity of solutions in h by k. Theta minus h by k less than 1 by lambda k square, where lambda is a constant. The situation changes. Of course, here again, it depends on lambda. If your lambda is large, that is, suppose inequality will hold for at most finitely many rational numbers. Now, that's surprising, and that makes the things interesting. This is the first theorem of a chain of theorems that I am going to consider, and this theorem is called Hurwitz theorem. Let me make a mention that at the time of Hurwitz, the great mathematicians, Lagrangian, etc., they had a strong feeling that there are only few transcendental numbers. But it is deduced from Hurwitz theorem, of course. A student of Hurwitz, Liouville demonstrated infinitely many transcendental numbers. He was essentially a student of Hurwitz, and he follows the thinking approach of Hurwitz. Well, I am going to tell you, by starting, talk is on Markov chain. Markov chain is a sequence of theorems, and this Hurwitz theorem is the first theorem called T1, theorem number 1 of Markov chain. Well, around Markov chain, several problems have appeared, and several tools are used to till this band. Mostly the tools are taken from indefinite quadratic forms, continued fractions, geometry of numbers. You see, linear groups, Fuchsian groups, etc. Markov used indefinite forms, Lagrange, Hurwitz, Perron, etc., several mathematicians used continued fractions in the study of theorems on and around Markov chain. We also work with, that is myself and my students, also work with simple continued fractions. All of us know what a continued fraction is. It is taught in class 8 also in the name of Lagrange bin. We call it Lagrange bin. You see, an expression like this. Yeah, an expression like this. This one, A0 plus 1 upon A1 plus 1 upon A2 plus so on. Well, given a finite Lagrange bin, given a finite simple continued fraction, everybody knows how to find its value. We will start solving, we will start tabulating its value from below, and then finally we will get a rational number. Here A0 is an integer, and A1, A2, etc. they are positive integers. So its value will come out to be a rational number. Even in class 8 I remember that students are taught to find, students are asked to find the value of such finite simple continued fractions. Now, well, we are going to consider irrational numbers. Now, the same process is used to find the simple continued fraction expansion of irrational numbers. The process depends in separating integral and fractional parts of theta and repeating the process with a reciprocal of the fractional part. The reciprocal of the fractional part will exceed 1, will be greater than or equal to 1, and the process will repeat, and ultimately we will find an infinite sequence of integers. Well, we have started with an irrational number, and that's why we are getting an infinite sequence of integers, A0, A1, A2, An, etc. A0 is an integer and other A's are positive integers, and we get an expression like this. You see, this is an infinite simple continued fraction. Well, to save a space, this is abbreviated as, you see, square bracket A0, A1, A2, etc. And well, the portions of the simple continued fraction, for one portion is A0 itself, another portion is A0 plus 1 by A1, third portion is A0 plus 1 by A1 plus 1 by A2. You see, fourth one is A0 plus 1 by A1 plus 1 by A2 plus 1 by A4. If you stop at different quotients, A's are called quotients, you get different, you see, parts of the continued fraction as I narrated now. And these parts are called convergence of the continued fraction. A0 plus 1 by A1 is first convergence. About A0 you can say 0th convergence. A0 plus 1 by A1 is first convergence. A0 plus 1 by A1 plus 1 by A2 is second convergence, etc. Nth convergence is A0, A1, A2, so on up to An. That is up to An. We use Rn to denote nth convergence. And the sequence R0, R1, R2, R3, Rn, etc. this tends to theta as n tends to infinity. This is an important finding. And well, this makes infinite simple continued fraction meaningful, and we call it infinite simple continued fraction of theta. In fact, we associate two sequences. One sequence is sequence Pn, of course, described inductively as follows: P0 is equal to A1, P1 is equal to A0, A1 plus 1. Then P2 is described like this: A2 P1 plus P0. P3 is described like value is equal to 1 upon Mn theta Qn square, where Mn theta is sum of two continued fractions. First one is finite and the second one is infinite. The finite continued fraction is 0, an minus 1, a1, and the infinite part continued fraction is an plus 1, an plus 2, etc. Of course, that is like this. Equivalence has been denoted here by C theta. Now, with the help of this backup of notations and background, I can describe mark of chain. Now, the first theorem can be stated as: for every irrational number theta, here capital I refers to the set of all irrational numbers. Now, the first theorem is, you see, theorems are very interesting. First theorem is, for every irrational number theta, for every theta in I, Mn theta exceeds root 5 frequently. Mn theta exceeds root 5 frequently and cannot be increased. You cannot increase root 5 for countably many irrational numbers. That is, for irrational numbers, well, we identify this class. For irrational numbers equivalent to theta 1, that is half root 5 minus 1. This theta 1 is called critical irrational. That is, for these irrationals, those equivalent to half root 5 minus 1, you see, this constant necessitates root 5. If theta 1 is not equivalent to this, if theta is not equivalent to theta 1, then we can increase root 5. That's theorem 2, second theorem of the mathematics. In theorem 2, we say, we get that for every theta in I1, for every theta in I minus c theta 1, well, so I have used here I1 is personal enumerable many irrational numbers, meaning thereby the inequality mod theta minus h by k less than 1 upon under root this 65 plus 9 root 3 by 22 k square. This has infinitely many solutions. This has infinitely many solutions for non-enumerable many irrational numbers. This constant also holds, or this constant also implies infinitely many solutions for that inequality for non-enumerable many irrational numbers. Now I will go to, I've just mentioned that one Lagrange part and their Lagrange part tends to 3 plus 1 by root 2. 3 plus 1 by root 2 is 3.7071. Now this number is important because if you go to L4 you will get a point greater than Hall's point. So this is a new information And the new information is that 3.7071 is a cluster point, of the Lagrange spectrum. That's a new information. And that's why, you see, this theorem has become very important. Well, you see, my one paper, which appeared in International Journal of Human Theory, in World Scientific, now Algebraic, you see, publication, we consider this set I4, A0, A1, A2, and so on, and thank you very much for this outstanding honor.
अब हम लोग ऑनलाइन DIFR बेंगलोर से प्रोफेसर अग्निद बनर्जी का लेक्चर होगा और तत्पश्चात जो है प्रभात चंद्रा सर 5-10 मिनट के लिए कुछ बातें करेंगे और तो ऑनलाइन कनेक्ट करें।
No, it is better. The person who has created the link, we will have to tell him. A person who has made the link. That's no problem at all.
हेलो, आप वो जो एक हाथ की निशान दिखाई दे रहा है, can you see the palm on the bottom line, bottom row, and then there is an arrow mark, up arrow mark.
Right.
Use that. Click that.
Yes, I am saying that. What it says is that Google Chrome does not have screen recording permission of your computer.
Oh, permission.
उमर को फोन करिए ना, परमिशन
गूगल में परमिशन
उमर के फोन कर लीजिए, गूगल में परमिशन जरूर पड़ता है। कौन लिंक बनाया था तुमने? देखिए तुम्हारा
for suggesting the name. So am I audible or should I speak up a bit? Okay, so the title of my talk is Equation, Partial Differential Equation. So I will start with a very brief prelude to this subject. Alright, so somebody needs to keep changing the slide. I'm looking at my PDF instead. So, roughly speaking, I work in the field of partial differential equation and my research covers the following areas. So what is unique continuation problems, which is what I will describe. I also work on regularity theories for nonlinear and parabolic equations. So a basic model to think about would be if I give you soap fill. So the natural question would be, which is like locally area minimizing with a minimal surface. So the principal question is that how smooth such soap films are. So this is typically the theory of nonlinear elliptic and parabolic equations, and the starting point of all of this has been the epoch-making advancement which was set forth in the early 1990s by Georgi, Moser, and Nash. I also work on free boundary problems, which I cannot talk about, and in recent times I have also started finding interest in certain problems that arise in the crossroad of analysis and sub-Riemannian geometry. So as I said, I will now start on my subject of unique continuation. So in a basic course in complex analysis, what we learn is that holomorphic functions, they satisfy the principle of strong unique continuation. So what it says is that if a holomorphic function on a connected domain omega vanishes with all its derivatives at a point, then in that connected component, it's identically zero. And this remarkable property hinges on the power series expansion of holomorphic functions, and it easily extends to real analytic functions. So, and we know that there are several pre-infinity functions, smooth functions which are not real analytic. So we can take a function u, which on the right exponentially decays at the origin, and we can take it to be 0 to the left of the origin. So we see that this is an example of a function which vanishes to all order, but is not identically zero. So smooth functions don't have this rigidity property. So this takes subject of my lecture. So first I will describe what a quadratic differential equation is. It is basically an expression that reduces the function with a weighting order derivative. So there is several notations over here. So here alpha is a multi-line. It means that it is composed of alpha 1 to alpha n. So that basically means that you take alpha 1 derivatives with respect to x1, alpha 2 derivatives with respect to x2, up to alpha n derivatives with respect to xn, and it doesn't really matter in which order you derive. So this is a fundamental property in analysis. So the number k, it is the sum of these entries of this multi-index, is the order of the PDE. And when a PDE is linear, there are several examples. The prototypical partial differential equation is the Laplace operator. So what you do is that you compute the Hessian, which is the matrix of second derivatives, and you take the weight. So that defines the Laplace. Right? The solutions to Laplace x equals to 0, as this are commonly called harmonic functions. And what one typically studies in the first partial differential equation is that, like for holomorphic functions, harmonic functions are real analytic. So once you have real analyticity, then the partial differential equation is no longer relevant. It's a basic property in analysis that the strong unique continuation property exists. Now there is a classical result of Hadamard, which says that if you get every second order linear elliptic PDE with real analytic coefficients, they only admit real analytic coefficients. So therefore the principle of strong unique continuation exists. So given all of this, what we see is that the question of the strong unique continuation in the context of partial differential equations is often more interesting in situations where the solutions don't have real analytics, where the operator does not admit real analytic solutions, right? But nevertheless, you can still expect rigidity property because the equation enforces certain constraints. So that is what I would explore during this talk. So first I will introduce some basic points. So we say that a function u vanishes to infinite order at a point if it decays more than any order polynomial at that point. That is, the point is, in this case, the concern point is x0. Now this is a very robust notion to have because many a times we deal with partial differential equations where the solutions don't admit smooth solutions. But in the case when the solution is smooth, then this is the same as having that all the derivatives of u vanish at that point. So it can be easily seen to be equivalent by Taylor expanding u. Now a partial differential operator is said to have the strong pre-continuation property, which I will abbreviate as SUC, if non-trivial solutions to Pu equals to 0 cannot vanish to infinite order at any point in the connected point. There is also a related notion of weaker unique continuation property, which is as UCT, essentially states that trivial solutions cannot vanish in an open subset. So once we know that, so non-trivial solution vanishes in an open subset, for this shifted operator, that this B is highly oscillating. Now in the case when B is 0, one can show that for Laplacian in any dimension or minus Laplacian in any dimension, there exists no positive L2 positive eigenfunction. Why? Because you take the Fourier transform, and what you see is that then at the level of the Fourier transform, the function has to be supported on sphere, and that will violate the Planck-Chenard theorem, which is about L2 isometric Fourier. So that cannot happen. But if you shift it to take these p-order perturbations of the Laplacian, then L2 eigenfunctions can exist. Okay, because that changes the positivity in a very dramatic way. Now, on the other hand, there is a selected theorem of Rayleigh. So what I said is that in the case of Rn, you cannot have an L2 eigenfunction. But my argument of taking the Fourier transform or any other parallel argument, or the simplest argument that one can think of, would not work if I have a punctured domain. That is, if I have a complement of a ball, my argument would not work. So, in that, there is a celebrated theorem of Rayleigh which says that you cannot have positive eigenvalues N2 positive eigenfunctions for minus Laplacian in any punctured domain. Okay, so this is a very fundamental theorem of Rayleigh. And what turns out is that if you have the potential V is compactly supported, then if you are able to prove unique continuation property for this perturbed operator, and if you combine it with this theorem of Rayleigh, in the case when V is compactly supported, then one can show that N2 eigenfunctions cannot occur for this shifted perturbed operator in the whole of R. So now there are several, the most basic method of proving continuation goes back to the work of Kahneman. So what Kahneman did is that he derived an estimate that I will describe it while, using which he was able to show that this operator, which is minus Laplacian plus B, where B is L infinity, satisfies strong unique continuation property. So this is a remarkable property, right? Because if you don't have V to be smooth or real analytic, you cannot expect the solution to be real analytic either, right? So therefore, what it says is that those examples of smooth functions that I had in the first slide, which is like 1 by x when x is bigger than equal and 0 when x is less than equal to 0, such functions cannot occur as solution. Okay? And Kahneman's original idea is based on weighted a priori estimates of this type. So this alpha is typically the vanishing, and the remarkable property of this estimate is that, this estimate in red is that this alpha is this constant is independent of alpha when alpha is large, and this alpha expresses the vanishing order of the solution, because otherwise you cannot integrate this term up to that order, right? Because if you have a large negative or a large alpha, then mod x to the minus alpha is not near 0. Okay? So alpha typically expresses the vanishing order of solution, and in unique continuation problems you assume that the solution manifests infinite order. So you have to let this alpha go to infinity. So you better want this constant on the right to be well behaved. And that is the non-triviality of this, okay? And it relies on some fixed cancellation properties that stems from harmonic analysis. So is there any question? नहीं ये तो और आगे चला गया है, काफी आगे चला गया है, आप आगे थोड़ा सा ले जाइए। नहीं आप तो पीछे जा रहे हैं, अब आगे जाइए। ठीक है, तब मैं एक काम करता हूँ, मैं इसी से हाँ यहाँ पे रुकी, ठीक है। तो ये वाला जो रेड कलर का एस्टिमेट है, ये मैं बता रहा था, दिस इज द प्रोटोटाइपिकल Kahneman estimate that was discovered by Kahneman in the 1930s, and using which he was able to show the continuation. It's a very non-trivial estimate that cannot be taken as an exercise in a first degree course, not even in any advanced PD, because there are some hidden cancellation properties that are employed over here. Because the non-trivial element of this estimate is that this constant is independent of alpha for all alpha. So now can you go to the next slide? So how do you apply this method? So suppose that you solve this PD Laplacian u equals to VU, and u vanishes to infinite order at 0. So that means that u times the cutoff is a legitimate test function in the estimate. Why? Because then I know that that will be integrable near 0. Because if u is like a constant near 0 or some order polynomial, then I cannot take this mod x to the minus alpha, because the integral would not even be finite, right? You only can integrate it to a. So now if you use the fact that u vanishes to infinite order, what you do is that you plug in u times this pi in this estimate, and you see the first term on the right. If you use the PD, Laplacian u equals to VU, P is bounded, so the first term can be happily absorbed to the left, because alpha is my friend. I will let alpha to be large, okay? So the first term can be absorbed, and then after it, and you see that the second term is only supported in a region where the weight is not even present, right? Because in the second region, mod x to the minus alpha can be majorized by 1. So now if you simplify further, आप थोड़ा सा नीचे जाइए और आगे बढ़िए. What you see is that standard simplification gives you the inequality at the bottom. And this inequality, now what you do is that now you let this alpha go to infinity. So this cannot happen indefinitely, right? For all large alpha, because the left hand side will go to infinity. So unless u is identically 0 in V half. So
इस काइंड कोऑपरेशन टू इंटरनेशनल कॉन्फ्रेंस के लिए। तो जस्ट आई कॉल प्रोफेसर केसी प्रसाद टू ब्रीफ अबाउट यू। सर and Honorable Vice Chancellor Nalanda Open University say something about you.
Okay. I'm really proud of you. मैं एक सामान्य शिक्षक किस तरह से लड़कों को मोटिवेट कर सकता है उसके बारे में आपसे जुड़ी कुछ बात मैं करूँगा। 2 मिनट।
हाँ,
प्रोफेसर अभिनीत बनर्जी अभी TIFR में फुल प्रोफेसर है। He became full professor at a very early age. और इन्होंने जो काम किया है उस आप लोगों ने अभी समझेगा पार्शियल डिफरेंशियल इक्वेशन से जुड़े जो यहाँ पर रिसर्च स्कॉलर्स हैं वो उनको वो इंट्यूस्ड हुए होंगे, वो चार्ज हुए होंगे। और आपने देखा होगा कि किस कैसे प्रॉब्लम्स, चैलेंजिंग प्रॉब्लम्स ये लोग टेकअप कर रहे हैं और उस पर वर्क कर रहे हैं। आप यदि इनसे संपर्क बनाना चाहें तो ये बहुत ही सरल है और ये आपको हर तरह की सहायता प्रदान करेंगे, ये मैं आपको एश्योर करता हूँ। एक घटना मैं ये बताता हूँ जो एक सामान्य शिक्षक भी बच्चों को प्रेरित कर सकता है। ये इत्तेफाक की बात थी, मैं वहाँ मेरा शौक था कि ओलंपियाड के बच्चों को मैं उनके कुछ क्लासेस देता था, उनको कुछ पढ़ाता था। वो 8वीं 9वीं 10वीं के बच्चे होते थे। उसी पर पढ़ाई के क्रम में मैंने ये कहा कि आप लोगों में कुछ मैथमेटिशियंस बनने के लिए कुछ एक संकल्प होना चाहिए। You should develop your career in mathematics. तो इन्होंने अपने पिताजी को बताया, उनके पिताजी ATC में थे, इंजीनियर थे और वो चाहते थे कि इंजीनियरिंग, उनका सपना था कि मेरा लड़का इंजीनियर बनेगा। तो इन्होंने अपने पिताजी को जाकर के कह दिया, छोटे बच्चे थे, जाके कह दिया कि नहीं पापा मैं इंजीनियर नहीं बनूंगा, मैं मैथमेटिशियन बनूंगा। तो उन्होंने कहा कि किसने कहा तुमको? तो इन्होंने मेरा नाम ले लिया। छोटे बच्चे थे, सरल थे, तो वो हमसे आकर के मिले और उन्होंने मुझसे पूछा कि आपने क्यों इसको इसका ब्रेन वॉश कर दिया है। मैं चाहता था कि इंजीनियर बने, इंजीनियर में मैंने बहुत प्रकार की सुख सुविधा वगैरह मतलब जैसे अच्छा लाइफ रहेगा। तो मैंने कहा कि देखिए इंजीनियर्स तो बहुत हैं देश में, लेकिन मैथमेटिशियंस की, अच्छे मैथमेटिशियंस की देश में बहुत कमी है। तो मैं चाहता हूँ कि आप इनको मैंने इनमें प्रतिभा है, मैं उस स्तर पर नहीं हूँ, लेकिन इनमें जो एक आवेश है, चार्ज है, उसको देख करके मुझे लग रहा है कि वो एक बहुत बड़े अच्छे मैथमेटिशियन बनेंगे। तो फिर उन्होंने बंगाली फैमिली से आते हैं तो वहाँ कुछ लर्न ओरिएंटेड लोग होते हैं, ये हमारा सौभाग्य है हमारे देश में। तो ऐसे लोग हैं तो वो मान गए, उन्होंने इनको अलाउ कर दिया कि ठीक है तुम जो करना चाहते हो वो करो। और फिर इसे मैं समझता हूँ कि ऊपर यदि कुछ रिकॉर्ड होता होगा तो ये जरूर दर्ज होगा कि कम से कम एक इंटरनेशनल ऑर्डर के मैथमेटिशियन को मैंने इग्नाइट किया, मैंने कुछ मदद की कि उनकी जो प्रतिभा है वो खुल करके सामने आए। मैंने इनसे कहा है कि आप मेरी इस बातचीत को सुनिए। वो इसीलिए कहा कि यदि इसमें कोई अतिशयोक्ति हो गई हो तो वो उसको सुधार देंगे, और यदि ठीक है, मैंने जो कहा ठीक है, तो वो अभी वो बोलेंगे कि नहीं सर जो बोले वो ठीक है। आप बोलिए।
First of all, sir, I he will tell something about. Sir, first of all, Vice Chancellor of Nalanda Open University and President of this conference will say something about you, sir.
Thank you, Professor Banerjee, the youngest professor presenting talk in this conference. We are thankful to you that you spared your valuable time to be here, of course online. Young researchers will be greatly benefited by your lecture, and your lecture is very thought-provoking, motivating, and informative. Thank you very much for being here, connected online with us.
Thank you.
What is your age, by the way?
Now 35 plus.
35 plus, youngest professor. Thank you so much.
Thank you, Professor Dr. Amit Banerjee, that you have delivered lecture here, and research interest of the Amit Banerjee. It is I know about from the link regularity theory for nonlinear elliptical and parabolic partial differential equation. Second one is free boundary problem. Third one is potential theory, and fourth one is unique continuation problem that have written on your website. तो हम लोग सभी लाभान्वित हुए. I just K.C. Prasad wants to something regarding, you may tell something about the K.C. Prasad and about the conference for 2 minutes.
So you want me to say something?
So something about the conference.
Correct. So can I speak? Can I speak? I think
no, you may tell.
Okay. So first, I would like to thank Professor K.C. Prasad for his very kind words, and whatever he said, that was exactly the case. In fact, I don't think I would have done mathematics if it was not his presence. क्योंकि उस टाइम पे जब हम लोग थे, the way he started all these Olympiad camps, that was the principal motivation for me to pursue a career in mathematics. और वो मेरे पिताजी को बोले भी थे कि आर्ट बंद करके उन्हें CMI भेज दीजिए. So that was the career decision that I had to take. Even I was not sure about my own mathematical abilities क्योंकि मैं RMO तो qualify किया था, but उसके आगे मैं नहीं जा पाता. So I had also my self-doubt as to what extent I can do. But I think the advice was very good. उसके बाद मैं CMI में गया and I think I have kept contacts with him. मेरे पापा का फिर ट्रांसफर हो गया था पेरेंट्स का, इसलिए उसके बाद हम रांची में गए थे. So our contact has been rather very sparse and not so sort of. But nevertheless, I think whatever he said was very kind of him. And at least from this talk, I just wanted to give you an idea that partial differential equations is not just about application, because many times our intellectual curiosity drives the problem and not necessarily how it interacts with the physical world. Many times it's also a coincidence how it sort of relates to various physical applications, including certain quantum mechanics and so on. But hopefully the toolbox that you saw is something that connects harmonic analysis, G groups, which is algebra, and so on and so forth. Despite that, the formulation of the problem being very Euclidean and real. So what I'm trying to say is that different branches of mathematics, no matter how abstract they play a pervasive role all across mathematics and even other applications, related applications as well, that lie in the crossroad of different subjects. So that is to be appreciated.
अपने लेक्चर 15-20-25 जो भी है समय में अपने देंगे, और इसके बाद जो है आपका प्रेजेंटेशन चल रहा है, लेक्चर लंच में जाएंगे और उसके बाद वैलिडिटी सेशन के लिए उपस्थित होंगे। प्रोफेसर गणेश महतो जी।
I welcome respected chairman of conference, Professor K.C. Sinha, DC, Nalanda Open University, Nalanda, organizing secretary, Professor Vijay Kumar, HOD Math, Commerce College, Patliputra University, Patna, Dr. K.C. Prasad, former Professor, Ranchi University, Ranchi, my esteemed colleagues, prize-winning mathematicians, guests from India and abroad, distinguished delegates, representative from the media, research scholars, students, ladies and gentlemen. It is my privilege to welcome you all to 16th session of the BMS. This is a historic moment. The session being held in the Nalanda Open University, Nalanda. Now, I have to deliver my lecture on the topic गीता का सार कर्म ही ईश्वर है. I have wrote a book in Hindi medium, so I wanted to speak in Hindi medium. मैंने गीता का नाम सुना था बचपन से ही. गीता एक अच्छी पुस्तक है, आध्यात्मिक पुस्तक है. रामायण भी आध्यात्मिक पुस्तक है. बहुत सारे ग्रंथ हैं जो आध्यात्मिक पुस्तक के रूप में लिखे गए हैं, ग्रंथ के रूप में लिखे गए हैं. तो मुझे पढ़ने की लालसा हुई कि गीता उत्कृष्ट ग्रंथों में इसका नाम आता है, श्रीमद् भगवद गीता. तो मैंने सोचा कि इसे जरा अध्ययन किया जाए कि इसमें क्या है. जब मैंने उसे पढ़ा और थोड़ा माइन्यूटली उसको सूक्ष्म रूप से जब अध्ययन किया तो पता चला कि इसमें गणित, विज्ञान, यह सब का भी समावेश उसमें है. तो इसलिए उसे मैं अध्ययन करके इस पर देखा. उसमें जो गणित का पोर्शन है क्या है उसको मैं बताऊंगा, और विज्ञान का क्या पोर्शन है. गणित और विज्ञान तो लगभग कहता है कि मैथमेटिक्स इज दी क्वीन ऑफ साइंस, मैथमेटिक्स इज दी क्वीन ऑफ साइंस एंड मैथमेटिक्स इज दी अभी स्मरण से उतर रहा है, एक डिफिनेशन है. खैर जो भी हो, तो मैं अब उसी पर आ रहा हूँ. इसमें मैं उस पोर्शन को मैंने लिया हूँ जो कि इसमें के मैथ के सभी स्टूडेंट हैं, विद्वान हैं, और विदेश से भी टीचर आए हैं. इसमें हमारे एक मित्र जगदीश बाबू भी उपस्थित हैं. हम दोनों बेगूसराय किए हैं और अभी नाइजीरिया में ये वरिष्ठ प्रोफेसर में हैं. तो बड़ी खुशी हुई इनको देखकर. इनसे बहुत दिनों से मुलाकात भी नहीं हुई थी. अभी यहाँ मौजूद हैं अग्रिम पंक्ति में. तो मैंने जो गीता पर लिखा है उसमें उसका हम दो ही चीज को उससे निकाला. पहला जो आत्मा का डिफिनीशन दिए कृष्ण भगवान, उन्होंने कहा कि जिस समय जब युद्ध के मैदान में अर्जुन पहुंचते हैं तो अर्जुन जब देखे कि युद्ध के मैदान में जितने संबंधी हैं, उनके गुरु द्रोणाचार्य हैं, चाचा उनके पितामह वहाँ मौजूद थे, सारे के सारे लोग वहाँ पर थे मौजूद। उनको देख करके उनका हृदय द्रवित हो गया और उन्होंने कहा कि इस युद्ध के मैदान में मैं यह पाप नहीं करूँगा, चूँकि इस युद्ध के मैदान में हमारे गुरु हैं, हमारे चचेरे भाई हैं, हमारे कोई चाचा है, कोई दादा है और मेरे गुरु भी हैं, कोई मामा है। तो इस स्थिति में मैं किसको मारूंगा? मैं तो अपने ही लोगों को मारूंगा, यह बहुत पाप होगा। मैं नहीं युद्ध करूंगा, जिसको मुझे मारना है मारे, मैं युद्ध नहीं करूंगा। तो कृष्ण भगवान बहुत समझाए कि अधर्म का राज हो गया है, युद्ध करना जरूरी है। हे कृष्ण, तुम नहीं जानते, तुम किसी को नहीं मारते हो। तुम जिसको कहते हो कि हम मार रहे हैं वह मारते नहीं हो, इसलिए कि तुम केवल जो बाह्य शरीर है, बाह्य शरीर वह जो है वह बाह्य शरीर, वह प्राण नहीं है, वह जीवन नहीं है। उस बाह्य शरीर के अंदर जो आत्मा होती है, जो प्राण होता है, जो एनर्जी होती है, वही निकल जाता है और बाह्य शरीर मृत प्राय हो जाता है, वह मृत हो जाता है। और आत्मा जो है अजर अमर है, यह न इसकी उत्पत्ति होती है, न इसका नाश होता है, यह अविनाशी है, यह सनातन है, यह सतत रहता है। इसलिए तुम आत्मा जब तुम मारते हो तो शरीर मृत्यु होता है, लेकिन आत्मा जो जीव है शरीर के अंदर, वह जीव कभी नहीं मरता है। जब जीव मरता ही नहीं है, आत्मा जब मरता ही नहीं है, तो तुम किसको मारते हो? तुम किसी को नहीं मारते हो। सारे आत्मा जो है, जब कोई मरता है तो वो सभी, मैं ब्रह्मांड के रूप में हूँ, सारे ब्रह्मांड मेरे अंदर हैं। तो इसका अभिप्राय ये था कि ये आत्मा या प्राण या एनर्जी मरने के बाद वह जो ब्रह्मांड है, जो ब्रह्मांड का वातावरण है, उसी में वह एनर्जी चला जाता है। तो कृष्ण भगवान ने कहा कि आत्मा नहीं मरता है और जीव, वही आत्मा जो है जीव है, प्राण है, कभी नहीं मरता है। इसलिए तुम चिंता मत करो, तुम युद्ध करो। पहले तो अर्जुन ने धनुष बाण भी रख दिया था रथ पर, लेकिन समझाने के बाद कहे नहीं, तुम क्षत्रिय है, तुम्हारा यही धर्म है, तुमको युद्ध करना है और तुम ये मत सोचो कि हम किसी को मार रहे हैं। जब आत्मा मरती ही नहीं है, न अग्नि जला सकती है, न पवन उड़ा सकता, सुखा सकता है, और न इसका नाश होता है, न इसकी उत्पत्ति, ये पहले भी था, अभी भी है, बाद में भी रहेगा। इसीलिए तुम युद्ध करो या चिंता मत करो। हम विज्ञान में और गणित में पढ़ते हैं प्रिंसिपल ऑफ कंजर्वेशन ऑफ एनर्जी। उसमें भी आजकल के जो वैज्ञानिक हैं वो लिखते हैं कि एनर्जी कैन नॉट बी क्रिएटेड नॉर इट कैन बी डिस्ट्रॉयड बट ट्रांसफॉर्म्स इनटू वन अनदर काइंड। ऊर्जा का ना तो विनाश होता है, ना उसकी उत्पत्ति होती है, केवल एक दूसरे से रूपांतरण होता है। कृष्ण भगवान ने आत्मा के संबंध में यही बात बोले कि आत्मा जो है वह नाश नहीं होता है, ना उसकी उत्पत्ति होती है, केवल उसका भी रूपांतरण होता है। एक देह से दूसरे देह में, एक वस्तु से दूसरे वस्तु में वह आत्मा चला जाता है। इसीलिए ये दोनों एक चीज है। कृष्ण भगवान ने जो बोले और जो कंजर्वेशन ऑफ एनर्जी का जो प्रिंसिपल के रूप में वैज्ञानिकों ने कहा, गणितज्ञों ने कहा, यह दोनों एक ही चीज है। अतः गीता में उन्होंने जो कहा ये गणितीय और विज्ञान का विषय है। ये अब आगे उन्होंने कर्म की परिभाषा दी, कर्म की 3 रूपों में परिभाषा दी, कि कर्म की 3 रूपों में व्याख्या की, और उस व्याख्या में सबसे सर्वोत्तम कर्म निष्काम भाव से सेवा करना, निष्काम भाव से कर्म करना, सन्यासी के रूप में कर्म करना, इस कर्म को ही सर्वोत्तम माना और कहा कि यह कर्म ही उचित कर्म है, यह कर्म अनुचित नहीं है, लेकिन बाकी जो दो कर्म है वह कर्म ठीक नहीं है। तो उन्होंने सेलेक्ट किया निष्काम भाव से सेवा करना, कर्म करना। इस कर्म में जहाँ की उन्होंने बताया कि तुम कर्म करो, तुमको उसके फल की चिंता नहीं होनी चाहिए। ऐसे आप कहीं कहीं गाना भी सुनते होंगे कि कर्म किए जा, मत कर चिंता, मत कर ये इंसान, ये है गीता का ज्ञान। तो कर्म जो करता है, कहा कि वो यह कर्म सत्कर्म कहलाता है, यह कर्म त्यागपूर्ण कहलाता है। त्याग के भावना से कर्म करो, सत्कर्म करो, सकारात्मक सोच वाला ये कर्म करो, यही कर्म असल कर्म है। इसी से मनुष्य को मोक्ष मिलता है, मनुष्य का जीवन सफल रहता है। और जो कर्म कम फल अधिक चाहता है, कहा यह फल दिशा विहीन है। लेकिन जो कर्म, यह कर्म जो है ये दिशा युक्त है, लेकिन ये कर्म जो निष्काम भाव से कर्म किया जाता है, जिसमें त्याग की भावना से कर्म किया जाता है, वह दिशाहीन है, वह दिशाहीन कर्म है। और जो वह कर्म करता है जिससे कि लोग कम कर्म करके गलत रास्ते पर जा करके अधिक से अधिक कम समय में फल को प्राप्ति करना, उसके चलते भ्रष्टाचार होना या दुनिया में बहुत सारी चीज गलतियों को उसके अंदर आना, वह कर्म जो है वह सत्कर्म या त्यागपूर्ण कर्म नहीं है, निष्काम भाव से वह कर्म नहीं है। इस दोनों की व्याख्या उन्होंने समूचे गीता में विरत रूप से किया है। अब मैं उसी का जो लिखा हूँ उसको मैं पढ़ रहा हूँ। भागवत गीता गणित, विज्ञान, दर्शन, अध्यात्म, कला से परिपूर्ण है, जिसका पूर्ण विवरण आगे दिया गया है। मानव एक चेतनशील प्राणी है। आदिकाल से ही मानव ने सत्य असत्य, धर्म अधर्म, मूर्त अमूर्त, चर अचर, जड़ चेतन आदि पर काल के अनुसार गहन अध्ययन एवं चिंतन किया। बड़े धर्म चिंतकों ने अध्यात्म का विश्लेषण मानवीय, मनोवैज्ञानिक एवं वैज्ञानिक ढंग से किया है। समूचे ब्रह्मांड में जो कुछ हो रहा है, इस पर दार्शनिकों ने जहाँ तर्क के आधार पर जानना चाहा, वहीं वैज्ञानिकों ने सत्य की खोज, प्रयोग और विशेष ज्ञान के आधार पर करना चाहा। हालांकि शुरू में दोनों के मार्ग अलग देखे जाते हैं, परंतु अंत में दोनों के मार्ग एक ही बिंदु पर मिलते नजर आते हैं। ब्रह्मांड में हर क्षण कुछ न कुछ घटना घटती रहती है, जैसे पृथ्वी का सूर्य की कक्षा में घूमना, चंद्रमा का पृथ्वी की कक्षा में घूमना, उल्कापात, रात दिन का होना, चंद्र ग्रहण, सूर्य ग्रहण आदि घनेरों घटना उपघटना, नियम परिनियमों का विश्लेषण ऋषि मनुष्यों एवं खगोल शास्त्रियों, वैज्ञानिकों ने अपने ढंग से किया है। प्राचीन काल में जिस समय विज्ञान का विकास उतना नहीं हुआ था, उस समय श्री कृष्ण ने अर्जुन को युद्ध भूमि में आत्मा और कर्म के बारे में बृहद रूप से विश्लेषण करते हुए वर्णन श्रीमद् भागवत गीता में किया है एवं उपदेश दिया, तथा जो उपदेश दिया उन्होंने यह पूर्णतया वैज्ञानिक, गणितीय, आध्यात्मिक एवं दार्शनिक है। अतः हर दृष्टिकोण से भागवत गीता सर्वोत्तम ग्रंथ है। जब अर्जुन सांसारिक माया मोह में फंसकर कुरुक्षेत्र के मैदान में युद्ध करना नहीं चाहते थे, तो उस समय कृष्ण अर्जुन को उपदेश देते हैं, अर्जुन को बतलाते हैं कि सत्य क्या है, असत्य क्या है, धर्म क्या है, अधर्म क्या है, मोह क्या है, मोक्ष क्या है, भक्ति क्या है, पूजा क्या है, सेवा क्या है, मानव क्या है, ईश्वर क्या है, दानव क्या है, भोगी कौन है, योगी कौन है, धर्म कर्म क्या है, धर्म क्या है। इस पर कृष्ण भगवान ने बृहद रूप से अर्जुन को समझाया है। एक बार दुर्योधन भी क्रोध में आकर कृष्ण भगवान को डोरी से बांधने चला, तो कृष्ण ने दुर्योधन को अपना विराट रूप और दिव्य रूप दिलाया और चमत्कारी रूप से दिखाकर उन्होंने दुर्योधन को समझाने की कोशिश किया है कि ब्रह्म क्या है। कृष्ण भगवान ने बतलाया कि सारा संसार मुझ में लय है, मैं ही ईश्वर हूँ, ब्रह्मांड मेरे अंदर है, नष्ट होकर मुझ में ही समा जाते हैं, मुझसे ही पैदा होते हैं ईश्वर सर्वशक्तिमान है, ईश्वर एक है, अद्वैत है। ये कृष्ण भगवान का कहना था। ये आध्यात्मिक रूप से कहा गया है ग्रंथों में, लेकिन वैज्ञानिक और गणितज्ञ इस चीज़ में थोड़ा हट करके सोचते हैं। जो अपने को ब्रह्मांड मान रहे हैं, वैज्ञानिकों आध्यात्मिकों ने माना इस बात को, लेकिन वैज्ञानिकों ने और गणितज्ञों ने इस बात को कहा कि इसको मैं नहीं मानूंगा, और उन्होंने कहा कि ब्रह्मांड को मैं मानता हूँ और कुछ भी घटना उपघटना कर्म समूचे संसार में, वर्ल्ड में, ग्रह उपग्रह, जहाँ कुछ भी हो रहा है, जहाँ गति है वहाँ बल है, जहाँ बल है वहाँ कुछ न कुछ कर्म होगा। तो इसी कर्म के बारे में जो गणितज्ञों ने सोचा, कर्म के बारे में कृष्ण भगवान ने भी बताया, उन्होंने भी इनकी व्याख्या की, और गणितज्ञों ने, वैज्ञानिकों ने भी इसकी व्याख्या की। इसमें थोड़ा सा अंतर यही है। तो हम चूँकि गणित का ही आज ये चल रहा है कॉन्फ्रेंस, इसलिए मैंने भी इसमें लिखने का यही अभिप्राय दिया कि गणित और उसमें से जो विज्ञान निकलता है वह तभी निकलेगा जब हम कृष्ण भगवान को ब्रह्मांड ना मान करके, अगर जो मानते हैं तो मुझे कोई आपत्ति नहीं है, लेकिन ना मान करके गणितज्ञ और वैज्ञानिक इस चीज़ को मानते हैं कि ब्रह्मांड है और एनर्जी कहीं जो भी निकलती है जाती है वो ब्रह्मांड में ही जाती है, वहाँ से ही प्राप्त होती है। और एनर्जी जो है, हम पढ़े हैं विज्ञान में भी कंजर्वेशन ऑफ एनर्जी, और उसको हम लोगों ने व्याख्या भी की है। तो मैं चाहूँगा रास्ते पर जा करके अधिक से अधिक कम समय में फल को प्राप्ति करना, उसके चलते भ्रष्टाचार होना या दुनिया में बहुत सारी चीज़ गलतियों को उसके अंदर आना, वह कर्म जो है वह सत्कर्म या त्यागपूर्ण कर्म नहीं है, निष्काम भाव से वह कर्म नहीं है। इस दोनों की व्याख्या उन्होंने समूचे गीता में विरत रूप से किया है। अब मैं उसी का जो लिखा हूँ उसको मैं पढ़ रहा हूँ। भागवत गीता गणित, विज्ञान, दर्शन, अध्यात्म, कला से परिपूर्ण है, जिसका पूर्ण विवरण आगे दिया गया है। मानव एक चेतनशील प्राणी है। आदिकाल से ही मानव ने सत्य असत्य, धर्म अधर्म, मूर्त अमूर्त, चर अचर, जड़ चेतन आदि पर काल के अनुसार गहन अध्ययन एवं चिंतन किया। बड़े धर्म चिंतकों ने अध्यात्म का विश्लेषण मानवीय, मनोवैज्ञानिक एवं वैज्ञानिक ढंग से किया है। समूचे ब्रह्मांड में जो कुछ हो रहा है, इस पर दार्शनिकों ने जहाँ तर्क के आधार पर जानना चाहा, वहीं वैज्ञानिकों ने सत्य की खोज, प्रयोग और विशेष ज्ञान के आधार पर करना चाहा। हालांकि शुरू में दोनों के मार्ग अलग देखे जाते हैं, परंतु अंत में दोनों के मार्ग एक ही बिंदु पर मिलते नजर आते हैं। ब्रह्मांड में हर क्षण कुछ न कुछ घटना घटती रहती है, जैसे पृथ्वी का सूर्य की कक्षा में घूमना, चंद्रमा का पृथ्वी की कक्षा में घूमना, उल्कापात, रात दिन का होना, चंद्र ग्रहण, सूर्य ग्रहण आदि घनेरों घटना उपघटना, नियम परिनियमों का विश्लेषण ऋषि मनुष्यों एवं खगोल शास्त्रियों वैज्ञानिकों ने अपने ढंग से किया है। प्राचीन काल में जिस समय विज्ञान का विकास उतना नहीं हुआ था, उस समय श्री कृष्ण ने अर्जुन को युद्ध भूमि में आत्मा और कर्म के बारे में बृहद रूप से विश्लेषण करते हुए वर्णन श्रीमद् भागवत गीता में किया है एवं उपदेश दिया, तथा जो उपदेश दिया उन्होंने यह पूर्णतया वैज्ञानिक, गणितीय, आध्यात्मिक एवं दार्शनिक है। अतः हर दृष्टिकोण से भागवत गीता सर्वोत्तम ग्रंथ है। जब अर्जुन सांसारिक माया मोह में फंसकर कुरुक्षेत्र के मैदान में युद्ध करना नहीं चाहते थे, तो उस समय कृष्ण अर्जुन को उपदेश देते हैं, अर्जुन को बतलाते हैं कि सत्य क्या है, असत्य क्या है, धर्म क्या है, अधर्म क्या है, मोह क्या है, मोक्ष क्या है, भक्ति क्या है, पूजा क्या है, सेवा क्या है, मानव क्या है, ईश्वर क्या है, दानव क्या है, भोगी कौन है, योगी कौन है, धर्म कर्म क्या है, धर्म क्या है। इस पर कृष्ण भगवान ने बृहद रूप से अर्जुन को समझाया है। एक बार दुर्योधन भी क्रोध में आकर कृष्ण भगवान को डोरी से बांधने चला, तो कृष्ण ने दुर्योधन को अपना विराट रूप और दिव्य रूप दिखलाया और चमत्कारी रूप से दिखाकर उन्होंने दुर्योधन को समझाने की कोशिश किया है कि ब्रह्म क्या है। कृष्ण भगवान ने बतलाया कि सारा संसार मुझ में लय है, मैं ही ईश्वर हूँ, ब्रह्मांड मेरे अंदर है, नष्ट होकर मुझ में ही समा जाते हैं, मुझसे ही पैदा होते हैं, ईश्वर सर्वशक्तिमान है, ईश्वर एक है, अद्वैत है। ये कृष्ण भगवान का कहना था। ये आध्यात्मिक रूप से कहा गया है ग्रंथों में, लेकिन वैज्ञानिक और गणितज्ञ इस चीज़ में थोड़ा हट करके सोचते हैं। जो अपने को ब्रह्मांड मान रहे हैं, वैज्ञानिकों आध्यात्मिकों ने माना इस बात को, लेकिन वैज्ञानिकों ने और गणितज्ञों ने इस बात को कहा कि इसको मैं नहीं मानूंगा, और उन्होंने कहा कि ब्रह्मांड को मैं मानता हूँ और कुछ भी घटना उपघटना कर्म समूचे संसार में, वर्ल्ड में, ग्रह उपग्रह, जहाँ कुछ भी हो रहा है, जहाँ गति है वहाँ बल है, जहाँ बल है वहाँ कुछ न कुछ कर्म होगा। तो इसी कर्म के बारे में जो गणितज्ञों ने सोचा, कर्म के बारे में कृष्ण भगवान ने भी बताया, उन्होंने भी इनकी व्याख्या की और गणितज्ञों ने, वैज्ञानिकों ने भी इसकी व्याख्या की। इसमें थोड़ा सा अंतर यही है। तो हम चूँकि गणित का ही आज ये चल रहा है कॉन्फ्रेंस, इसलिए मैंने भी इसमें लिखने का यही अभिप्राय दिया कि गणित और उसमें से जो विज्ञान निकलता है वह तभी निकलेगा जब हम कृष्ण भगवान को ब्रह्मांड ना मान करके, अगर जो मानते हैं तो मुझे कोई आपत्ति नहीं है, लेकिन ना मान करके गणितज्ञ और वैज्ञानिक इस चीज़ को मानते हैं कि ब्रह्मांड है और एनर्जी कहीं जो भी निकलती है जाती है वो ब्रह्मांड में ही जाती है, वहाँ से ही प्राप्त होती है। और एनर्जी जो है हम पढ़े हैं विज्ञान में भी, कंजर्वेशन ऑफ एनर्जी, और उसको हम लोगों ने व्याख्या भी की है। तो मैं चाहूँगा उन्होंने बताया, अर्जुन को समझाने तो कई बार दिव्य को अपना दिखाया तथा आध्यात्मिक एवं वैज्ञानिक तर्क देकर अर्जुन को समझाया कि तुम माया मोह में मत फंसो, शरीर नाशवान है लेकिन उसके अंदर आत्मा है, वह अविनाशी है, वह कभी नहीं मरता, केवल रूपांतरण होता है। तुम किसी को नहीं मारते हो, तुम युद्ध करो। इसके अलावा कर्म के विभिन्न रूपों को बतलाया करके जो एरिया का है वो प्लस का है, उसका बनाया है, और अनंत तक में जो उसका फोर्स फंक्शन है और जो डिस्प्लेसमेंट फंक्शन है, वो दोनों से जो बना अनंत तक में, तो वह बराबर 1 इसका हम कर दिए। और चूँकि कोई भी ग्रह जो है वो हम जानते हैं कि केमिस्ट्री में एक है ये प्रिंसिपल ऑफ इसका है लॉ ऑफ ये है whenever chemical reaction takes place with the mass of the reacting substance, mass of the product, मैंने उसमें बताया है लॉ ऑफ केमिकल कॉम्बिनेशन।
थैंक यू प्रोफेसर गणेश महतो जी, जिन्होंने गणित के माध्यम से गीता के रहस्य को और कर्म के बारे में बताया है। तो ये गणितीय परिभाषा इनकी पुस्तकों की रचना की जाएगी, पुस्तक ये अधिकतर ऐसा छप रही है माननीय कुलपति महोदय के द्वारा प्रोफेसर गणेश महतो जी का।
साइड होके कीजिएगा ना फोटो। हेलो हेलो भैया, साइड होके कीजिए ना।
सर के द्वारा अब गोरखपुर से आए हुए हैं और गणित स्कूली शिक्षा पर बहुत काम कर रहे हैं। काफ़ी प्रैक्टिस विषय को सर इनके बारे में 2 शब्द व्याख्या करेंगे।
ये श्री अनूप कुमार सिंह जी हैं। ये कैलेंडर आप लोगों को दिया गया है, इसमें 200 साल के किसी साल 200 साल 1901 से 21 होता है। किसी डेट का डे आप जान सकते हैं 1 मिनट में। हम एक आज का जो डेट है उसको एक्सप्लेन करते रहे, उससे आप उसी तरीके से किसी का भी कर सकते हैं। जैसे 2023, तो 2023 वाला देखिए, जनरल ईयर्स जो लिखा हुआ 2023 में आइए, 2023 इसके रो में आगे आइए, 2023 इसके रो में आगे आइए। नवंबर के कॉलम में क्या है 2023 के सामने देखिए तो सी है। 2023 के रो में आइए और ये नवंबर वाले कॉलम में सी है। अब सी यहाँ नीचे में आइए, A B C D E लिखा हुआ है, सी में आइए और आज का डेट देखिए तो आज का डेट 6 नवंबर, फर्स्ट कॉलम में देखिए आज का डेट 6 नवंबर। अब इसके बाएं आ जाइए, मंडे लिखा हुआ। फिर से हम एक्सप्लेन कर रहे हैं, 2023 ईयर्स वाला में आइए, 2023 वाले रो में, 2023 ये रो है 2023, उसके सामने और आगे बढ़ जाइए तो नवंबर कॉलम जो है मंथ का नवंबर, उसके नीचे देखिए 2023 का रो और नवंबर मंथ का कॉलम जहां इंटरसेक्ट कर रहा है, कौन सा लेटर है? सी है। अब नीचे आ जाइए, A B C D E लिखा हुआ है, F G, सी में आइए। सी में डेट देखिए, आज डेट कौन सा है? 6। सी में डेट 6 नवंबर। अब इसके बाएं तरफ आइए, कौन सा लिखा हुआ है? मंडे लिखा हुआ है।
ये मीटिंग कैलेंडर है, इस एक इस 7 महीने पर आधारित है, 12 महीने पर आधारित नहीं है, ये 7 महीने पर आधारित है। ये
दोनों होता है, इसमें डेट से डे और डे से डेट।